Okay, sure. Hi guys, this is Rahul Jain. I'm a principal data engineer
Good morning,
at
sir.
yeah.
Good morning, everyone, and welcome to today's session on accelerating incident resolution with anomaly detection and root cause analysis. It's my pleasure to introduce our speaker, Rahul Jain. Rahul is a principal data and AI engineer leader at with over 22 years of experience in large-scale data platforms, AI-driven analytics, and real-time processing system. He currently leads architecture for the WebEx Analytics platform, building high throughput pipelines that process billions of events every day. In today's session, Rahul will share practical approaches to anomaly detection and root cause analysis along with real world lessons from production scale environments. Please join me in welcoming Rahul Jain. Sir, you can start.
Hey, thank you very much. Hi guys, this is Rahul Jain. He already gave my introduction, but I'll just go more detail. I'm a principal data engineer at a Cisco. I work in WebEx group. What's WebEx? WebEx is the pioneer in the video conferencing. Yeah, no, Zoom came out of the WebEx, by the way. Um, so today, what I'll cover is cover the escalation incident resolution with anomaly detection and root cause analysis. Idea here is to give how do we reduce mean time to diagnose an event, right? And what we have done, what was an experience we had, it, how do we fix that, right? So driving fast incident resolution in a real time streaming system. um, I also have my LinkedIn profile link and my GitHub link. Uh, this is a slide to, you can scan this barcode and enter this for all the participants, provide a feedback, and win the Amazon gift card. All right, let's start with the real world scenario. I talked about what WebEx does. It provides the conferences, right? WebEx conferences. And there are many Fortune 500 companies are our customer. Let's take a scenario, morning 9 a.m. at US time zone, right? It's a peak hour, right? It's not like mid time, less number of users we have. It's a peak time. It's a morning time where the global startup starts. Globally the startup starts. Everybody wants to join the meeting. There's a rush hour for every organization in the US. So I'll give you some numbers. It's like around 40 million users on the calling side of it who actually calls and dial in and join the meetings. There are 65 million monthly participants who joins the meeting. Since it is a peak hour, there was an invisible incident. There was some quality degrade happen, and our monitoring did not detect that. Why? Why did not detect that? So what we'll talk about in this agenda of this entire presentation is we'll talk about situation. What is the situation we were in? What was the complication we had it? What implication if with that complication and situation we had it? What was our position? What we did that? How we did that as an action? And what benefit we have it? Right. So scale, we're going to talk about scale at a situation by monitoring breaks. We're going to talk about that. Real cost, if monitoring breaks with the scale. what's going to happen. We're going to talk about radar, real-time anomaly detection, and root cause analytics system, how it works, and what we achieve by doing that. So let's dive into situation. So let's see the scale which we work on, right? And this is a scale right now. I'm not talking about pandemic. Pandemic was 10x of what we have right now, by the way. So around 18 to 30 million events per minute we get it. 650 million participants joins the meetings, and 39 to 40 million calling users joins that, right? So if you look at the chart carefully, at 7 a.m., we started getting to traffic. Many people started. So US, Eastern people start earlier, and then we start later in the PST time zone. So from 7 a.m. started, and by the time 10 a.m., we have 10 million, almost 10 million meetings running concurrently. If I say 10 million meeting, on an average, 3 participants in each meeting, 30 million participants per minute, and that events are getting generated. Now, let's assume that if there is a 1% quality degradation, it's going to impact so many customers, right? So that's the situation we are. We have so many users, we have so many customers, we cannot take a risk. System can even have degradation at the 1%. Now, let's talk about the monitoring blind spots. Traditionally, when we create monitoring, standard anomaly detection is, standard deviation or percentage deviation. That's standard way of doing it. But let's look at the scenario, right? We have people connecting the network type as Ethernet, the wired connection, we have wireless connection, either Wi-Fi or cellular, right? Geographically difference, connecting from Asia Pacific region to US in the US region, in the European region. All that has a different latency, right? If you look at that latency on the Ethernet is around 50 milliseconds. On Wi-Fi, it's around 160 milliseconds. Cellular around 300 milliseconds. If I put everything in one bucket, that's people used to do it, and we had done in past also. What would happen is it's going to create the baseline would be higher, right? So there are 2 side effects with that. One, that Ethernet 1, which we supposed to detect it, Ethernet moved from 500 milliseconds to 50 milliseconds to 100 milliseconds. It's doubled, but it's according to this existing monitoring, it did not cross the threshold. It will not notify, and many users using Ethernet will have issue. Will have a degradation on the call experience, but we will not be notified. Whereas other place, cellulars are at the boundary, right? It will create so many false positive notification to us, and engineering team will just spend a lot of time to go and do a root cause, find it out, and say, oh yeah, this is cellular, that's how it's happening, or that's the reason it's happening. That's called notification fatigue. So what it costs? 40% false positive, an hour to diagnose the root cause, what happened with that system, and 200 alerts per week. What's happening? For engineers are getting notification fatigues, right? Customers, till the time we resolve an issue, the meeting is over. right? We're not really helping them. And the real problem is not able to detect, right? So we understand the situation, we understand the complication, we understand the implication now. Now, how do we address that? And that's where our position is radar. Radar is real-time anomaly detection and root cause analytics system. Uh, it at very high level, very simple. We do an ingestion, we do a segmentation. I'll talk more about the segmentation. Why do we do a segmentation? I gave a brief in the situation, by the way, but we'll talk more on that. Then we go and detect the anomaly. This is a time series anomaly and the popularity anomaly, and we'll talk about how that works. Post process, we have to, even though we do a lot of these things, there are certain noise, so we need to reduce the noise, right? So that the engineers are not getting into the notification fatigues. Classifying the problem is it's my problem, it's a WebEx environment problem, is it a network ISP's problem, or is it a customer environment problem or customer laptop having high CPU or high usage on that, or their internal network has some kind of an issue. So once we have that detail, if it's a my problem, we can detect that and create a rebalancing of the meeting. Example, if one of the server was having a problem, one of the region was having a problem, we can start moving meetings to another region which is performing good, right? If the ISPs are having a problem, then we can notify customer and say not customer as well as our client app, saying can you reduce your resolution so that you're not creating a lot of bandwidth, not consuming a lot of bandwidth, and you'll have a better audio experience. Where the video experience, either we stop the video or reduce the resolution to optimize the user experience, right? Something which we can control it, something which we want a better experience. And somewhere we also want to say customers that, there is some problem in your environment. We're still degrading the video. We are stopping video, but we're getting best audio experience on that. So what happened in this process is we diagnose that we detected, time to detect, time to resolve, time to diagnose, time to resolve is become from hours to minutes. So let's talk about ingestion. We ingest, around 30 million events, which are media quality events here in the user quality events. But we do also have some other events. We'll focus on the media quality right now. Then we do a segmentation. Right. Segmentation is generally, if you look at the segmentation, is what I was talking about, network type. Ethernet, Wi-Fi, cellular, geographical region, Asia Pacific region, Europe, US. Further, we break down in terms of country, which country. Some country has a very good internet bandwidth versus some other doesn't have it. Sometimes we do at ISP level. Some ISPs are good. Client type. Is it a laptop or mobile client type? It's certain version of a client type where we did a media optimization. So we kind of go and detect the segmentation. For seasonality models, we use multiple statistical models and seasonality model on that. Very popularly, Halt Winter is what we use. It does a pretty good job on anomaly detection on the time series data with the seasonality, and there are certain parameters which we control it. Noise suspension and all that. So there are two sections in that. One section is, let's say there are some system is under maintenance, right? We know that the system is maintenance. So there are certain events which we can associate. Oh, there are this event. Right now, we just, instead of giving, alert, we'll just give the warning. because their system is under maintenance anyway. Um, Second scenario is there are not enough population or not enough events where we should classify that as a severe issue. So that's where we do noise reduction and other stuff. Root cause analysis is where we detect. I call out. It's our server is having a problem. There's a lot of server CPU spiked up, or our consumers' laptop CPU spiked up. Right? If the CPU spiked up, we do a respective action on the server side, respective action on the app side to have a better experience. Right. And there are multiple severity, channels. We have, different ticketing systems for us, notification for customers, and notification for client to auto optimize itself. So now let's talk about the segmentation, right? I briefly gave you that, we look into different option, and each of them has a different baselines or thresholds. But if I go and create for all this combination, there gonna be so many variation, and that's monitoring that would become a nightmare. So what we do is we look at the past data, we run through different ML algorithm, random forest, and the decision tree, and we come up with a classification saying that these are the optimal group of segments which we need to monitor it. Everything falls into others. Because if the group is so small, it becomes too noisy. If it's too big, we'll have the same problem which we started with. So that's where we use this analysis and come up with an optimal number of groups. Giving you an example for network type combination and other things, network type and region and the device type combination, there would be 82 or more groups. We optimize back to AC. There are 4 groups which really fit well on that. We don't need it. And there is another group, it's called other groups. So everything falls under that. And then we can monitor it. Now let's take an example, because we now splitted that into a small, in the right group. If Ethernet gonna go up, because now Ethernet baseline is around 50 milliseconds. With the buffer, we say 10% up and down or something. If it goes beyond that, we can create a different kind of an alert, different severity. If it goes to 20% up, 40% up, we have the warning. If it goes to 80%, we say we have a severe alert on that. Priority is very high. Somebody has to go and look into what's happening with certain kind of Ethernet things. Right. But then the segment is one thing. We detected the time series segment, right? The next thing the segmentation is done. Now the next thing start is the detection engine. So detection engine, we have one as a time series detection engine, and the second one is a popularity one. Popularity is an extension of a time series, by the way. So the time series, if you look at that, we're looking past 2 weeks or 3 weeks, depends on the data type pattern, and then we look into the pattern and we figure out, this at 9 a.m. Monday morning is what we have traffic like this. So we just compare that traffic with the baseline, which is the previous 2 weeks Monday morning 9 a.m. Not the Sunday, because Sunday would have a different threshold. That's come the seasonality. That's where the seasonality works very well for us. We look at the time of the day, time of the week, and have the threshold for that. So once we have that threshold, we have certain upper bound and lower bound, kind of saying, okay, I have 10% up and down. We're good with that. And that's where our anomaly detection, time series anomaly detection works. We use three algorithm for media experience. The whole winter does a pretty good job. There is another scenario which we use user feedback, the net promoter scores, where user, as soon as meeting is over, we prompt for a user, how was your meeting experience? Rate between 1 to 10, where 1 is bad experience, 10 is a good experience, kind of the feedback we get it. This feedback is very important. We need to know how user is experiencing it, because we know from the server side, we know from the data, from metrics, but sometimes user experience are slightly different. So having that data come into us, we start monitoring that data as well. But that cannot be a seasonality in that nature, or that cannot be suddenly there is a spike on that. It slowly drift, right? Since it slowly drift, we use a different kind of algorithm. And that algorithm basically sees, slowly users her experience, her user responses are going up or down. It generally takes, week or two to you start seeing the trend, right? But so when user experience or user started giving a bad reviews, we start seeing the slope, and that actually signifies, we had with the newer version of a client or something that actually caused that. Once we have that, we do a root cause analysis. We know, what happened before and what happened now. It gives in a very clear picture what has caused that user having a bad experience. And I'll give you one of the example. When we did that, we introduced a new audio algorithm, and it was only introduced to beta customers, and had a bad experience from the user, and that numbers in the metrics was not showing up. So this was a really good use case where we have different kind of scenario and different algorithms to work on that. Now we talked about time series particularly. Now let's talk about the population anomaly. I mean, basically population anomaly. What we're doing is, since we have different segments, we're monitoring different segments. We're looking into all the segments and saying, is this issue is across all the segment? When we see anomaly, it's across all the segments, or it's very specific to certain local. So we call it local versus global anomaly. And that's what it says, is it global, a certain region? We have to look into our server. It's most likely our servers have problem. And again, when we do data comparison in RCA, uh, we will know, we'll see that, right? If it's a very local, then we know, certain group of user or certain group of customers have a problem, and certain ISP has a problem. It really helps that when we look into the global and local versus global anomalies on that. So now let's take one of the decision path. I mean, I did talk about many of them, but let's take this scenario that, okay, we're looking at the bitrate metrics. Bitrate is, how good my data transfers are. Um, the For video, 4K, 2K, 4K video, we need very, very good bitrate. For the audio also, we need a very good bitrate in that scenario. So we look at that bitrate aspect of it. So bitwise percentage drop drastically. Then there are certain segment, let's say call segment as X47, right? Certain segment has an issue. We go and do a classification, which is like the RCA detection, RCA analysis we are doing is random forest. And then we found that, okay, one of our CDN or one of our ISP had an issue. Right. So there's two ways to address the CDN. If the CDN problem, we can, start moving to a different region CDN and start serving that. This basically do a load balancing around on our side automatically. But if it's an ISP issue, we can notify the client, there is an ISP issue. So instead of using 4K resolution, why don't you use 2K resolution? But generally, as a user does not see any experience change, right? But it will instead of having video stop or pause, he'll have a smooth video transition. So he will never have a bad experience. Between 4K to 2K, we did that. User will not notice that. So we talked about our position. We talked about situation, complication, implication, and our position. We did all that thing. Now we have systems up and running. What is giving to us? Let's talk about the benefit. But the benefit what we got is 84% reduction in the false positive notification, because we are now getting a real uh, notification. There are few uh, which are still having a problem, which it's always you cannot correct that. Um, Fast diagnosis, time to detect, time to diagnose, time to resolve has reduced drastically from hours to minute. It's 92% improvement. I mean, one of the key example was where we had 1 hour to do the resolution versus now it's 5 minutes. Alert noise reduction. Yeah, so it used to be 200 plus alerts a week. Now it's like 30, and out of 30, these 30s are most of them are real alerts, real notifications, right? That we do have a different severity on that, but as a developer who's or a site admin who's monitoring the system, he doesn't have a monitoring fatigue. When the notification is coming, he knows that this notification is most likely gonna is a real, and I need to go and take an action on that. By the way, when taking an action, because we have with the notification, we have RCA with that, so he doesn't need to spend a lot of time to do a lot of analysis on that, because again, anomaly and RCA at the same place, right? We combine two systems at one system. So, what's the takeaway? Three things to remember: segmentation before you detect, because all baselines are different for different group of data sets. So, segmentation before you detect. Build explainable classifier. Define your the RCS properly, and it has to be explainable and designed for the scale from the day one. Right. Thank you very much. I'm open for the question now.
No, sir, we don't have any questions.
Okay. Right. I think then we are good. Can stop my sharing.
Okay, sir. Thank you. Thank you, sir, for your interactive session.
Thank you.
Is the session ended here?
Yes, sir.
Okay. Fine. I think we can take up the questions. Or if there is nothing, then we can wait for the other speaker join. While the next speaker is joining, if you have any questions, please let me know. We can answer here. You can have any question, Microsoft Fabric, Power BI, vouchers, anything. Hi Rajesh, good morning, good evening.
Hi, Amit. Hello, everyone. Good morning, and good afternoon, and good evening, wherever you're in the world. So, you want me to share my screen,
Yeah,
Amit?
you share and test it, and then I think in next 5 7 minutes we can start. Meanwhile, those who have question regarding this session, they can start posting, and if they want, they can have interaction also while we are starting this session. Okay. I'll do one thing. I'll just put this on the YouTube right now. Meanwhile, feel free to have interaction with the attendees. Moderator, please be ready in 5 minutes.
Okay, sir.
Anyone have questions or something regarding the sessions or anything, they can feel free to unmute themselves and ask the questions, or they can type in the chat window. Uh, we will be starting soon in this session again. Jaya, Nisha, we see message from Ranjan. Hello everyone, we are going to start in few minutes. Those who are joining from different cities, can they type the cities from where they are joining? I hope most of the people are joining from different cities. Can you type in the city from where you are joining? Welcome everyone. Okay, we Rajesh is joining from Charlotte. Let me type. I'm joining from Hyderabad. Oh, we have from Canada. Rahul is still with us. He's from San Jose. I've been to San Jose in the past. Okay, we have people from Patna also. And how many sessions did you watch yesterday? Some of you watched more than 5 sessions. Anyone who has watched more than 5 sessions yesterday? Okay, those who are on YouTube, they can type on the YouTube. I can check the answers there also. Oh yeah, we have. Okay, we have Nisha watched more than 5 sessions. Ahmed watched all the sessions. Wow, that's great. I think staying us for the entire day was okay. Pressure watched 4. And I think there is someone who watched 3. Manu watched 3. That's great. That's great. I think some of you has watched. I think one of you has watched in the entire session. That's a very real long day. I think we started 7 and we ended by 10. So staying there for almost a day. Oh, Jaya also watched most of them. That's great. That's great. Okay, so it means it's going good, and I think we have a very good topic again: rethinking data model for the Lakehouse era. Make it interactive. Ask as many questions as you can. Okay. I think moderator, you can start with the introduction. Today we don't have any social media contests. We will only be having the DP600, the attendees, and the best question contest will still be ongoing. And from today evening, you can start filling the forms for applying for the vouchers, and we'll try to give you as much as we have here, especially for DP600, 700. We have 40 of them. So we'll be sharing those with you. And please take the full advantage. We have the entire day speaker lined up till 6 p.m. today on this room, and 6:30 p.m. Any certification for participants? We'll try out that. I know the previous one is also pending from the in-person event because we have these back-to-back events. But we will see. If some of you needs it, please let us know on the WhatsApp groups. We'll try to get for you. We'll try to work on that. Means we have the format. We just, I think, not little enough fast to send that out. But yeah, definitely we'll try that. I think speaker certificate and speaker certificates, moderator certificate, attendee certificates. There are a lot of things to be done. And then we have another event at Indore. I'm not sure anybody joining from Indore. We are having an in-person event in Indore on the next Sunday, 17th. So if you have some friends in Indore, do let them know that we have an in-person event on next Sunday in Indore, and it is going to be about real-time analytics and the fabric. Okay. Social media, I think social media form you should have filled. If you have posted on social media, should have filled. Only the form for the voucher should be filled after 6 p.m. because we want at the end of the event you provide your feedback and then you fill the form. So so challenge number 2, 3, 4 is something which you should be doing after today 6 p.m. But any other like social media challenge was still yesterday. Basically, if you have posted today, definitely you can post it because anyway we entered into the last day of the conference. So promotions, whatever we have promoted till now is only going to work out. Please go ahead and fill. Anybody promoted the event on the social media, please go ahead and fill. It's not that we are not going to consider, but we are saying that now if you are posting, it's fine if you are posting, and then if you have that link, please go ahead and fill that. So form 1, there is no limitation. If somebody did not post it, please post it. Anyway, we are going to consider whatever you have entered. But in the form 2, 3, for the challenge 2, 3, 4, we are not going to consider anything which is posted before 6 p.m. because the event was ongoing and we want people to give feedback after that. Okay, and if you have filled it by mistake, let's say if you have filled it yesterday, form 2, 3, 4, don't worry, fill it again at the end of the sessions because we want you to provide the feedback and we want to share that with the speakers also. I remember last time, people liked Chris session a lot, and there were a lot of comments around that, and then we shared with them that how much people are liking your session, and that's why Chris came again this time. He was very busy, and I was, asking him that we need to have a session, and finally he did make to it. So all those things help. Your comments, especially about how did you like the session, and post the event. If you post them on the social media, We can actually keep the post event social media challenge also. I'll ask moderators if they have something in plan. But I think now we are on the top of the hour. I'll hand it over to the moderators. And thanks for this discussion. Uh, Winners will get either DP 600 or 700. So the voucher is either DP 600 or 700. And please remember, this time the vouchers have been restricted not to take any other exam. We have incidences in the past where people have taken other exams. So this time it has been taken care. So you can take either of the exam. But if you are deep into the data engineering, I suggest DP 700. But remember, it has PySpark and KQL. A lot of content comes in. I have given it long back, so but I cannot comment on that. But the only thing I can tell you, it requires deep expertise on PySpark, KQL, and SQL and data engineering. But if you love Power BI, SQL, then DP 600. But if you have good expertise in data engineering, please go ahead. TP700 is going to be a little bit more difficult than DP600. So DP700 is all for the data engineering, DP600 for analysts. The people who are coming from Power BI, like I have came from Power BI and SQL, DP600 is the first step, then DP700. But if you are doing DP700, I think one is sufficient. But if you wanted to do DP600, there is no stoppage. Please go ahead and do that. Okay, so everyone, I'm now want to hand it over to the moderator. Please, moderator, please introduce our next speaker and then please hand it over to him.
Yes, sir, sure. Good morning, everyone, and welcome to today's session on rethinking data models for the Lakehouse era. It's my pleasure to introduce our speaker, Rajesh Vayyala. Rajesh is a principal data architect with over 10 years of experience designing and modelizing enterprise data platform across industries including finance, banking, logistics, and technology. He specializes in enterprise data architecture, lakehouse modeling, cloud analytics platform, and AI-ready data ecosystem. He has led large-scale initiatives using technologies such as Microsoft Fabric, Azure Synapse, Snowflake, and Hadoop, helping organizations build scalable and governed data platform for analytics and AI-driven decision making. Rajesh is also an active speaker and contributor in the data community, regularly sharing insights on modern data architecture and governance. Please join me in welcoming Rajesh Vayyala. Sir, you can start.
Yeah, thank you so much for the intro. Hope you all can hear me and you can see me. So again,
Yes.
good evening, everyone, and thank you for joining the session today. Welcome you all to the Microsoft Analytics Community Conference 4. And I also want to thank the organizers, the Hyderabad Data and AI Community and the India Microsoft Fabric User Group. Thanks for this opportunity. So today we are going to talk about something that is becoming increasingly important across every modern data platform initiative, how data modeling is evolving in the Lakehouse era. So for many years, most of us
Excuse me, sir.
designed, yeah,
Sir, can you please turn on the camera?
okay, okay. How about now?
Yes, sir. Perfect. Thank you.
Yeah, okay. All right, yeah. So for years, most of us designed data models for relatively stable environments, right? We had transactional systems, centralized warehouses, and nightly ETL pipelines, and BI dashboards as a primary consumer. But today, the landscape looks very different. We now deal with streaming pipelines, CDC, AI workloads, semantic layers, self-service analytics, and vector search and data products. So the assumptions underneath traditional warehouse modeling have fundamentally changed. So this session is not about saying the old models are wrong. In fact, one of the key message of this talk is that the traditional models still matter, The challenge is understanding where each model fits, where it breaks, and how to combine them effectively across the Medallion architecture, like bronze, silver, and gold layers. So throughout this talk, we will discuss practical architecture patterns, the real enterprise challenges, common modeling mistakes, and how AI is changing the way data models are consumed. So if you have any questions, you can wait up until the end of the session, or feel free to post in the chat. So let me quickly introduce myself and provide some context for for why I care deeply about this topic. I have spent most of my career working in high volume and highly regulated environments, particularly around financial services, collections, enterprise analytics, and large scale reporting ecosystems. So in these environments, architecture decisions have very long life cycles. A poor modeling decision uh, does not just affect the performance, it affects the governance, the compliance, the maintainability, the reporting trust, the operational scalability, and increasingly AI reliability. So over the years, I have observed that teams, like most teams, don't fall because they lack knowledge of modeling techniques. But most architects already know what 3NF is. They know dimensional modeling, they know data vault. So the real issue is that the organizations often apply these patterns without considering the actual behavior of the domain. So, for example, I have seen organizations implement data vault everywhere simply because it became popular, even when the domain was relatively stable and simple. So, I have also teams force normalized 3NF structures into analytical environments where users need like fast and faster queries for reporting. On the other side, I have seen organizations build wide denormalized tables too early, which created governance chaos and semantic inconsistency. So we'll look into the intentional architecture. Instead of asking which model is best universally, we should ask which model best fits the domain, the layer, and the consumer. So one of the core themes of the session is that the old playbooks were written for a world that no longer exists. So the traditional warehouse architecture assumed the centralized systems, the relatively stable schemas, and BI dashboards as the main consumer of data. In that environment, many modeling assumptions worked extremely well. But over the last several years, the Lakehouse architectures, the real-time analytics, the AI workloads, and self-service platforms have quietly changed the nature of the data ecosystems. So today, the same data platforms may simultaneously support the dashboards, machine learning, semantic layers, or the AI agents, or notebooks, APIs, the operational analytics, the streaming pipelines. So that changes the expectations placed on the data model. So we can no longer assume that a single structure serve like every consumer equally well. We also cannot assume nightly batch processing is sufficient. So the freshness expectations are changing rapidly. So the key here is not that the traditional modeling is obsolete. The message is that the environment around those models have changed dramatically. So let me briefly walk through the structure of the session. So we'll start by discussing what changed in the modern data architectures and why traditional assumptions are under pressure. Then we'll expand the modeling toolbox and discuss 3NF, data vault, star schemas, white tables, semantic layers, the AI-oriented structures. After that, we'll discuss how these models fit across bronze, silver, and gold layers. Then we'll move into the practical decision frameworks instead of debating which model is universally correct. We will discuss how to choose deliberately based on the source system nature, the compliance requirements, the analytical needs, the schema drift, and any operational constraints. And finally, we'll talk about the AI readiness and how semantic layers and the retrieval structures and governance patterns are becoming essential for modern AI consumers. Before we go deeper, I'd like to get a quick sense of the audience. So take a look at the options and drop a number in the chart that best represent the default modeling approach your organization tends to use today. Some organizations are still heavily normalized, others are strongly dimensional, some have moved aggressively into the data vault, and some are using wide denormalized tables heavily. And honestly, many enterprises are using all of them simultaneously. So there is no right or wrong answer here. In fact, one of the key conclusions of this session is to say that the mature Lakehouse ecosystems almost always contain multiple modeling styles working together. So the important question is to not which model exists. The important question is whether each model is being used intentionally in the right layer for the right consumer. Let me look at the chart here. I don't see anything on the themes chart here, but that's fine. So let's go to the next slide. So there are four major forces are driving the architectural rethink. The first is Lakehouse storage itself. So the open table formats like Delta and Iceberg have decoupled storage from compute engines. Historically, the warehouse engine and the storage layer were tightly coupled. So today, the same data may be accessed by Spark, the SQL engines, ML workloads, and AI applications simultaneously. The second force is the real-time analytics. So streaming and CDC pipelines are pushing fresh data directly into the silver and sometimes even gold layers. So the old assumption that analytics data updates once per night is no longer universally true. And the third force is the AI and ML. So the machine learning, the feature stores, the vector retrieval, and AI agents all prefer different data shapes. The same gold layer may feed the dashboards, feature engine pipelines, and semantic retrieval systems simultaneously. And the final one is self-service. Domain teams increasingly build their own marts and analytical layers. So without strong governance and confirmed semantics, organizations quickly end up with inconsistent KPIs and fragmented reporting. So these four forces together are fundamentally reshaping how we think about data modeling. So this session introduces an important mindset shift. So historically, organizations often treated modeling approach like competing religions. So some teams believed only in normalization. Some teams believed dimensional modeling solved everything. Some teams now push data vault everywhere. But modern architectures require a broader toolbox. Different modeling styles solve different problems. So the goal is no longer choosing a single universal pattern. The goal is understanding which pattern best serves the domain, the layer, the consumer, the governance requirements, and the freshness expectations and the operational realities. So throughout the next few several slides, we will explore each modeling approach and discuss where it performs well and where it struggles. Okay, so one of the biggest sources of confusion in architecture discussion is that people use the term data model to refer to different things. So what is a data model? So a data model is a blueprint of the representation of how the tables are linked to each other or related to each other and how they will be physically implemented in a database or a data store. So there are actually three major levels. So the first one is conceptual model, which focuses on understanding the business domain. So this includes the entities, the relationships, the business meaning, and the consumer behavior. So this model is often created to help the non-business folks to understand or non-technical folks to understand how the data will be connected. And the second one is logical data modeling. It focuses on structure. So this is where architects decide whether something should be represented as a 3NF model or a data vault or a star schema or a white table or a semantic object. So this is where we create the entities, the relationships, the attributes associated to the entities, and we'll also implement the normalization. And the final one is the physical data model, which focuses on implementation details such as like the storage engine, the partitions, the clustering and indexing, and for iceberg or delta layouts, where we use the warehouse optimization as well. So the most important orchestration happens in the logical layer, and and throughout this presentation, when I use the word domain, I'm referring to how data behaves logically, how entities change, how consumers access them, and how frequently schemas evolve, whether historical reconstruction matters, whether auditability matters, so that behavior should drive the model choice. So let's begin with the third normal form. So normalization is fundamentally about reducing the redundancy and improving the consistency. So at a high level, the first normal form removes the repeating groups, and the second normal form removes the partial dependency. The third normal form removes the transitive dependency. So the goal is operational correctness. In transaction systems, often referred as OLTP. So this is extremely valuable because updates happen constantly, and you want each fact stored in exactly one place. So you don't want changes for a given record to happen in multiple tables. So for example, if a customer address changes, you want to update it once, not in 10 different tables. So that makes 3NF excellent for operational systems. However, analytics introduce a different pressure, right? The analytics queries often require joining many tables together. As the number of joins increases, the complexity and the query cost increase as well. And the another limitation is history. So the traditional normalized models do not naturally preserve historical states. Updates typically override the existing values unless any additional mechanisms are introduced. So 3NF remain incredibly valuable, but primary for operational correctness and conformance rather than large scale analytical consumption. Let's talk about data vault. So the data vault approaches modeling from a very different perspective. So the core idea is separating the business keys, the relationship, and the descriptive attributes, and the history. So the hub store the stable business keys, and the link store the relationships, and the satellite store the attributes and historical changes. One of the most important principle in data vault is insert only history. So instead of updating records, so new versions are appended. These provide lineage auditability, the traceability, and the schema flexibility. And it also helps with the source integration flexibility. So data vault is extremely powerful in environments with many source system frequent schema drift, and where the requirements for heavy compliance requirements, and where the business definitions are evolving. However, this flexibility comes with a complexity. There are more tables. That means like there are more joins, and if any analyst they want to query, they typically struggle because they need to do more joins against the wall structures directly. So the vault works best as an integration as well as historical preservation layer rather than a direct reporting layer. So this slide helps make data vault more concrete. So the important point here is not memorizing the SQL. The important point is understanding the responsibilities. So where you see the hub represent the business identity, where the link represents the relationships, and the satellite represents changing descriptive information. So a key principle here is that the most mature organizations they don't hand code these structures manually anymore. So tools like DBT, Automate DB, Vault Speed, Waitscape, and many others in the market right now, they often generate much of the repetitive implementation logic. Um, so the real work is not writing SQL. The real work is making good data modeling decisions, and that distinction is very important. Now let's talk about the dimensional in dimensional data modeling, which is often used for building the reporting and analytical layer. We have a star schema and snowflake schema. So here I would like to talk about the star schema, which is widely used and optimized for analytical consumption. So instead of prioritizing the normalization and operation correctness, the dimensional time modeling prioritize the simplicity, performance, and analytical usability. So as you see in the picture, we have a fact table which is surrounded by multiple dimension tables. The fact table store the measurable events like metrics, and the dimension tables provide the descriptive context. So this structure aligns naturally with how analysts think. So the revenue. So for example, here you see the revenue by region, payments, by month claims, or by product. You can actually query, and you will be able to pull all the metrics from the fact table. One of the advantages, the queries become easier to write and easier to optimize. However, dimensional modeling requires deliberate decisions around defining the grain for the fact table. And the second thing is how we're going to handle these slowly changing dimensions. So that is also crucial. Like, so for example, if a customer table have 100 columns, we cannot create ICD slowly changing dimensions or type 2 for all the columns. So we have to work with the business, understand what are the key elements that they want to tag the history for reporting or analytics, and then create the SCD type 2 in the dimensions as such that. So it is not ideal for raw ingestion or for audit reconstruction. The star schema is excellent for like the gold layer analytics, and but not sufficient as the only model across an enterprise lakehouse. So let's look at the white tables. So the white tables are becoming increasingly common in the Lakehouse ecosystem. Especially as organizations move toward cloud object storage and columnar query engines. Historically, many architects were trying to avoid denormalization because the storage was expensive and the redundancy created operational problems. But the modern lakehouse engines changed the economics of the data access. In environments using Parquet format, Delta, or Iceberg, or the query engines can effectively skip columns that are not needed during execution. So that means a table with hundreds of columns does not necessarily require reading every column during a query. So this changes how we think about the joins. In traditional warehouse environment, normalization reduce the duplication, and it improves the storage efficiency. But in the distributed lakehouse environment, repeated joins across very large data sets can become expensive because joins require shuffling data across compute nodes. So as a result, many organizations now pre-compute expensive joins upstream and materialize the flatter analytical structures downstream. So this is where the white tables become valuable, because white tables work extremely well for dashboard acceleration, ML feature engineerings, and for Python notebooks, as well as AI agents, the flat analytical consumption, and for self-service reporting. So a machine learning feature store is essentially a, a highly governed white table, and an AI retrieval layer often prefers flatter structures as well. However, white tables also introduce the important governance risks. So if an organization build white tables without semantic discipline, the duplication spreads rapidly, and different teams begin defining KPIs, or in sometimes they do redefine the KPIs independently. And the columns drift semantically, and the update logic becomes inconsistent. So eventually, there will raise an issue about the trust about the data. So this is why semantic governance matters even more in denormalized environments. And one of the most important architecture message is white tables are usually not an alternative to dimensional modeling. In mature architectures, white tables are often downstream optimized structures. And these are generated from governed star schemas or semantic layers. So this is not a debate about white versus star schemas. Rather, the white structures are frequently downstream products built from dimensional foundations. Here on the left, you see like how the five tables and four joins for every query. Whereas on the right side, you see you have two columns. You don't have to join. The engine never reads the others. So it is 10 times cheaper, is the approximate, or maybe varies widely. So the point here is that people think white is instead of star. It is not white. White is built from star in the gold layer. So the semantic layer ties them together. So the feature stores. So the feature stores are essentially white tables with operational discipline. So offline training environments prefer historical point in time correct white analytic structures. Meanwhile, online inference systems prefer narrow, low latency, current state, fast lookup structures. So the critical architecture challenge is consistency. If training logic and serving logic drift apart, the model behaves unpredictability in production. So this is known as training serving skew. So one of the most important modern modeling principle is define features once, materialize them differently for different consumers. So this is an example of why modeling matters deeply for AI systems. So this is one of the most important slides. So historically, dashboards were often the main consumer of gold models. So today we also have AI agents, the notebooks, the APIs, the ML systems, the semantic search, and all the self-service analytics. Without semantic layer, every consumer redefines business meaning independently. So the semantic layer, which centralizes the metric dimensions, the business definitions, and the governance as well as the business logic. So the physical model underneath can vary. You may use star, white tables, vault, 3NF, but the semantic layer creates a stable business contract about them. And increasingly, this layer is becoming essential for AI reliability. So if you look from a Microsoft Fabric perspective, so the semantic layer is built on the dimensional data model, so which are data model, and which is the delta tables in the gold layer, and then you create the semantic model, and Power BI can be able to connect using the direct connect or direct link, and then the dashboards can consume the data, and the reports can be built on top of it. So again, I don't want to read the syntax here. It is not the important part. The important idea is that the metrics or name definitions are centralized, and the business meaning becomes the machine readable. So when an agent asks for active recovery rate, it should not guess. It should retrieve the approved enterprise definition, and the definition becomes governed and versioned as well as reusable and expandable. So this is increasingly important because AI systems rely heavily on semantic grounding. So one of the biggest misconceptions about NL2 SQL systems is that they somehow magically understand the warehouse schema. So in reality, the strong AI systems depend heavily on semantic grounding. The semantic layer becomes the prompt context. So instead of reading the raw warehouse structures directly, the agent consumes and the metric definitions, the dimension descriptions, and the freshness rules and the governance metadata. So this dramatically reduces the hallucination risk. So without semantic grounding, AI systems just guess, and an agent, it may not work properly as we are expected to work. So this slide, it basically summarizes one of the core messages of this presentation. As the 3NF model, it provides the operational correctness, the data vault provides the auditable integration, and the star schema provides analytical usability. So none of these models is universally superior. Each solves a different problem. So the mistake organizations make it trying to force one model into each layer and every workload. So the modern Lakehouse architectures succeed when multiple models compose together intentionally. So this case study demonstrates a common enterprise mistake. There is a data quality organization. They had many sources and they have heavy audit requirements and complex compliance applications. So they choose a data vault for actually the correct architecture decision. Whereas the mistake came later. So the analysts were pointed directly at the vault structures. As a result, queries became extremely complex and the performance degraded, and there is semantic inconsistency, and there is shadow reporting appeared. So the problem was not data vault itself. The problem was using the wrong data model for the wrong consumer. So the fix was not removing the data vault, but the fix was introducing proper gold layer for the consumption structures. The vault remained the system for historical integration and auditability, and the gold layer star mods became the analytical interface, and this will simplify the analytical usage while preserving the governance and traceability. So the most important lesson here is vault is a layer, but it is not a destination for the analyst to run the queries against. So this slide introduces the bronze, silver, and gold, the gold structure. So where let me quickly go up. Okay. Yeah, so let's look at. So in this slide, I would like to talk about the Medallion architecture, as whether you're using Microsoft Fabric or Snowflake or Databricks. Most of the enterprises across the globe are marching forward to implement Medallion architecture in their data blueprint. So here, the bronze layer, which stores the raw data exactly as it arrives from the source, and the silver is where the data is cleansed, the standardized and integrated. And this layer often behaves like an ODS, operational data store, and focuses on current state. With the gold layer is where data is optimized for analytics and for consumption. So this is where we apply models like star schema and implement the SCD type 2 for historical tracking. So this separation helps balance performance and the historical accuracy. So same entity, three shapes. So this is again often a question that I face at work as well. So there is a borrower entity. It may exist as a raw source, and they have in bronze layer as a hub and a satellite. Sorry, in a silver layer as a hub and satellite, and as a dimension in gold layer. So this is not duplication. It is it is purposefully transformed entity. So the same business entity which evolves structurally across layers, and depending on the needs of integration, the governance, and the history, and for analytical consumption. So this is one of the key mental models modern architects must understand, that though the table is named same in three different layers, the data that exists within the table And the purpose of the table creation in each layer will define for what it can be used for. So now that we have talked about SCD type 2 in the last few slides, so let's talk about it. So SCD type 2 preserves the history by inserting new rows instead of overwriting the existing values. So what happens is when you're reporting, oftentimes the business or the end consumers, they want to do the historical reporting, so what will happen is this allows organization to answer any historical questions accurately. So for example, what was the customer risk level last year, what sales region owned the account at the time, what organization structure existed during the reporting period. So without storing any history, we cannot actually come up with those reports. So and organizations cannot reproduce prior analytical states, right? That's why the SCD type 2 introduces a new row instead of just overwriting the existing data from the OLTP system. So that's why we implement this in the dimensional data model so that the history can be stored there, and it can be easily retrieved based upon the identifiers or the indicators that we have in the table, which later can be help us for simple querying. However, the SUD type 2 can introduce some complexity and some storage growth. So it should be applied selectively. As said, we have to work with the business and we have to identify and track only the attributes that the business genuinely asks the history questions about, or the historical questions about. And there are two commonly confused patterns here, So the first one is the hierarchical versioning. So this concerns changing the organization structures, So when a sales territory or reporting hierarchy changes, should historical reports remain as was or update to the reflect the current structure? So that decision must be made deliberately, And the second pattern is snapshot versus roll forwards. So the snapshots preserve the state directly, whereas the roll forwards reconstruct the state dynamically. So snapshots are easy to query, but more expensive to store, whereas the roll forwards are cheaper to store, but slower and harder to reproduce. So there are trade-offs for each pattern, and we should be careful when choosing which pattern can help your organization and for a given use case that you're working for your data modeling. So there are several major CDC approaches here. I don't want to read each one, but the first one is the watermark-based extraction, which is simple, but it is weak around deletes and out-of-order events. Whereas the second one is log-based CDC, which is typically the strongest enterprise approach because it captures the inserts, the updates, and deletes directly from the transaction logs. So in one of the project that where we are inserting data from Oracle to Microsoft Fabric, we are using the Golden Gate to do the log-based CDC for our data ingestion into the Microsoft Fabric, And the third one is event streams, which provide semantic meaning rather than the raw row differences. And again, the snapshot and the difference remains useful for the legacy environments, that does not support better integration patterns. So most mature architectures actually combine multiple CDC approaches depending on your source capabilities and depending upon your use case. So in this slide, it basically illustrates how the modern streaming Lakehouse pipelines operate. So instead of nightly batch refreshes, many modern architectures move data incrementally through CDC, or they can use event streams. So the bronze can append the pipelines, and the silver layer where you can merge the logic and do the incremental the merge logic incrementals, and the gold layer is where you process, so the key architecture implication is that the freshness expectations are moving further right into the lake house. So the gold layer is no longer necessarily like we have last night data, so that changes how the analytics and the AI consumers behave within your enterprise. So as we are halfway through, again a quick check, so this poll helps, to honestly look on your current state. So many organizations still operate with daily refreshes, so that is perfectly normal. But AI consumers increasingly expect fresher information. So one of the key message here is that the freshness is becoming part of the data contract. So you can just choose which option is your enterprise using, and you can just give post or poll in the chat window. So the platforms moved the line, So modern platforms are converging architecturally, So whether we discuss about the Microsoft Fabric, Databricks, Snowflake, or BigQuery, we increasingly see similar architecture patterns, open storage, shared governance, decoupled compute, multi-engine access. So this means modeling decisions now outlive engine choices, so the model becomes more durable than the platform itself. So what one copy, many engines actually mean? So historically, the warehouse owned the data. So today, the warehouse increasingly behave like an engine sitting on top of the open storage. The same iceberg or delta tables may feed SQL engines, Spark notebooks, ML pipelines, AI agents. So this will dramatically increase the importance of good data modeling, and poorly modeled data now impacts many consumers simultaneously. So before it was just one report is not working or the performance is impacting. But now that you have one copy of data, so you should focus more on your data modeling at that stage as well, so that it will not impact multiple downstream consumers. So modern warehouses increasingly support both structured, the retrieval semantic, and the structured retrieval as well as the semantic retrieval. So the structured retrieval means it handles exact analytical questions, whereas the semantic retrieval handles similarity and contextual search. So importantly, these capabilities now coexist in the same governed environment. So the vector search is no longer necessarily a completely separate stack. That changes how we think about the retrieval architecture as well. So some warehouses like the iceberg or delta tables, and even with the vector itself is a column type now, so we have to be careful when working on these type of use cases about how you can construct your data model. And so again, as we talk about the AI session, so which is about the retrieval quality, which is heavily determined at the right time. And here, so RAG is a modeling problem, right? It is oftentimes it is addressed as a such problem, but there are three different decisions that you can look at. You can look at the chunking, like how you split documents, whether it's a modeling decision, and the second one is about hybrid retrieval. So vector alone is rarely enough, or do you have to look at the other modern stacks, or combine any of the existing any of the newer abilities or capabilities to address the RAG problem, or also you can actually filter the metadata before you retrieve. Not after you retrieve the data, but you can actually filter the metadata. So some of the most RAG failures are actually data modeling and the retrieval architecture problems rather than the pure LLM problems. So this is why governance and the retrieval design are becoming tightly connected when you're dealing with the AI consumers. So now that we have reviewed the modeling toolbox and seen how each model fits across the bronze, silver, and gold layer, so we will move into a more practical part of the talk, how to choose deliberately. And the next few slides give you a decision framework and the pitfalls that quietly look at some of the Lakehouse projects. So this slide basically summarizes how to choose deliberately. So if the domain has a schema drift and many consumers and compliance obligations, so the vault often fits very well. And if the domain is stable and operationally structured, you can use 3NF, which may fit very well. If the goal is to execute analytics and reporting, the star schema often works best. However, if you have like any ML feature stores, the flat analytical access or white tables becomes very useful. And increasingly, the semantic layer sits above top on all of these data models, so that you can actually do the domain-driven data modeling or metadata-driven data modeling, and then have a semantic model sit on top of your data model, which can be further consumed by your downstream consumers. So instead of options, I just named these as three different recipes. So these are just for practical adoption paths. So the first recipe is the lean start first, which works well for any small teams and fast delivery. So if you just have a single source and you have a small team and fast time to insights, you can just add a vault layer. I mean, you can just have a bronze layer for raw and a light 3NF in the silver, and you can create conformal dimensions and fact tables in the star schema. If needed, you can create a vault layer just so for the future. So this lean start first is mostly used by startups. And then we have the wall centered. If you have many sources, if you have like audit heavy and schema drift expected, you can use the data vault modeling here. And then there is a hybrid 3NF plus star, which is for a stable OLTP, BI driven org, and low compliance, where you can use the hybrid, which is a combination of 3NF and star. So the important idea is about sequencing, like which model can fit in your which layer, so that it can evolve over time. So this is a case study that demonstrates the opposite problem from the earlier example. So the organization built star schema directly from bronze without a proper silver integration layer. So initially, this worked well, but as the source systems evolved, the schema changes broke the downstream logic, and the customer identity integration became difficult, and the historical reconstruction became impossible. So the missing integration layer, which is our silver layer, became the bottleneck here. So that's why some enterprises, they often miss creating a silver layer, and they can just directly dump it to the gold layer. But that layer cannot be avoided, which can further don't break your pipelines or your reporting or your AI agents. So one of the most common questions I get from Fabric teams is whether to build in Lakehouse or the warehouse. So honestly, the answer is as usually both, and the choice should be driven by the layer you're working in. and not by personal preference, So the Lakehouse is your Spark native environment. It is excellent for bronze and silver, raw ingestion, schema on read sources, where the integration logic sits and a large volume of transformations happen. So anything you would normally write in PySpark or SQL Spark or notebooks belongs here. Whereas the feature engineering for ML, the vault optimization to through DBT or automate DB, white table materializations, all of these live naturally in the Lakehouse. Whereas the warehouse is your T-SQL environment, so it is purpose built for the goal layer consumption. So if you need like a full T-SQL with stored procs, multi-table transactions, fine-grained role-based security, and merge-heavy SAD type tools, or a Power BI direct lake source. So the warehouse is the right surface, So the star schemas and conform dimensional mods feel native here. So the important thing to remember is that the both surfaces sit on the same one lake storage underneath, and both write to the delta. So the difference is the engine and the developer choice, but not the data format. So the pattern that works in production today is hybrid. So build the bronze layer and silver layer in the lakehouse, where Spark gives you the flexibility and scalability, and build the gold star marts in the warehouse, where T-SQL gives you the governance, the security, and a direct lake source for Power BI. Then connect them using the one lake shortcuts. So there is no copy, no ETL, and just one delta file reference from both places. So if a team only uses one of the surfaces, you are as usually leaving the capability on the table, and the architecture that this fabric is created is designed is to use both for your needs. The other very common fabric question is how to model for batch versus near real-time data. So the architecture pattern is the same. The medallion you have already known, but the ingestion shape and the modeling decisions change with the cadence. So on the batch side, you are typically using data pipelines, the copy activities or data flow gen to land into the lakehouse, and the bronze is Parquet file becoming the delta tables, where the silver is a scheduled merge, as usually a DBT or notebook running on a trigger, where the gold is a star schema in the warehouse, which is refreshed on a schedule. So Power BI consumes through import mode at Red Lake. So the modeling discipline here is about merge keys and water columns, so you can rerun without duplicates. Whereas on the near real-time side, the surface changes, the event stream is the entry point of the streaming data, and then we have the Eventhouse and KQL databases, which are for purpose built for high volume telemetry. For delta-based streaming, you can use the Spark structured streaming, which writes into the lakehouse, and the silver layer merges happen continuously. And then at this near real-time side, you can have the gold layer, which becomes as a materialized views or a streaming table, and Power BI gets fresh data through direct lake or direct query against the event house. So the modeling decision that matters most of the streaming are different from the batch, and late arriving data is normal, so you have to design for it. And there are out of order events which are normal, and SCD by event time is more honest than SCD by load time, So the pattern most enterprises actually run is hybrid. There are slowly changing dimensions which are for batch, and the transactional facts are for streaming. And there is a reference data is for batch, and telemetry is for streaming. So the decision is per table, whereas not per platform. The fabric supports both surfaces in workspace and sharing the same one lake storage and the same governance model. So if you find yourself debating batch versus streaming as if they were competing choices, you are as usually looking at the question from a wrong perspective. So you have to pick the each table and the actual needs, and then the platform handle them. Yeah, as we discussed, I think this is the slide from the previous use case. Where we were not having a silver layer. So the solution for that case study was to introduce a silver properly, where the wall structures absorb the source variability and the gold mods can remain the stable, so this demonstrates why the silver acts as a architectural shock absorber when the source is frequently changing, and also to do the historical data ingestion from bronze to silver. So this slide basically summarizes the common Lakehouse modeling failures. So some organizations skip silver entirely, other creates massive uncontrolled white tables, and others allow semantic drift across marks. There are few they over-engineer the data vault, and the major issue is platform first thinking. So whether it is Fabric, Databricks, or Snowflake, do not automatically determine the right data model. The model should be chosen based on the domain, the behavior, and the consumption patterns. Um, so this slide it basically talks about how the models agents can actually consume. So the AI agents are extremely sensitive to ambiguity, and then we have the conformal dimensions, which became even more important. And the naming convention matters, and there are freshness, contract matters, and the semantic governance matters. And one important insight here is that the AI amplifies existing governance weaknesses. So if the humans struggle with the inconsistent semantics, agents can struggle even more with the inconsistencies. So it is very crucial to fix the model before you actually have uh, the data ingested, so that the downstream cannot have a major issues. AI files differently than dashboard files. So this, I don't want to just, with the interest of time, I don't want to spend much time on this slide. But slide is mostly talking about, so if your dashboards fail with the way how the model is built or how the data is ingested, it says that the AI systems fail very differently, and that can impact the reporting as well as the predictions the AI models can do, and it can also impact your business operations. So again, this is from the previous slide, and it shows that how the AI agents actually look like, and how the many traditional warehouse naming conventions are highly compressed or cryptic, whereas the AI systems often misinterpret them, and it can create a bottleneck for your AI reliability or AI use cases. This slide it basically ties the entire session together. So these principles themselves they did not disappear. We still have to confirm the dimensions. We have to preserve the history. We have to governance the semantics, and we have to optimize the consumptions. So what changed is the consumer, from business users looking at our reporting and dashboards. Now we have agents that consume the same goal structures that were previously used by analysts. So that increases the importance of the semantic clarity and freshness and the retrieval and how you design your governance. So this slide basically is about where your organization currently is, and where is the current maturity. So most organizations today are somewhere in the middle. So you just have to look at your architecture and see how you can actually improve for the coming up AI use cases that you will be dealing with. So this basically summarizes the 5 major takeaways. So the Lakehouse expanded the modeling toolbox, and there are different layers that deserve different structures. and there are white tables or for downstream optimization patterns, and we have the semantic layer, which is for increasingly the governance contract. And then the modern architectures must increasingly design for AI consumers as well as human consumers. So I always like ending sessions with the practical actions. So the first recommendation is auditing the naming quality in gold layer. The second one is identifying the semantic inconsistencies around KPIs, and the third one is honestly mapping what your bronze, silver, and gold layers actually contain. So many organizations discovered that their implemented architecture differs dramatically from the reference architecture diagram they present. So when they started, they presented a high-level architecture diagram to their enterprise architects or the technical leads. But after 6 months or 1 year, if you go and if you actually look at your the database, you can see a completely different architecture that has been implemented. So as you go Monday to your work, you can spend some time look at your architecture that has been implemented and see how you can optimize it for proper modeling, data modeling decisions, and how it can impact your reporting and analytics and the AI usage. So I would like to open it for any questions. Uh,
Hi, sir. We have a question from Rashmita. We use different data models like normalized tables, denormalized tables, and data vault together. How do you decide what data should be combined into white tables early and what should be handled later in the semantic layer so that we get good performance without wasting storage or losing governance?
Yeah, that's a good question. Thank you so much. So for any of the white tables, I decide based on the usage patterns and stability. So if the same joins are repeated frequently, the grain is clear, right? So the business meaning is stable, and the table supports a specific analytical or ML use case. Then it is a good candidate for white table in the gold layer. So for example, if we are looking at a payment daily summary or a customer activity profile or any ML feature table, can be a white because the purpose is clear and the performance matters. But I wouldn't push everything into the white table early. If the definition is still changing, and or if you're still debating on your KPI, or the same attribute is used across many mods, or if you want to look at from a data governance perspective, so I keep it in the confirmed model or semantic layer, because the semantic layer should own definitions like active consumer or recovery rate or net revenue or current balance, right? Because these meanings must be consistent across reports, or notebooks, or even AI agents. So my rule is pre-compute stable, high volume, and repeated access patterns. And white tables are for performance optimization, but not for inventing like the business logic.
Okay, sir, we have another question from Rashmita. How do you make sure AI agents always use correct business definitions and rules instead of raw data, especially when using multiple data systems like Delta or Iceberg?
Yeah, great question. The first thing is we should not let AI agent directly interpret raw delta or like iceberg tables, right? So raw tables are too technical and they're too inconsistency, and often missing the business context. So the right pattern is to put a governed semantic layer between the agents and the physical data. So that semantic layer should define the approved metrics, or where it's the dimensions, the business rules, the data freshness, or the masking and the lineage. So for example, there is an agent that should not guess what customer or the recovery rate means. It should retrieve the certified definition from the semantic layer and generate queries only against the approved gold tables or certified data products. When we have multiple systems like Delta, Iceberg, Fabric, Databricks, Snowflake, or other engines, The storage format is not the main control point, So the control point is the contract about the data, the catalog or governance, semantic definitions, and the certified data models. So what I would do is like the agent should not query the raw data. The agent should query the governed or should query the governed data, and the delta and iceberg store the data, but the semantic layer teaches the agent what the data means.
Yes, sir. We have another question from Bhargav. How do you handle lineage and trust for AI agents? If an agent pulls a definition from the semantic layer that contradicts a raw data field in Iceberg, how do we automate the truth reconciliation?
Yeah, that's a great question again, So I would not let the agent reconcile truth by itself, The agent should not decide whether the semantic layer or raw iceberg field is correct. That reconciliation has to be handled through governance, lineage, and data context, So for example, the raw data represents what source sent, and the semantic layer represents the approved business interpretation. So if they contradict, that is a data quality or governance issue, but not an AI reasoning issue, right? So the first we have to capture lineage from the raw into the silver, into the gold, all the way to the semantic. And second, we have to attach the ownership to each certified metric or table. And then the third one is to create a data quality checks. And then fourth, if a mismatch happens, you have to automatically flag it, quarantine the affected data if needed, and route it to the data owner or the data steward.
Yes, sir. Thank you. We have another question, last question. In a modern lakehouse system, how do you decide what data goes into bronze, silver, and gold layers? And how does the design support both batch and streaming workloads?
Yeah, in a Lakehouse, I decide layer placement by purpose, not just by technology. So bronze is the raw landing layer. It stores data as received from the source systems, whether it's arrived from a batch file, CDC, APIs, as streams. I keep it appended only, source aligned, and minimally transformed so we can replay, audit, and troubleshoot. Whereas the silver is in the integration layer and the quality layer. So this is where we standardize the formats, deduplicate, apply data quality rules, handle CDC mergers or confirm keys, and create trusted entities. And gold is the consumption layer, So this is where like we design for business questions like star schema, white tables, aggregate, semantic models, so on and so forth. So gold should be optimized for reporting, ML, AI agents, and business consumption. For batch and streaming, the design principle is the same, whereas the difference is the arrival pattern. Batch may land as a daily files into the bronze, while streaming or CDC lands continuously to the bronze. And silver process both incrementally, and gold updates through materialized views, incremental pipelines, or streaming tables. So you have to use each layer, whether it's a bronze or whether it's a batch or a near real time, it doesn't really matter.
Yes, sir. Thank you. All done, sir.
Okay.
Yeah,
Thank you
we
again,
already have you,
everyone,
the
for
next
taking
speaker.
time and
Thanks.
for answering, for asking these questions. I really appreciate for attending the session. So if you have any questions, I'm gonna post my LinkedIn here. So feel free to reach out to me, and I'm happy to discuss.
Thanks, Rajesh. Thanks everyone who has attended. We the next speaker, Yug, is already there. Moderator, please take over.
Okay, thank you so much. Right, so let me quickly bring up my screen. Kindly confirm if my screen is visible.
Yes, sir. Visible.
All right, okay. Allow me one more moment to.
Yes, sir. Sure, sir. Meanwhile, I will introduce.
Sure, please go ahead. Yeah.
Good morning, everyone, and welcome to today's session on building generative AI application on Azure with Microsoft Foundry. It's my pleasure to introduce our speaker, Yug Malik. Yug is an associate director at United Health Group, a Microsoft certified trainer and an AI and digital strategy leader with over 17 years of industry experience. He had led AI driven initiatives across healthcare, oil and gas, and enterprise platforms, helping organizations turn AI into practical business value. As a speaker, trainer, and mentor, Hugh is known for combining strategic insights with hands-on implementation to help teams building scalable and production-ready AI solution. Please join me in welcoming Hugh Malik. So you can start.
Sure. Thank you so much again. Hello, everyone. Good morning, everyone. My name is Yug Malik. So I'm an AI practitioner. I have been fortunate enough to be working in the intersection of AI and healthcare for quite some time. And I'm also a Microsoft certified trainer. And what I love about is sharing knowledge with forums like this and helping startups, helping students and the professionals, adopt AI effectively. So that's where my expertise lies. And in today's workshop, we'll more focus on what is RAG. We call it as retrieval augmented generation, and how we build solution around a RAG, right? And I would like to incline towards the enterprise use cases, right? I'll not go much deeper into the technical stuff, although I will show what are the steps that you can take while creating an RAG application in Azure. But my focus would be for this audience to understand once you know what is the technology, what it does, how you can implement. The next question is where do you do where I can implement it? What sort of an use case would be relevant for this AI feature, right? And that's where I will fill that gap with some of the real time use cases that we implement RAG in. Okay. Now, let's start with what happens normally and why RAG, right? So whenever you use any LLM, right, or the normally that you have been using ChatGPT, Copilot, right, or any Q&A that you are doing, so what you do, you type in your prompt, and it goes to the LLM. LLM interprets your prompt and provides back the output. That's how the process pretty much how it goes on, right? But what if I say that what you ask, right, the answer that you're getting is from the public domain, right? But if I needed to have Q&A done on my own document, how that would be approached? Taking an example, let's say you are working in a legal firm, right, and you are dealing with a lot of contracts, right? And generally, what you might have seen, noticed, the contracts are not single pager, right? So it spans for more than 30, sometimes 50 pages, right? And same goes for the financial sector documentations. You can talk about the insurance, healthcare. Those are the document heavy industries where they deal with a lot of documents in each of their processes, right? Now, coming back to the example of the legal, if I have to do a Q&A on one contract, which is more than 50 pages that I have in my hand or in the digital format in my laptop, and I need to do a Q&A on that, and I want the LLM to only provide answer against that particular document, how do I go about it, right? And that's where the the concept of RAG comes into picture. comes into picture, right? So what happens when you have RAG implementation is when you do a Q&A, right? Meaning when you post a query to the LLM, right? Or you just prompt it, then it goes and retrieves your document, retrieves information from your document. What it means, it does a semantic search on your document and it finds the relevant answer, relevant piece of information that could be something you are looking for. And once it retrieves that information, it provides back to the LLM, and the LLM does the data massaging and the format and everything to provide you an answer and as an output to the user, right? So this is the area that we'll more focus on now, right? So we will provide some input, or we will see how in the enterprise, what sort of an use case where we provide the input, how this the retrieval happens, how this vectorization happens, how this semantic search that I talked about, which search on the document, on your document, provides back to the LLM, and then the output is sent back to the user, right? So we'll cover in today's session this portion of it. Now, to carry out uh, in the context of Azure, right, or Foundry for that matter. Now, what you see on the screen are the resources that we'll be using, right? So we will be using one storage account, which is nothing but where your data is getting stored, your document will get stored, right? And then we will go for OpenAI because, as I said, the uh, LLM is where your uh, moderator. I think my one voice is getting echoed. If you can check it, probably people are not on mute. Yeah. So we will see how the OpenAI uh, resource can be are getting used, and then we have this Azure search. So these are the resources that we'll be creating within Azure, and then we will get into Azure Foundry and see how those connections are built, how those services are getting reflected in the Azure Foundry, and then we'll see some of the real time use cases where it is getting implemented on. Okay. So what I'll do from here on is I will log into my Azure account. We'll start creating the resource group, as you said, the resource group, the storage account, then the OpenAI, Azure OpenAI services, and then we'll deploy the model in the Foundry, and then we'll do the Azure service, right. So that's the 4 or 5 step process we are going to follow from here on. All right. So I will create a new one. So this is the portal that I have. I'm logging into, which is nothing but the Azure portal, wherein I will first create the resource, which we call it as the resource group. So this is how I'm just follow the steps. If you are already in the Azure platform, if you want to learn on the go, then you can follow the steps that I'm doing. So here, few of the groups are already been created. So I'll create a fresh and new resource group for this workshop. I'll name it as group. So I'll just provide the name of the resource group. I'll leave the region as it is, whatever is coming by default. I'll go ahead and create it. So remember, we created a group called RG, which is the resource group -RAG -demo2, right? Now I'll click on create. There you go. So the resource group is created. Now we will create all the resources from here on under this particular resource group, right? The first resource that I'm going to create is the storage account. All right. So I'll create a storage account. I'll select the resource group that we created now, and then I'll name the storage account something like where I'll name it as demo2 hyphen rag hyphen storage. It has to be unique depending on the region that you're creating under. The field can, okay, so it doesn't accept the hyphen, my bad. All right. So I will create this. I'll just keep it as default, maybe that should work. I'll go ahead and create it. All right, so our storage account is being created, right? It takes sometime around 15-20 seconds for the deployment of the storage account once you click on the create account. So this is where we will be uploading our document since we are trying to create a repo of our own document so that we can do a rag on our setup document. So now the storage account has been created. So we'll go to the resource, and under the resource you see there's something called container, right? And this is where we will add one more container, and container is where we're trying to store our document, right? And you can use when you do the real time, you can take MongoDB, you can go for Cosmos or any other databases as well, right? So for this particular demo, I'm just considering container, so I will name it as ag container 01, and I'll create it. All right, so once you create the container, what I'm going to do is I'm going to upload one of the documents to the container, right? And this is how you can upload. But before that, I'll show you the document that I have with me so that you understand what sort of document I'm going to upload and how it is gonna get vectorized once I upload it. So I'm going to upload a document which you see here. This is a sample policy document, right? And the policy document is of 32 pages, right, as you see here. And this is the document that we'll upload to the container, right? So to do that, I will click on upload. And from here, I will browse the file, select the file that I need to upload, and click on upload button. Perfect. So our document has been uploaded to the container. So storage part is already set. So far we have created the resource group. We have created the storage account, and then to that storage account we have uploaded the document on which we want to do the Q&A, which is through the RAG model. Okay. So the next step in the sequence we have is to create an Azure OpenAI service. So I will create one Azure OpenAI service, right? So here I can select either of it. So I'll go for Foundry because I want this particular service that I'm going to create to get reflected in the Azure Foundry, right? So I will select the resource group that we have, which is the demo2, and then I will provide a name to the OpenAI service, right? So I'll say that RAG OpenAI service demo1, demo2, so yeah. And I'll keep rest of the thing as it is. Maybe I can put this as the project name. I'll make it to RAG, um, project demo 2, so that we refer it back. It is easier for us. And I'll go ahead and create the resource. All right, so it might take 10 to 15 seconds more to initialize the deployment and complete it. So it is getting created as you see here, the one that resource uh, we created. So it is getting deployed. It is in progress now. So maybe 10 more seconds probably. All right, seems to be coming up. Perfect. All right. So we have now created the OpenAI service. Now we'll go to the resource, right? So this is what we created, right? And then I will go to the Foundry from this particular icon. Now, if you see here, now this is, I'm already logged into the Microsoft Foundry, right? The project that we created is rag hyphen project hyphen default demo 2, right? So this is the project that it is appearing in the Foundry by default. All right. Now from here on, you have multiple options to work. Like you can go for creating an agent, explore the playground, find the models to deploy for this particular project, and if you want to use this in your client applications, right, or any of your external application for that matter, this project, right, so you can use this API key endpoint and all the information that you see here, so that all that outcome of this project can be get you can have a integration point in the client applications, right. Now what I'll do is I'll go to the explore playground. Over there, if you see, we have models, right? Now here I will deploy one model, right? So I look for because what we need is the semantic search, right? So that's where I will add a model called text embed. Okay, so from here, right? Yeah. So this is the model catalog, right? So we have ample amount of or number of models that we can choose it from. So in this catalog, you have to smartly choose what model will work for your use case, right? Since we're talking about we're trying to create the RAG pipeline or a demo on the RAG. So here I will be selecting the text embed. Text embed 3 this should do. And then I'll click on the model and then I'll click on deploy. I'll go with the default setting. So we do not want to spend more time on that. Perfect. So the text embedding has been already created over here. Now I'll go back to the Azure, and here I will add one last thing, which is the Azure search. Now this is important because ultimately what we want is the document that we have uploaded already in the previous step. We need a search to get applied on the document, right? And this Azure search helps in chunking the document, right? The vectorization is nothing but the bigger chunk of the document or bigger document, which we saw it had 32 pages, right? It will chunk into smaller units so that when we do the Q&A on that document, the the pipeline is able to find the relevant answer depending on what we are looking for from that smaller chunk, and then provide us the answer, which is quite relevant, right? So this Azure AI search is the AI resource which helps in doing that. So we are going to create one resource here. So I'll follow the almost the same process. You might be already figuring out that adding the new service is almost the process remains same, right? You just need to select which resource group under the you need to create the resource, and you have to provide the name of the resource, which has to be unique for that particular location. So I will name it as brag AI search. All right, I should be good to go. I'll click on create. All right, so if I go to the resource, yeah, so the resource has been created now, which is the AI search resource. Now over here, I will import the data that we have created already, right? So what I'm going to do is I'm going to connect the container, right, which is under the blob storage, and then we have this RAG, and there are a few configurations that we have to go through this. So we have created the service account, which is demo 2. This one we have created the storage account here, and then we have to select the container that we created under the storage account, and that container, if you remember, has the document that we uploaded, right? And then I'll keep everything by default as it is coming. I'll click on next. Seems to be taking a little more time. All right, so I have to acknowledge this. I have to select Open AI. Here I will select Microsoft Foundry. I want this has to be connected back to the Microsoft Foundry. So then this is the project that I need to select, the Foundry project that we had, right? So we had RAG project default demo 2, right? So this is where the connection is getting built up. And then we have to select the model that we created in the Foundry, which is the text embed 3 large, right? So this is what I need to select, and I'll keep it as API key so that we can have the endpoints whenever we want to integrate in the client or external application, right? I think the configuration looks good. I'll click on next. I'll keep it this. I didn't have to do anything here. I will go on, and so this is, I'll put a demo 2 so that we refer. So this is the name under which it will get created. And now the RAG pipeline is getting built. So yeah, so it has been created. If I go to search explore, now what it is doing is it is chunking the document that I uploaded, right? So it is working on that. So in a while, we will see the vectorization of the data. Okay, so if I click on search, maybe I should be able to. Perfect. All right. So if you closely notice this particular screen, right? We have, uploaded a document, and this was the title of the document that we uploaded. This was a policy document for Arjun Mehra, right? Now, below that, what you see is the vector, right? The text is getting vectorized. And these are the chunks that has been, divided into, right? Now, technically, when we now query on this particular document, now the pipeline will look for the relevant answer from that respective chunks that it has been created already. And then the answer will fetch back to get provided to the LLM, and LLM will massage the data and provide back to the user, right? So that's the process that it follows. And this is the vectorization that which is the core concept or core component of the RAG model. All right. Now we're already halfway through. We're well on time. So I wanted to spend next 20 minutes on some of the real-time use cases, right? Now I will show you one application which we have built, and it's a prototype, right? Wherein we're trying to solve. I mean, I'll take one example of the enterprise use case where the document is being processed, extracted, and then how the RAG is being implemented on that, right? So I will try to bring up my next window. Yeah, perfect. All right. Now, this is one part where I'm going to show how the RAG is being implemented. Now, before that, I'll take a minute to explain. So think about a policy holder or a policy document which I uploaded or which we uploaded. We saw that, right? Now, if what if I want to, extract only a few of the information, right? Now, this document, as you already have seen, it was containing 32 pages. I'll reopen the document for your understanding sake, right? Now, if you see, there are 32 pages in this particular document, right? And this document has so many things, right? Now, if I ask you manually to provide me the details like what you see here, right? For example, what is the policyholder name, date of issue, what is the expiration date of this policy, who is the provider, right? Meaning from whom I have bought this policy, right? Then the address of the policyholder, right? And what is the policy number? What is the premium amount, right? If I ask you and handing over this document, how much of time would you take to get me this information? Not less than 5 to 7 minutes, right? And these are 8 to 10 information that I need. Now think about the processor, right? Think about when we submit any claim, right? The claim generally goes with multiple documents attached to it. And the processor who is actually looking into those documents, they need not have to, they just need maybe hardly 6 to 10 details from those documents, as you see here, right? To validate if the document is correct, if it is from the right candidate, it is not a mismatch, if the policy has everything that is needed, or the information is all accurate, and I can go ahead and approve. Now, to approve that request, be it a policy, be it in the financial services, the loan documents you can refer, so I just need 6 to 10 details of that particular document, that particular candidate, or the request before I go ahead and validate. Now, what happens? The bottleneck in the industry that we have is it's manual. It takes a lot of time. Number one. Number two, there are a lot of chances of getting information wrong, right? Whatever that we manually extract, we may not be exactly be able to retrieve all accurate information, right? Uh, and that creates a bigger bottleneck in the further downstream applications, right? So now this, what you see now, is a very simple prototype just to demonstrate in this workshop that you can create an extraction or document extraction, and then there is one feature which is the core feature of what we are trying to focus today is the RAG model, right? So what I'm going to do is I'll upload the same document which we saw, the policy document. Okay. Uh, yeah. So I will upload this policy document, and the same document is uploaded. I'll click on extract. It might take maybe 15 seconds to extract all the relevant information that is needed. And these are the information that you see below, right? Will be something which will be extracted from this document and shown it here. Okay. And also I'll show you underneath what are the services that are being used, how those services are communicating amongst each other to provide all this information with the keeping the context as we have already spent in last 30 minutes. All right. So if you see here, the policy holder name, date of issue, expiration date, provider name, everything has been accurately pulled from, right? And it is from the same document. And now, what if I just need to click on? I need to understand, right? If the policy number is right or wrong. So I just need to click on this. It will tell me which part of the document this policy number was fetched from. Number one. Number two, it also highlights you. Now, for a manual processor, it becomes very easy for them to tally that the left information which got extracted is matching exactly in the document that I have uploaded, and which part of the document it has got extracted from, that also gets getting mapped. Okay. Now, beyond this, let's say I had all hardly 8 to 10 details got extracted. Now, what if I need more information to get extracted from? And that's where this RAG concept is coming to picture, right? So now this is a small chatbot or AI assistant, right? It can do a Q&A only on this document. The practical example that we saw, how we added multiple resources, how we connected those resources until the vectorization happened, right? Now on that particular vectorization, this smart assistant or chatbot will do the Q&A, right? So I will say identify the parties, right? So it is doing the Q&A on that vectorized data, and it provided me all the details of the the people or the entities mentioned in the provided document. If I want to summarize this document, I'll just write it, summarize this document for me in 3 lines. All right. Uh, so it exactly provided me 3 bullet points summarizing what this document is all about, right? And likewise, other information that you need to ask before you go ahead and save this information. Hey, everything is correct. This document looks good, all good. And once you save it, it goes for the downstream application, right? So this small window that helps in a bigger extent in terms of making sure all the information that I'm able to validate and ensure this particular transaction is all safe to go for my downstream application uses, right? So that's the beauty of this sort of an application. The second use case I just wanted to show you is where, again, Q&A, because we're talking about RAG again, keeping the context. Uh, Coming back to the first example that I gave, where I said you had a lot of documents, a lot of contracts, you are working in a legal firm, right? But you do not want you are looking for some information out of you have, let's say, 10, 20 documents, a bunch of documents you have, but you do not know that information is residing in which of those documents. Now manually, if I have to go through and figure out, then I have to open all 15, 20 documents. I have to do a Q&A in the sense control find or do some other mechanism to figure out that piece of information, that part of the clause or some key thing that I'm looking for. And that would have taken a lot of time for me, right? But what if I say that application like this, you just have to upload all the details. Let's say, you know, I have 10 items I just selected randomly though, but consider these are the legal documents, right? And I will click on upload. So it is getting uploaded. Now, what is happening underneath is all these documents are getting vectorized, right? Each document is getting chunked and stored in the vector database. The storage unit that we saw, so this is exactly where it is getting stored, right? And once it is uploaded, chunked, and stored, then we can do a Q&A on these documents. It might take, because I've uploaded all 10 documents, maybe it might take 30 more seconds, I assume, right? But the point is, once we have this, then I can use this chatbot, right, and do a Q&A exactly how you saw in the previous use case, right? I can ask anything that I need, and it will look for all the 10 documents. It will find the best relevant matching answer, and it will provide me back as per the question that I've asked. Right. So that's the beauty. And this is how these are the places where the RAG is getting implemented. The concept of RAG, is in the real time, in the enterprise real world business case is being used and utilized. All right. So now the last part of the story where I wanted to showcase how the solution, I mean, you see in the front end, you have seen how, we covered in the Azure, how we are configuring it. Now you are seeing how in the application where, we use RAG as a concept, and how it is mapped to the real world use case, right? So it's all connecting all the dots. Now, also, I'll bring up the slide back. This is what I wanted to, so I'll just expand it a bit maybe. I hope you can see it. All right. Uh, Moderator, if you can put people on mute. Yeah, thank you. All right. Sorry for the disturbance. So if you see the solution diagram, what it talks about the first pillar, which is the data source, right? In the example that we just saw, we uploaded a document to the application. But in the real time, the document can come from any of these sources, right? I can have this document stored in the third-party storage. I can have a shared drive. I can have database. I can have enterprise applications, right? Or I can have the API for getting the documents, right? It can be anything where from where I can get the documents from, right? Now, once the document I got, right, the second layer is where I need to extract the information from the document. Now, over here, I can use Azure Document Intelligence, right? And then extract the information, and the information, once it is extracted, it gets vectorized. The way that we saw that we uploaded a document, the policy document, to the container, and then from there how the data got vectorized. Now once it is vectorized, this is where in the vector database it will get stored. All right. Now once it is stored, and then we have this LLM out here using the Q&A, or using the prompt or the question that we got from this vector database. The data will get passed on to the LLM will refresh the data or massage the data and send back to the user, right? So now this database is more of storing all the metadata, right? If I have to store anything beyond what I have in RAG, right, for my analytical dashboard or anything for that matter, so I have this database for that. Now the fourth layer is where the human in the loop, right? The screen that we saw before this is nothing but the human in the loop. The data is getting extracted, right? The human in the loop is just there for validating that data, whether the data is correct or not. Only when the data is correct, then the human agent is validating and saving that data for the downstream application uses. Right. And this layer for any AI implementation, I repeat, this human in the loop, as we speak today, is very much important, very much critical for all the AI implementations, be it a smaller or larger enterprise, right? The biggest reason is that any correction or course correction that has to be done through the human layer only. We can't let everything passed, only through AI to the downstream applications, right? The human layer is very much important. And secondly, for the feedback loop. What if the data, I mean, going back to the example that we saw, data got extracted, but if I do not have an human in the loop, then I would never know whether the data got extracted is right or wrong. Now, secondly, when I have the human in the loop, I know which field the data is, coming 90% accuracy versus 80% accuracy or below, right? So that I can do a course correction. Now that course correction is getting captured in this database, that out of 100 transactions or documents that I have processed, out of that, which of those documents and against which of those fields I had course corrected, right? Now that essential mean that's a feedback for the engineers to have a look at it. Do I need to fine tune my model for those certain fields so that next time when we process a document, those fields will extract as expected. The data for those fields will get extracted as expected. So that's a feedback in the this a feedback loop which happens, which is very much important, very much necessary, and that can only happen through the human in the loop. I hope it is all making sense, right? And then we have this chatbot is exactly where the RAG model is working, right? So anything the the user is asking through this chatbot, the chatbot is hitting the RAG database, right? And providing you answer via the OpenAI or any model that we have deployed, basically the LLM. So that's how the transaction works. And once we save the data, we verify the data, we use the chatbot to double check the data, then we save the data. And once it is saved, then only the data is getting stored in the, I mean, data is getting used in the downstream application. The last layer is the downstream application. All right. So that is how you build an enterprise solution. And of course, the governance layer, the infrastructure, the network, security, role-based access, right? Those plays, you know, a very critical and crucial part in the any of the implementation, right? Without any governance, if you actually open your AI for production deployment, then what kind of data it is being used, what kind of sensitive data, right? Is it using the PHI or PI information? Is it using some information which was not supposed to be publicly available, right? Not supposed to be leaked. So to avoid those sort of compliance related situations, the governance layer is very much important to have. So any org, small or large, using AI should have a governance model, should have people who should scrutinize the use case, evaluate the use case. Then when we implement it throughout the SDLC process, we should have checkpoints, right, to ensure that the responsible use of AI is maintained across this across the process, right, across the software development life cycle till we deploy the project in the deployment. I mean, in the production. All right. So that's how I just wanted to put my perspective and give you an insight of how it has been, how the enterprise is looking at RAG model, AI governance model, right? How RAG in the real time use cases are being used. So pretty much I've covered. We are still left with 10 minutes. I would uh, open this forum for any Q&A, and then we can wind up. Moderator, if you have any questions that you see in the chat from the audience, or audience, if you have any questions, feel free to ask me. I'll be more than happy to answer. And this is the QR code. I will be very much reachable over the LinkedIn, and happy to connect and discuss further on any of the Q&A stuffs that you might have or anything that you might need help on.
Hello, I had a question.
Sure.
So how does this work with documents that are not in the same format, or they're like, for example, the policies, right? So the one that you shared was from HDFC, ICICI might have some other format, and the details might be not in the same positions or something. So how does it work? Or is it only for policies? Or can other documents also be imported?
All right, it's a pretty good question. So when we design any application, right, uh, we generally can't make it domain agnostic, right? Now, if I'm making it for a policy, then it is recommended to keep it defined within the policy document. Now, the template might change, right? I may not have same template or the structure for all the documents. That is not needed. We have LLMs. We are dealing with the document intelligence system. It is pretty much intelligent to extract uh, the relevant information from the unstructured documents. Okay, so uh, it can also give a pretty good result. Recently, we tried with a very gibberish handwritten document, and it was able to provide us the relevant information. So to answer your query, Saiti, that any unstructured document will work. Any policy document tomorrow, if you upload to this model that we saw or to this application, it will extract the information for you, right? Just that it should not be completely out of context. In case of policy document, you are uploading, let's say, a finance related document or a pharma related document, right? Then it will not have any context against which it has been trained on, right? So in that case, the extraction will not work. It won't have that information in the first place. And secondly, it might hallucinate. So it is better to keep your application within the bound of the domain that you're working in. And against that, you can have multiple formats of documents that you can try and test with, including the handwritten.
Okay. And to follow up on that, how is that different, or what additional features do we have when it's compared to the AI Hub's document extraction that we have in Power Platform?
Okay, so the beauty of the platform, Azure platform, is there are predefined templates available, right? You need not have to always go for a custom build, right? What I mean is, say for example, you are working on extracting KYC information from the Aadhaar card, from PAN card, right? Those are pretty much a document which is standard across the nation. Now, for that, we have predefined models available in Azure Kitty. Okay.
Okay.
Yeah. So I'll take a minute. Maybe I can open and show it to you. Um, yeah. So if I go here, this is the Azure Foundry, right? And okay, so this is a little different. I will select a different project, maybe. Okay. Find models. Maybe this one. No, okay. I'll send you the link, right? I have to navigate through that. The point is, it has predefined models. I was showing you yesterday in the session that I took. So you can use or you can leverage those models for some of the use cases, right? Very standard ones: invoice, tax documents, your cards, ID cards, PAN card, right? Aadhaar and all that. And there are plenty of it actually. So you can make use of that as well.
Okay, sure. Thank you.
I'll share the link maybe. Yeah, sure.
Yes, please. Thank you.
Any other question, guys?
Hi, sir. We have a question in chat box.
Sure.
Does this work with documents that are not in the same format? Example from a different policy maker.
Mhm. Yeah, I think the same question you answered. So it is indeed the format is not a concern, right? The only concern is it has to be a policy document. The information should be relevant, or the document should be relevant to the application intent. Otherwise, there is no constraint, no bound on the format. Any format document, in fact, if you can upload the handwritten document to it, right? If that handwritten document has the content relevant to the intent of the application, bang on, it will extract the information that you need. Does that answer your question?
Yes, sir. And we have another question.
Sure.
How is this different additional feature from the AI up document extraction in Power Platform?
Yeah, I think it is underneath. It is same, right? Power Platform again. I mean, Power Platform. I think AI Builder is being referred here. So it has multiple predefined templates, right? But in Azure, we have Document Intelligence, which is similar to what we have in Power Platform, and it can cater to various type of documents, as I mentioned earlier, and it has all the intelligence to ensure that any nature of document, right, be it an image, be it a PDF, be it a scan document, all the data can be extracted, handwritten, as I mentioned earlier as well. All that can be extracted, and through the LLM the output can be provided back to the user in the right way. So uh, so yes, so Power Platform and Azure, in the context of what we're talking, it has the similar features.
Yes, sir. Done, sir.
All right, okay. Thank you, everyone. I'll be more than happy to get in touch with folks in case if you have any questions over the LinkedIn. And it was great to be here and speaking on it. Thank you so much. Have a great day ahead. Thank you again. Bye.
Yes, sir. Thank you, sir. Thank you for your
Thank
session.
you.
Yeah, the next speaker was trying to join. I think he is facing some issue. He'll be joining soon. I saw him trying joining once. Yes, we have Sathwik with us now. We can start. I think Sathwik is there. I made him presenter. Sathwik, you can share your screen.
Hey guys. Hi.
Hi
I'm
everyone,
audible?
we are excited to welcome Sathwik a data analytics professional currently also associated with Affine with expertise across Microsoft Fabric, Databricks, Azure, Data Factory, Power BI, Tableau, and Cosmos DB. With strong experience in modern data engineering analytics technologies, Sathwik actively works on building scalable data solution and driving insights through cloud and BI platforms. Let's welcome him together and looking forward to this session.
Thank you. And am I audible? Can someone confirm? Am I audible?
Yes, you are.
Are you able to see my screen?
Yes.
Okay. Just a second.
Not able to see the screen yet, though.
It might be. Now, can you see?
No.
Just a second. I'll just stop sharing and I'll just share it again.
Okay.
Yep. Can you see now?
No, not yet. Screen is not visible.
Not yet. Oh my god. Okay. Otherwise, I can do one thing. If it is getting delayed, I can share the PPT with you guys, and one of you can share me the screen. Might be Amit or any other, if you don't mind me asking.
Yes, you can share me the PPT. I'll share my screen.
Sure. Shall I share it in WhatsApp or?
Okay, Sathwik is not able to share the screen. Moderator, will you be able to share the screen, or do you want me to share this PPT?
You can share the PPT with me. I can share the screen.
Okay, I'm sharing on this group itself. Let me see.
Okay.
Sathwik, we can share with the entire group. That's not a challenge. Sathwik, can we share this PPT
Yeah.
with this entire group?
Sure. No worries.
Okay, I'm sharing here. 1 second. Oh, there's no attach option coming here. There's no attach option here. 1 second.
Okay.
Okay, let's see. What is happening? Okay, I'm forwarding on another moderator WhatsApp group. Hold on. Yeah, I forwarded it to moderators group.
Yep. Yep. Thank you. And I can see the screen.
Is my screen visible?
Yep. Yeah. Yeah, you can start the slideshow and
Yes, I can see it.
guys, am I audible?
Yeah, your voice is a little low.
Okay.
Yeah, better now.
Sure. Okay. Yeah,
I think now this would be 1 second. Yeah.
cool.
Okay,
You
fine. I
can
think you
start.
can start. At least on the YouTube screen, I can see the presentation is taking the preference. Okay, and okay, this is view, focus on content. Okay. So everybody prefer focus on content or don't use anything. That should sort out the things for me. Okay, let's begin.
Okay, so basically, I am Sathwik. and I work in the firm called Affine. So Affine is basically specialized in dealing with the data engineering projects and AI related projects, like working on RAG and working on AI models, testing the AI models efficiency, etc. Everything. We have a lot of segments in it, but I'm working particularly in data engineering, where I particularly work for a client, Microsoft, as Affine is the official partner of the Microsoft. And regarding my work, basically, it's kind of an AI engineer, where we are at the verge of losing the jobs for a data engineer and Power BI, right? So my job will focus that kind of scenarios where I work with the data agents or the agentic AI kind of. Have you ever heard of the Copilot Cortex? So basically, Copilot Cortex is one of the agentic AI, where it has 72 agents like data analyst, data engineer, pipeline debugger, etc. Everything, and whatever the task you give to it, it will just accomplish it using the MCP servers. It will directly connect to your Fabric, and it will directly execute the queries. It will debug. It will see what are the errors in the PySpark. It will see what the errors are in SQL. It will write the SQL code, and yeah, it does a lot many things with just simple prompts. So kind of pretty fascinating thing, even for me. Even I'm learning new with the MCP servers, agents, and doing the data engineering, creating the metadata frameworks entirely using the AI, etc. So this is all about me, and yeah, we can go with slides and the topics today. The delta table. The next slide. You can go to the next slide. Delta table. So we all know that the delta table is just like a SQL table, but what's special? What's so special in it? Before jumping directly into the shortcuts, we can easily first see the basics, and we can go in depth. Okay. So what is a delta table? It's just a normal SQL table. It has time travel. It has ACID transactions. This is what everyone knows. But in Fabric, what exactly a data engineer will see? Basically, a data engineer will go to a specified storage location and check for the delta log, the metadata, and the partitions. This is all regular life of a data engineer will generally occupy with. Okay, so a delta table, it is just a table with the delta log. What is inside the delta log? Inside the delta log, there is again a JSON file which holds all the related data with multiple columns, where you can see the data at a particular point of time, at which time the inserts are done, at which time the deletes are done, and at which time overwrites are done. It has some version history, etc. Next, we have the metadata. What's inside the metadata? Even inside the metadata, you have the JSON file, but mostly it is related to the columns. All the columns data will be present inside the JSON file of the metadata folder. And then we'll be having the Parquet files. The Parquet files is where the actual data. If we do any partition or create the condition of the partition, then a partition folders will be created, and inside that we have the Parquet files. So this is what a general look of a delta table looks like. But what if, like, the delta table is accessible in Fabric, but it is not controlled completely by Fabric? So this is where the shortcut tables comes into the picture. Okay, so the shortcut tables are basically kind of a fancy name which we are trying to use these days. Basically, we have two types of tables: external tables and managed tables. Managed tables are inside the Fabric, and external tables are at a particular location in general terminology. So those external tables we call as the shortcut tables. So the shortcut tables, why shortcut tables? Because there is a table at a particular location, and you want to access the table at multiple workspaces or at multiple notebooks, and give that data to multiple places at the same time, then the link inside the Fabric terminology is called the shortcut, and we call it the shortcut table. And coming to the shortcut tables, when I say the Fabric manages it, but not completely. So basically, whenever you do an update, delete, or overwrite, Fabric does the operations, but you can't delete the table actually. So whenever you delete the table in the schema, then the external location they which is referring to the ADLS Gen 2 or S3, the external location, the table will be staying the same, but only the schema, the icon will be removed. That means like generally the table will be deleted. Okay, deleted as in only the shortcut icon will be removed. But at the ADLS Gen 2, you will have the actual table. So that is one main property of shortcut table. Uh, if you ever tried using the shortcut, go to the Lakehouse, and inside the schema, if you just delete it, it will just vanish from the schema. But in the ADLS Gen 2, you will always have the table. So yeah, there are some properties for the shortcut table. Like a regular, you can stay in the shortcut table for a few moments. Yeah. So basically, we have the delta table, where inside the delta table we have the Parquet files, and for the Parquet files, whenever we do the updates and deletes, you will have a deletion vector inside the delta table. So that is one property of the delta table, and similarly, the shortcut table will also have the same. Whenever you do some updates or deletes, even the shortcut tables have the same deletion vectors, same properties as the delta table. But where the shortcuts actually solve the problem. So whenever in real time you're trying to operate on some Medallion architecture or any kind of idempotent architecture, you will have a single source of truth. This shortcut table is stored at a particular ADLS Gen 2 container or a particular location, will be considered as a single source of truth, and this table will be serving for all the departments or all the multiple places, whatever the business scenario is. You don't need to always create a replica of it and try to operate on it. You can create a one table and manage the permissions. Whoever can write or whoever can read, you can just manage the permissions and just share the same location to multiple departments. This is not just the one of the benefit, but it has many benefits in real time. So consider an incremental load. So inside Fabric, if you want to create it as a managed table, the cost is comparatively a little bit high when it is as a shortcut table. So why? So basically, Fabric has its own, you pay for the capacity and you pay for the storage, both, right? Whenever there is an incremental load and you need the table at multiple places, there is some cost associated with it. Then and the shortcut tables will solve that particular scenario where the cost is has a little margin, not very high, a little margin. At a cost perspective, also shortcut tables have benefits, and shortcut tables can be read via SQL endpoint. So at Lakehouse, you'll be having a SQL endpoint, and similarly, whatever the thing like whatever operations you do on a delta table for querying only, you can do it for the shortcut tables as well. And in SQL endpoint, we don't support the data manipulation languages like the updates or deletes. Why? Simple. As I already told you, whenever you perform some operations like update or delete, you will be having deletion vectors inside the delta table, and SQL endpoint doesn't have that capability. So that's the only reason where a SQL endpoint is only used for querying. Querying as in only your select statements will work mostly. This is one property of like a shortcut table as well. And after creating these shortcut tables, you can create the views as well. If we move to the next slide, again, if we generally consider a workflow, whenever we create the tables, then the next part will be how to share the data, how to give the data to other departments, or how to select some security operations on the views, on the tables, etc. So that's where the views icon will look something like this. And yeah, so T-SQL endpoints, the SQL endpoints will support the views and you can query it. And complex join operations in views are the basic properties. And yeah, whenever we give the data for a data visualization, the stored procedures are kind of, you do some operations like a batch operation on particular SQL statements, etc. So stored procedures is like you pass some parameters and the queries will be executed based on the parameters. This is a simple use case of stored procedures, and the stored procedure icon is something which looks like this. And in the SQL endpoint, can you query it? Yes, you can query all the stored procedures in the SQL endpoint as well. And you can create stored procedures on top of shortcut tables. And yeah, if we move to the next slide, file shortcut. We have seen the shortcut tables, but what is a file shortcut? Basically, whenever you try to do some operations on a shortcut table, and those shortcut tables have some irregularities and move to unidentified state. Unidentified state as in Fabric will not lose the properties of the table. It will hold the properties of the table, but it will be keeping it in the unidentified state. Unidentified state as in you can query the data, but as a file. So file shortcuts are similar to the shortcut tables. You will be having all the metadata, you will be having the delta log, and you will be having the Parquet files, which stores the actual data, everything. But just it's in the unidentified state, or if it is in the files, then we call them the file shortcuts. For example, if we give an access to a particular folder which has a list of delta tables, then we can create the file shortcuts. Here, one more scenario also comes into the place, the schema shortcuts. Whenever you attach a folder which has a list of delta tables inside it to your table section inside the Lakehouse, that is the schema shortcut. If you attach the folders inside the file section of your Lakehouse, this is the files shortcut. But just we need to be careful that if we give the direct connection to the delta table folder, for example, we have a master table. Inside the master table, we have delta log, metadata, and Parquet files. If we give the direct connection, then it will be always a shortcut table. If we give a connection to a list of tables inside a folder, for example, I have a new folder and inside that there are 5 master tables. If I just give a direct connection to that folder which has the connect, which has the property of all the delta tables inside the list, then generally it is the file shortcut. And these file shortcuts are not queryable in the SQL endpoint because again, only the shortcut tables has the property to be queried in the SQL endpoint. And you can go to the next slide. Unidentified state. Shortcut tables, mostly whenever there is an issue or whenever there is an up and downs happening in your workflow, you can find all the tables inside the unidentified. Unidentified as in your tables data is not lost or your tables data is not manipulated in many kinds. It's just Lakehouse cannot identify it as a table, as a shortcut table or a delta table. This happens mainly in two scenarios. Whenever you are trying to raise a uh, branch, or whenever you are trying to move the shortcuts from one environment to another environment, as in from one lake house to another lake house by Git, or one lake house to another production data lake or production delta lake scenarios, then most of the tables will be found in unidentified state. So this is one major thing where you always need to have a track of the shortcut tables inside the unidentified state rather than deleting them directly. So what's inside the unidentified state? You can always again move that tables to the schema, but first in the unidentified state, you will have an option to create them as files. So whenever there are shortcut tables inside the unidentified folder, you need to create as a files. Those delta tables will be created as files first inside your lakehouse, and then again you can create them as shortcuts. It's just a step inside the fabric where it is a safe it is considered as a best practice or a safe side scenario where it will not directly delete the tables. Whenever it has a doubt, it fabric will keep the table inside the unidentified state. This unidentified folder, you can find it inside the schema. And yeah, shortcut tables will not be deleted directly, as I told you. So it holds the data. And again, whenever there is another scenario where inside the ADLS Gento, if you delete the table, or if you delete the delta table, that schema will no longer recognize the table at your ADLS Gento. At that particular time as well, your shortcut table will move inside the unidentified folder. And again, from the unidentified, you can create a separate file inside the lakehouse and then again attach it to the schema as a shortcut or whatever, however way you like. And these are some of the properties of the shortcut tables. And yeah, you can go to the next slide. Sorry guys, just wondering, are you guys able to hear me properly? I can say audio is very low.
Yes, we
Yeah.
can.
Oh, okay.
Yeah.
Sure. Okay. Yeah. Yeah. Again, we have the delta tables, and whenever we have the delta tables, our primary duties will be to optimize it, keep the Z ordering, or use the V ordering based on our scenarios. But what does the optimize do whenever there are multiple data inserts? It will just organize your data so that you can query it faster and read it faster, and you can filter them faster based on a particular primary key or based on a particular ID column, etc. This is generally how a delta table looks like internally. So whenever you have an issues and you go to the ADLS location, you will have the delta log, you will have the metadata, and you will have the Parquet files. So if you are seeing the columns in the metadata and you are unable to see the columns inside Fabric, then that means there are some security operations going on. So this is where we can track the backend, or you can call it as a backend of a shortcut table. So you can go to the delta log and you can see delta log is nothing but again a JSON file, and you can query the data accordingly. Inside the JSON file, you can see if you have an access, you can inside the JSON file you can see which is the latest version when it has updated. And again inside the metadata, you can see all the columns. This is like a master access scenario where if you can see the delta table, what's inside it, you already have access to everything. And yeah, you can go to the next slide. So as we have already discussed, why we can't update or delete in the SQL endpoint for the shortcut tables or delta tables. So the SQL endpoint doesn't have the capability. So whenever you try to do it, you will get this error. So do not try. Most of the people will just check whether you can update or delete using the SQL endpoint So it just doesn't support it. We don't have that capability yet. Whenever we have that, we can again push the limits. And yeah, so if we go to the next slide, when using the shortcut tables or when you are working with the delta tables, like what are the best practices? Whenever we try to create a external table, we give the command dot save and we give the abfs path for the location of the ADLS gen 2, and there the delta table which will be created. And if we want to attach the delta table to the lakehouse, we will write create table, and we will give the lakehouse dot schema dot table name. And later on, we don't define the schema, we just write using delta location, and inside the location we will give the location and we'll attach that as a shortcut table. This is the general practice of how we create the shortcut tables. But uh, what if we need to use that commands multiple times? Like we always need to write the dot save or dot create or replace table, or create table if not exists queries. What if we write them inside a function with all the parameters that we want to use, and whenever we want to query the table or write the table or use the table multiple times or perform some merge operations, we can define some functions. And that functions, when we define in a particular notebook and create run that notebook inside another notebook, like you can use percent run and define the notebook name to get that particular functions inside another notebook. That's a general property of the notebooks. That's where these are some of the best practices of using the shortcut tables, where register delta will just attach the table, read delta, whatever the partitions are, whatever the table names are, whatever the schema is, you can just define a lakehouse schema and table name. If you just write this function and just give some parameters, it will do the work for you. So whenever you are trying to design a workflow, especially with the tables, you always need to write multiple select commands, multiple dot save commands, and multiple dot save as table commands at particular scenarios. What if all those scenarios are mentioned in particular 4 to 5 functions, and with that functions you can do all your work easily? That solves most of our time, right? So that's where, so these are some of the best practices when you're dealing with delta table creations or shortcut tables. You can use the functions, you can name the function register delta table, and inside that you can just give the path, you can give the lakehouse schema, and that table will get attached instead of writing the create table command for SQL. For read delta, if you want to read only some specific partitions, you don't need to write the actual SQL query for around 10 lines. You can just have 4 lines, write a 4 lines of code, and the read delta function is actually mentioned inside a notebook. That saves a lot of your time. Again, the write delta. The write delta is like creating dot save command. You can define the mode override, mode append. It's just you'll be having the syntax of this function, whatever the parameters you want to pass at a particular pace, and you can use these functions multiple times so that it will save a lot of your lines of code and your time as well. And again, the merge. If you want to perform upset or based on some set of keys or a single key, whatever, you can define in the merge delta and at a particular notebook, and you can call that notebook and you can just write the merge delta as seen in the slide, like only 4 to 5 lines of code, and you can just mention the parameters and it will does the job for you. This is considered as one of the best practice when dealing with the delta tables or the shortcut tables. Okay, and no, if you go to the next slide, what if we are using a medallion architecture, and inside the medallion architecture, we are using the shortcut tables. The general scenario. So we need to define the schema properly inside the bronze, especially because bronze is considered as a raw layer. And whenever we are trying to use this best practice functions, we need to be very careful. Like we need to mention some properties like schema evolution or replace if exist properties. We can mention all those with a proper convention. Like if there is a schema, and if you, whenever you are trying to use a write delta function and you use a met schema equal to true, again you need to be very careful because there will be a schema drift. The number of columns that are getting attached will be very high sometimes, and the best practice again will be the worst practice if you don't use it properly. So these are some of the pitfalls, or you can consider some negative points or the consequences or the cons, where even after using those functions and making your life easier, you will be having some edge cases as well. Next, we need to be very sure for the row count, if we directly want to use the filter conditions for specific partitions, etc. If you go to the next slide, uh, does it support incremental? Yeah, all the best practices support incremental problem. Like a micro batch, small files doing a lot of jobs inside a single write delta or match delta function, or like if there is any high cardinality partitions. So shortcut tables are external tables, and optimize and ordering and z ordering or v ordering will always have some extra shuffles, or will always have some extra cost associated with it. So that is where the liquid clustering comes into the place, especially when dealing with the shortcut tables or the external tables. It is a little bit cost effective compared to optimize, and it works better than optimize command for multiple reads, etc. Whenever we try to do incremental load, like when every day your table is getting appended with a million rows or some few millions of rows, liquid clustering is the method we try to generally use it and query the data faster from that table, rather than using optimize or other things. So that is one important property. Try to use the liquid clustering. It's just a simple syntax in PySpark, like cluster by, and you can define the column names. And in the liquid clustering as well, you can define set of columns, like not more than 5 columns. It will be again ms. Try to define a set of 2 to 3, and 2 to 3 is always a best practice. You can always change the columns. Like if you create a liquid clustering on a set of 3 columns and you want to change it again, you can do it. There is no hassle in that. And again, the delta log, we need to mention the vacuum, where the delta log always stores whenever you try to do some operations. And whenever we try to use the best practice functions like read delta, match delta, we sometimes ignore the vacuum operations. So we need to explicitly mention the vacuums as well for the delta, or for a particular table, so that it is always not occupying a higher storage. And yeah, if we go to the next slide, architecture and design. So there is always, whenever we are using the shortcut tables, we need to always consider PII data, or the personally identifiable data, as a main priority, where if we do not appropriate, do not enforce proper rules on the shortcut tables, then your data will be visible to everyone, even though it is at an external storage account, and you can query it in a very comfortable manner, just as a table inside your schema. You need to always ensure that those shortcuts are reaching only particular segments of developers. Otherwise, if you don't enforce proper conditions on the tables, again, it's a mess. And instead of copying data, instead of using shortcuts, so you have some shortcuts in a prod, and again, you need to query for a temporary time in your dev environment, or for example, in you have some shortcuts in prod lakehouse and you want to query them in your dev lakehouse. So that's where again shortcuts can be created on top of shortcuts. So instead of copying the data every time, you can just create the shortcuts of that particular prod. You can just create a schema shortcut or a direct table shortcut, and you can resolve the issue. So this is where again copying the data or again keeping the data in multiple places issue is resolved. Shortcuts is always a better practice where it is stays in one location but queryable in many locations. And yeah, whenever you're trying to do the upset, make sure that only appropriate people can do the upset operations or delete operations, so that the shortcuts are already at an external location. If you don't have it, if you don't have the access in the workspace, or if you don't have the access to that storage location, it's always a mess. Most of the times workspace identity will have the access, but we actually will not have the access for that storage account. So that's where if you perform some upsert or a delete operations, again it's a very big hassle to trace back. And we can move to the next slide. So there are some limitations again. So who can access the shortcuts? What are the behaviors of the shortcut tables, and what is the capacity? So right now, according to the official Fabric documentation, 1 lakh shortcuts for one Fabric item, as in for a one lake house, is considered as an optimal thing at the moment. And if we create more than 10 shortcuts inside one path, then it takes a bit of time. Generally, shortcuts, whenever you try to append the data or whenever you try to add the data to them, within seconds, the data will get updated. But if you have millions of records and there are more than 10 shortcuts inside a single path, then updating those tables will take a little bit more time. That if you insert the data now, then after 2 or 5 minutes, your data will be reflected. So that's what it's the best practice is to keep 10 shortcut tables in a particular path, not more than 10 if you have larger volumes of data. Again, when it comes to the authentication, as these are external tables, most of the people sometimes will have access to the external location but not in the workspace, and some people will have the workspace access but not the external location. These are some confusions where the infra related issues occur mostly. And if you want to query the table, make sure that the workspace identity is properly allocated for that shortcut table, and you always have that ADLS Gen2 location as well handy, so that you can always have complete control over everything. If there are any firewalls, if there are any service principles associated, and if there are any secrets associated to that shortcuts, always make sure that you have a proper authentication. Otherwise, it's just only read only. Most of the times, the option will be by default as a read only. These are some of the infra related authentications where when you're trying to deal with the shortcut tables, make sure you always have proper service principal or proper secret or proper complete control of that ADLS storage Gen2 location as well. And yeah, whenever you try to deal with the SQL endpoint and query the shortcut tables, the SQL endpoint might take a little bit more time than a Spark notebook, and there is always a delay when compared to the Spark notebook. The SQL Analytics endpoint, you can always query the data and see the data, but with a little bit of delay. And you can always you can query the shortcuts inside the warehouse as well. And all the properties of Lakehouse, which we have discussed right now, similar properties apply to the warehouse as well. Nothing much. And if you go to the next slide, optimize, vacuum, and Z order. Always choose a right command. So whenever you try to use optimize, make sure that the size of the tables are at a medium scale, not more than 10 million, or the size of the rows are not more than 10 million kind of. The decent size for shortcut tables are considered around 1 million to 10 million. If we have less, then it's again optimize will be always better. And again, vacuum, we always need to mention it. And Z order, it's up to you. Or if you have frequent hits of the table, like frequent IO operations going on, Z order will be mostly convenient. And if we have incremental and frequent hits are not there, optimize will be very convenient for you. And if we have frequent hits and we have incremental load, everything, uh, don't overthink, just go for liquid clustering for higher volumes of data. And if we discuss the vacuum, Z order and V order, it's always again making the table read faster or query faster and filter operations working faster on the table. Yeah, if you go to the next slide, medallion architecture. So this is one of the most common thing everyone talks about. We have the bronze, we have the silver, and we have the gold. So whenever we talk about the medallion architecture, we have the delta tables inside the bronze, we have the delta tables inside the silver, and we have the delta tables inside the gold. But what exactly happens? Bronze layer is considered as a raw layer, but in real time, you will be having an external location where you'll get the data in CSV files or an API or or some JSON files or XML files in a storage container, which is considered as a raw or a particular pure raw layer. And from there, you will pick the data, you will convert them into the delta tables, and you will be like creating the CSV files or the JSON files or the XML files into a delta table. That is what a medallion bronze layer is exactly means inside the real time. Most in most of the scenarios, not particularly in everything, but in most of the scenarios. And in silver, you will perform some deduplications and you will be performing some transformations, you will be performing some mappings, and that's where your silver will come to the place. And mostly in silver, the terminology is that you will be having the master tables. And from silver to gold, there is some aggregations as in it's not particularly different. So aggregations as in on a particular id, what is the total cost or what is the total spend or what is the total number of clicks, etc. So just on a particular id, if you want to do aggregation and store it in a table, then you have the gold layer for it. What gold layer mostly consists of dims and facts, dimensions and fact tables. So the medallion architecture is mostly a star schema with the master tables being at the center and dimensions and facts being in the star. So this is what a general thing comes. But in real time, this is far more complex than what we see. Like the especially the hassle comes in the gold, where you have the dimensions and facts, but you need to share the data to the data visualization team or a machine learning team. So that's where again you need to select appropriate columns and you need to select appropriate tables to share them. If you share all the data, again the data will be lost and you expose a lot of your data to your clients. So gold layer is mostly two or three types of layers. You will be having dimensions and facts, and on top of that, again, you'll be creating some dimensions and facts or some views, which acts as dimensions and facts to share a particular department. Or for the Power BI team, if you want to share, the dimensions and facts will be there. On top of that, you will be creating another dimensions and facts. So that is where the complication arises in the medallion architecture generally. Whenever you try to share a segment of the columns or you create another table or view on top of this and share to other people, and an error comes at the report, you need to start debugging from the raw, especially. So whenever you try to debug, right, you always need to look at the bronze layer, whether that column is coming properly. Again, in the master layer, whether that column is getting populated properly. And in the gold layer, again, whether the column is getting populated properly. And then in the view. So this is one of the typical thing which the Medallion architecture has, and the pitfalls. Whenever an error happens, we always need to debug from the scratch uh, when the design is not proper. And especially in the silver layers, whatever the transformations you do is the final transformation. Again, you don't do the transformations. So we always need to be careful of doing the transformations at the silver layer. And one of another pitfalls is like there are some five CSV files, and those five CSV files are in the raw layer, and those five CSV files are converted into a bronze delta table. Each CSV file has 100 columns, and all those 100 columns will be brought into your bronze table, and all those 100 columns will again be brought into the your silver master tables, and all in that you will pick 20 to 10 columns inside your gold. So when you're designing a metadata framework or a framework for a Medallion architecture, you always need to make sure that you are selecting the right columns. So bronze layer, when you're trying to create the delta tables on top of the raw files, select only those columns which are necessary. If there are 100 columns, you always make sure that those 100 columns we are utilizing it properly. Otherwise, most of the times 50 columns will be kept aside and only 50 columns create a business scenario for silver and master. Rather than pulling all those 100 columns explicitly every time, or just directly creating the tables inside the bronze, make sure that you are selecting appropriate columns that only you want for the gold. Always try to think from the gold perspective when you're operating from Medallion architecture. What are the important columns I should consider at the bronze so that there will not be any hassle at the gold? Data engineers, especially, or data analysts, we always need to make sure that the columns are selected right. And if you go to the next slide, PySpark to SQL endpoint. So this is again in we have the query, but we'll look at the end of the session. PySpark to SQL endpoint. You create the tables using PySpark, and you query the tables inside the SQL. So that's where again some edge cases arise, where if appropriate data types are not defined, then there is always an issue of losing the data. For example, there will always be a 5 to 10% delta in your gold layer. In bronze layer, for example, there are 1000 clicks. In master, you will be having 1000 clicks, but in gold, you will be having 990 or 950 kind of. That's where when string to integer, integer to string, or whenever you try to convert one data type to another, the issues arise. Particularly, for example, if we consider a spend, we have a floating decimal points, like we have dot 1823 for around 4 decimal points. And when using PySpark, we can define it as a float or a big int, etc. And you write the syntax with the info schema, and you create a table. Then inside the SQL table, the dot decimals will be lost, and again it will create a delta for the spend. In bronze, you will be having some hundreds, and for example, if in bronze it is 1000, again after going to gold, it will be a 5% delta, as in you will be having 980 to 990 kind of. If there is a 5% delta, so make sure that your data types are appropriate, and you are getting the data correctly. So whenever there is a hassle, as I told you, you need to check each and layer individually in the Medallion architecture. First check the bronze, how much it is getting, and then check the silver, is it losing any data? Then again check the gold if it is losing any data. And whenever you're trying to use the infer schema when creating the tables, make sure that the data types are assigned properly. And if, as I told you, an example, if you go to the next slide, there is an example of you for the decimals. If we have the numbers in millions and even the decimals are more than 4 digits, then make sure you always use the double type and create the table so that even the decimals are not lost. As I told you, there was a example where we were getting a spend in millions and in bronze and master silver, but in gold we were not getting it. So in order to debug it, first we don't need to always go to the transformation functions or the code to look at it. Just first primary point will be to look at the data types and debug. Like if there is any data type issue going on in the real time, and we are losing the data. It's not always the transformation functions, or it's not always your code that is doing the loss. Sometimes the data types will also do the loss. And when you try to convert string to integer and or string to date, you'll always have a hassle. And whenever this types of problems comes, uh, the pitfalls are again a bit messy, and it will take more time to alter the code at multiple places and again get the data. So whenever you're trying to design the medallion architecture, always make sure that only you select the required columns, you are assigning proper data types, and the data is consistent across all the layers. The data is consistent as in like you get the same amount of metrics in the bronze, master, and silver. If there is any loss, you will have some filter conditions. That's obvious. But if you are not having any loss, make sure to check these metrics at all the three layers. And yeah, as we are moving or running out of time, there is a query. You mentioned optimization improves query performance, but reorganizing data in real projects. How do teams decide when to run optimized operations scheduled regularly or when performance starts dropping? So basically, when your data size or the number of rows increase from 1 million, then if you run the optimize command, it will be a better practice always. And if you have a particular filter operations or a particular uh, column mappings or whatever, like if you have any natural keys or primary keys, then if you want to frequently hit the table and query the data, then always Z ordering will take place. But Z ordering is again costly. So whenever you try to insert the data, it will shuffle the data at the location, and it will take some time, or there is always a lot of shuffles inside the data. So Z ordering is also suitable, but for a medium data, like if the data size is not more than 10 million. And always, if there is an incremental load and if there is frequent hits for the table, always choose liquid clustering on top of optimize and Z ordering. What liquid clustering will do, it will also again organize your data for frequent hits, but like in a more structured manner. Whenever the new data comes, it will not shuffle the data multiple times. It will just create the shuffles as it like on the columns you mentioned, and it will again help you in the frequent hits. Don't use all the optimized ordering cluster by on a particular table. It will be again a hassle when you read the data. All the commands won't work at a particular scenario. It's again completely based on your scenario, where a medium sized incremental load for around 1 million rows, optimize more than 1 million Z ordering frequent hits, and more than 10 million, go to liquid clustering for the shortcut tables. I hope this answered your question. And any other questions, guys? What is the biggest mistake team makes while designing these workflows, and how do experienced data engineers prevent performance issues before they happen? Yeah, so this is a typical question. Even in most of the interviews, we'll be getting asked, how will you optimize a query? There is nothing like optimizing a query. It's based on a scenario. How you optimize a table, how frequently like the data hits to the table, and how frequently the data is getting read by the visualization team or another teams. uh, always make sure you select the right columns from the raw layer. The biggest mistake is like you select all the columns in the raw layer as it is just a dump for the delta table. So experienced data engineers, as in it's not particularly related to the performance issues, but mostly the experience is when you try to do the mistakes, you learn from it, and it's like creating the framework more compatible so that everyone can understand. If you have a medallion architecture, try to create it in a more simpler manner so that everyone can understand. So if you don't need to always write some thousands of lines of code, you can split it into multiple notebooks and create proper functions. Like I told you, you can define some common functions inside a notebook and run that notebook in multiple notebooks, so that you always don't need to use a particular PySpark or SQL lines of code. Or whenever trying to do some transformations, always make sure that they are up to a minimal, so that you do hundreds of mappings and hundreds of transformations on a particular master table, you will not always understand what's going on. Split it into multiple notebooks with smaller chunks of code so that everyone can understand it and map to the master table, like in the star schema. Map all the notebooks to the master table so that everyone can understand it in a better manner. And performance issues, there will always be a performance issues where the visualization team wants a particular column and we don't have it inside the master tables or the bronze tables ready. We always uh, try to create a new table and again optimize it for a better frequent hits, and try to debug where the issue is. Or whenever we have the stored procedures and pass the parameters, they will not be working for people who are dealing with the data science. So again, the performance issues happen, and we need to debug what are the transformations that are going on and where is the error happening for that particular stored procedure. Debugging is mostly the hassle in terms of the performance. And I hope this answered for this session.
Yeah. So we are on the top of the hour. Is there anything left out, Sathwik, or you're done?
Yeah, we are done, Amit. Yeah.
Okay, fine. So thanks, Sathwik. Thanks a lot. We already have Nanddeep and Smita joined in, and we'll be shifting now here. It was a wonderful session. I can see a lot of comments and in this session. So thanks a lot for that. Moderator, are you ready to welcome the next set of speaker?
Yes.
Okay.
We are excited to welcome Nandan Hegde, an experienced data architecture trainer and Microsoft Data MVP with deep expertise in Microsoft Fabric, Azure, and C+ technologies. Recognized as Microsoft Fabric super user, Azure.
I think we are talking about 12p. It's 11. Navdeep and Smita. I think I did post it wrong first.
No problem, no problem. So yeah, Ms. Atlas, hi, Nanddeep and Smita
Yeah.
here.
Yeah, actually, when I posted, I actually posted 12p instead of 11. So I think that created confusion.
No issue, no issue. Okay, so this is who we are. We were going to start with the session.
Yeah, you can
Okay.
start sharing your screen. Yeah.
Sure, sure. Sorry. Oh, I think I just started sharing and it went away. Just give me a moment. Hopefully it should come now.
Not yet for me.
Okay. Something went wrong when I'm sharing. Okay. Just give me a moment. Let me try that one more time. Oh, I'm unable to share.
Is it so?
Just give me a moment.
It happened with the last speaker also. What is the problem?
Because at least it shows that okay, I'm trying to share, but again something went wrong and not able to share. Just give me a moment. Let me try one more time.
The last thing I wanted to restart the meeting because we then we have to admit everyone again.
Correct. Just give me another moment. Let me just try. Because at least it gives me option, and then it again goes away. Like it gives me option to share the screen. The option comes, and then again it goes away. Let me just
That's
try
strange
one
because I
more
think,
time.
but I think somehow our moderators were able to share. How come that? Okay, because we have the BI World login. Is it
Correct.
okay? Let me check these options for this meeting. Give me a second. Let me check if
Okay.
somebody modified the option. Just give me a second.
Sure.
Maybe the presenters don't have right to. Where is this meeting? Options. Presenter. Who's the presenter? Who can bypass lobby? Who can admit to the lobby? Rules.
Okay.
Okay.
So I rejoined from Teams desktop. Can you please make me a presenter?
I now change the setting of this meeting to be everyone can present. So do one thing. You just try to log in again.
Log in one more time. Sure. Just
Yeah.
give me a
Smita,
moment.
meanwhile, if you have something to share, just you can try if you are able to do so.
I'm also facing the same problem. Let me try once again.
Okay, I have entered Nanddeep again and make presenter change.
Okay. I do not have access to share my screen. Okay. Now it came. Okay. Hopefully it is.
Yes, so I changed the setting now.
Visible now?
So I think if Smita, you need to share, you may have to go back and log in again.
Sure. Yeah, no problem. Is that this I will be sharing. So
Okay.
not an issue. We can get started. All right. Okay. So good to start or
Yeah, you can start. I think you can
Yep,
start with the
sure.
intro. Both of.
All right. Okay, so hello everyone, welcome and thank you very much for joining. Thank you for joining us at this global Microsoft Analytics Community Conference 4, and this is going to be an entire one day kind of an event. So please be there, attend all of the events. We have got almost 60 plus kind of speakers, 160 plus kind of sessions, and so many attendees. So that is kind of a record for last three conferences. So even we are expecting similar kind of a thing while we explore Microsoft Fabric, AI Copilot, Power Platform, Purview, and all of the other certification related thing. All right. So for this particular session, we will be talking about how we can design the multi-agent kind of solutions on Microsoft Foundry. The reason like why I selected for this particular session is like as the AI solution they grow more complex, a single agent which is trying to do everything becomes pretty much hard to maintain. Even it becomes unreliable. So this connected kind of an agent, they solve this by letting you build the collaborative multi-agent kind of a system where the primary agent delegates the work to the specialized sub-agents and then they can perform the task. And the best part here is like you do not need to write any custom orchestrator or any hard coded kind of an routing logic. The main agent uses the natural language to figure out which sub-agent that it should handle each of the tasks. Okay, so now again, for example, if in case I go bit into the history, when we started using generative AI, we were pretty much limited to using this LLM large language model to answer the questions. So we asked the question, we got the answers, and we were quite happy with getting all those answers. Moving ahead, we also started creating the agents. So that means agents will have a dedicated kind of an capability. There will be some specialized agent which can not only just answer the question, but again they can perform certain tasks. So that means they can take the action if in case they need to connect to any of the external system, update any records there, get the information, delete the information. All in all of the CRUD, create, read, update, delete kind of an operations they can do. Okay, so that was again a good part. But now we are again one more step ahead, and then we have got those multiple agents, but those agents are communicating to each other, creating the orchestration, and then getting your job done. Okay, so in this particular session, we'll be seeing like how we can create the agent, how we can create the multi-agent kind of an ecosystem, and then how all those agents will be able to communicate to each other. Okay, so before we dive into the session, again, here is a chance for you with the challenge code, enter to win. So participate in all of the session challenges, scan this QR code and maybe enter the code which is given below to submit your answer. Okay, so to get a chance to win something good here. Okay, so again, this is going to be agenda for our session. We will be looking at the AI evolution, how the AI has been evolved from tools and assistant to the agentic AI. We will understand the basics of agent, like what agents are really mean, how do they work, and then we will go on to the specific topic of this session today for connected agents. We will see how multiple agents they will be able to connect to each other, the architecture behind it, features, as well as how we can set up that. Again, not just that agents needs to be into only one area, but again we will be showing like for example, if in case you have got you have got few agents which are created into the Microsoft Foundry, but still how you can use them to connect to the Copilot Studio agents as well. Then we'll be looking at how you can create the hosted agents, and then we will wrap up with some kind of key takeaways. Okay, all right. So before we start with the actual session, quick introduction. Myself, Nanddeep Nachan. I am from Pune and Microsoft MVP as well as Microsoft Certified Trainer. Author of these three books, as well as the author of this Udemy course on SharePoint framework. And on to the right hand side, here are few of my social media handlers for LinkedIn, YouTube channel, and so on. So please go ahead, send me a request, watch those videos, and you will be happy. Okay, so with that, along with me is Smita.
Hello, all. Myself Smita Nathan. I'm having total almost 18 years of experience in Microsoft technology. I'm a Microsoft MVP. I'm author of these two books, and these are some of my social handlers by which you can get in touch with me. So now we are going to talk about AI as a tool. So roughly the last decades, AI has shown up in enterprise environments in two dominant patterns. So you can see on this slide automation on the left and assistance on the right. And here are the things. So both of these are genuinely useful. So let's start first with the automation. So these are your rule-based system. So think like a Power Automate flows, UiPath bots, Azure Logic apps, schedule Azure function. The pattern is always the same. A developer or a business analyst defines a deterministic workflow. So if condition A, do action B and repeat. So the system executes exactly what it was configured to do and does it reliably at scale and around the clock. That's the value proposition. So the example on the slide is a classic adding a new hire to the HR system. So let's say that someone builds the automation once. So maybe it watches a SharePoint list, triggers a flow, creates the AD account, sends the welcome email, provisions the licenses. It's all about the beautiful things. But here is what exactly happens in the real world scenarios. So let's talk about that one. So the HR team changes a field name in their form, or the IT switches from the on-premises AD to intra ID. Okay, so, or someone adds the conditional steps for the contractors versus the full time employees, and suddenly that automation breaks. And here is the challenge comes. So, because it has a zero ability to reason about what changed. So, it deterministics the code executing, deterministic the logic. So, there is a no understanding of the intent. So, now look at the assistance on the right. So, this is the chatbot era where everything from the FAQ bots in a Teams to early copilot experiences. So these systems are reactive. So they sit there waiting for you to type a question. You ask something like what the dress code in the office, and the assistant performs a retrieval operation. Maybe it's queries on the Azure AI search index and does some rag over your SharePoint documents, rank the results, and returns an answer. And that's the useful. But you notice that what's happened next? Absolutely nothing. The assistants give you the information and it's on you to decide what to do with it. You are still the one planning, connecting, and executing. Just a moment, there is some problem with the sharing, so let's share it once again. Are you able to see the screen? Okay, so let's go ahead and let's see AI as a teammate. So, what was yesterday? Now, let's talk about the today. Okay, so this is where the things are genuinely interesting from the technical standpoint. So the headline shifts on the slide is a crucial. So AI is moving from being a tool to being a teammate. And I know that sounds like a marketing tagline. So let me explain what exactly I mean in engineering terms. A tool is something with a fixed interface. So you call it, it returns a result. It has no memory of why you called it or what comes next. A teammate understands the context, can decompose a goal into the subtask. You decide which tools to use, can recover from the failures, and can coordinate with other team members. So that's the architecture shift we are reviewing through right now. So let's look on the left card first. That is the agent. So what is an agent technically? So at its core, an agent is a program where the control flow is determined by a large language model. So instead of you writing the if else branches, the LLM decides what to do the next based on the current state, the goal, and the tools available to it. So it's reasoning the loop, observe, think, act, and observe again. So example on the slide is order a laptop for a new employee. So let me walk you through what exactly happens under the hood. So the agent receives that instructions. It reasons that I need to know the employee's roles to determine the hardware tier. So it calls a tool, maybe let's say Microsoft Graph, to query the pool and the employee's profile from the inter ID. It gets back the role. Let's say, for example, it's a senior software engineer. So it's reasons against that the senior software engineers get the high specification configuration, and it calls the procurement API, places the order, gets back on the order ID. It then calls the ServiceNow API to update the tickets and the order confirmation. So four tool calls, three reasoning steps, zero human intervention between these steps. So that's the fundamentally different from both automation and the assistance. So here is an analogy that really helps it clicks. Okay, a calculator versus a financial analyst. So with a calculator, you can press every button. You own the entire sequence of operation. With the financial assistance, you say that tell me if this is the acquisition, make the sense, and they figure out what models to run, what data to pull, and what assumption to test. So you describe the question, they figure out of the model. Okay, now method, sorry. So now look at the right card. That is the agentic system. So this is where it gets the genuinely powerful and is the core of what you are going to build in this session. So instead of the one agent doing everything, so you have a multiple specialized agents collaborating on a large outcomes. So think of microservices before the intelligence. So here is our example that onboard five new employees by Monday. So there is not a single task, decompose it. You need enter ID accounts provision, laptop order, Microsoft 365 licenses assigned, team channels created, training material sent, manager instructions, schedules. Also the introductions are scheduled in an agentic systems. You might have an IT provisioning agent handling the accounts and the licenses, a procurement agent handling the hardware, and an HR agent handling the documentation and the compliance, and the communication agent handling the welcome messages and the calendar invites. So each agent is independently capable, but they coordinate passing the context, sharing the results, and handling the dependency. So now let's talk from in the next slide from giving the instruction to sharing the goals. So let's start with the first row. You break the work into the steps versus you describe the outcome you want. So this is the most significant shift from engineering perspective. So think about how you build an automation today. Okay, so you sit down, you compose the problem, first do this, then check that if the condition this, then branch here, handle the error and call the API. Okay, so you are the planner over here. The second row, AI executes one task at a time versus the AI. So the AI plans and executes the many tasks. So this is the difference between a single function call and an orchestration layer. So the old school AI integration where especially the stateless API call sends the input, get the output done. So the modern agents message the states across a reasoning loop. So the third row over here, the human connects the dots versus the AI coordinates across the tools and the data. So this one really resonates with anyone who has built the integration solutions. So we are going to talk more about this in the demo also. And the fourth one row is my favorite. It is the scales with how much you type versus the scale, how clearly you think. So I want everyone to really sit with this one. In the old world, your productivity was literally capped by your throughput. Okay, how fast you could type the prompts, write the codes, configure the workflows. In the agentic world, productivity is capped by how precisely you can articulate the outcome. So we are going to talk about this agentic AI, how it is the new frontier. So this the headline says it, the agentic AI is a new frontier. And I want you to clear about what the frontier means here. So it does not just mean that the new and shiny. It means we are at the boundary of what been possible with the software. So for the first time, we can build a system and that don't just process the data, they pursue the outcomes. That is a fundamentally different capability and it changes how we architect the solution. So let me talk you through these three pillars. So the first is autonomy. So this is the ability to take the action towards the goal, not just the respond to the prompt. So think about this means that technically an autonomous agent has a goal representation, a world model built from its tool and context and a planning capability that generates the action sequence. Okay, so the second one is the reasoning. So this is what separates an agent from the macro or an RPA bot. So the reasoning means the agent can think through the steps, handle the ambiguity, adjust when something fails, and pick the next best action based on the new information. Third one is the collaboration. So this is where the multi-agent systems come in. So which is the core topic of the today's session. So the collaboration is the agent can team up with the each other with the tools and the data sources in your environment. So now let's go ahead and talk about what is an agent. Okay, so the AI agent is a simple program where you allow an LLM to help you decide the control flow of the program. So it is like a microservice that you can execute the task and achieve the specific business outcomes also. So now let's go ahead with the demo.
All right. So with that, let's get into our first demo, wherein we will be see like how we can create the agent into the Microsoft Foundry. So right now I'm into the Microsoft Foundry. Obviously, you will have to create AI service and everything, and then you will learn into the Microsoft Foundry. In the Microsoft Foundry, I have created a project, and then again, right now I'm into the new Foundry experience. But again, we will be showing you demo like how you'll be able to create the agents in the old Foundry experience as well. Now with that, for example, if you see here onto the left hand side, we do have various things, or maybe let me start with very first thing. If in case you go onto the home, this is where you are able to see all of the API key, project endpoint, as well as the Azure Open AI endpoint. And this is a place from where you will be able to use this information in your coding as well. So whether you can decide to do your code with Python, C Sharp, Java, or anything else, you can use this API keys to get connected. Now, when you go onto the Discover part, this is a place where you will be able to see all of the models which are available to you. So again, from here you can see like these are few kind of featured models which are available. That means the most used kind of as well as the featured kind of models that you can think to use inside of your application. And one of that is very cool is this model router, because what generally happens, each of the model has got their own capability, their own functionality. Let's say, for example, GPT-4o kind of models, they're good at giving the answers pretty much faster. For example, if in case you go with GPT-5 plus kind of models, they do the deep reasoning So that means they do take some time, but they gives you more deep reason kind of an information. Now, not all of the scenarios are good candidate for only single model. We need flexibility where, let's say, for example, simple queries can be answered by a very basic kind of a model. But for example, whenever any of the functionality which requires deep reasoning, deep thinking, in that case, that should be handled by some other models. Okay, so that means we can save the cost, we can save few of our tokens and everything. So to do that, this is something called as model router. So wherein we will have pool of models available to us. We can choose the one and then we can get started from there. So do explore all these models. We do have various models available. Based on the setting which I got onto my project, I have 1,000 plus kind of models available. But in the real world, we do have almost 11,000 plus kind of models which are available. From here, you can simply compare the models. So let's say, for example, if in case you are working onto the scenario and you want to compare the model, like for example, how the quality for that means the benchmarks based on the quality, safety, the input and output accepted and everything. If in case you want to see like which one will be better, let's say even from cloud, DeepSeek, the available from OpenAI, Microsoft, and so on, you can do the comparison side by side, and then you will be able to good means you will be able to take a good decision whether you can go with which kind of a model. Okay, so you will be able to compare all of your models from here very easily. Apart from that is if in case you want to see like what the other people are using, so here you can see the model leaderboard, and then again we can see at this point of time we do have GPT 5.5 which is being used very heavily, which has got almost 0.82 kind of an higher quality index compared to the other ones. So from here you will be able to see all those leadership board, and then you can decide which model that you want to use. Now, more important thing is like once we have decided which model to use, now we need to decide about the knowledge that we are going to give to those models. So that means probably a RAG kind of a model. So in this case, we can decide what kind of an flexibility or what kind of an information that we want to pass on to those models. So let's say, for example, we want to get the information from SharePoint. If in case we want to get the information from other sources, we can do that. So that can be done with something called as tools. So from the tools here, we can see we do have various tools available. For example, you want to connect to WorkIQ in Microsoft Teams. If in case you want to connect to Azure SQL, even if in case you want to connect to the Azure Cosmos DB and everything, we do have various tools available. Few of them are MCP tools, even few of them are kind of a custom connectors. And one more thing is, even you can build your own tool or your own connector here. So that is another thing. After that, we do have various solution templates available. These are the easy to get started kind of samples which are available for you. Let's say, for example, you want to create just the AI chat based kind of an application, a basic chat application, which is integrated with your data as well as the telemetry. You can use this kind of a feature, and then from here you can get more information. But you can see like this one is using Foundry tools, Azure OpenAI, and most of the things. So you can see what are the key features, how it will work, and everything. So this is going to be your starter point. If in case your scenario fits into any of these, you can use that. And again, obviously, you'll be able to extend that further as well. Okay, so that is basic that you can start with. Now let us go on to the build. So in this build, this is a place where you can start creating your own agents. Before you start creating the agent, just decide which models you want to use. So this is a place where you will be able to deploy all those base model. So in the discover section, select which model that you want to go ahead for the deployment. From here, get them deployed. Okay, so once you deploy the model, those models will be available to you. Right now, I just have got a couple of models installed here, GPT-4o and the embedding model. But you can deploy as many models that you want, and again based on the consumption of that you will be charged. Again, for example, if in case you have got any custom models created, right now it is into the preview, but you can add your custom model as well, and then you can start using those. Even you will be able to connect to the any of the AI services. So right now even we do have voice as well as text to speech to text, all those kind of an AI services available. Even if in case you want to deploy any of the fine-tuned models, so that means take a base model, and then get it fine-tuned on your knowledge, you can do that. It can be more configured from this area, fine-tune. Now, let us go on to the very important information here, which is about tools, okay? Because tools will give the hands to your agent to perform certain work. So from here, you can go onto the tools, you can click connect to a tool, and then here you will see three categories of tools. First one is the configure tools. Right now, we just have only three tools available here, one for Fabric, one for SharePoint, and then the other one for the Azure Automation account. These are the pre-configured kind of a tool so that you will be able to connect to your SharePoint sites, Fabric data agent, as well as the Azure Automation account, which do exist into your same Azure tenant, and then do the work from there. Again, we do have various catalogs. So almost list of catalogs which are available from where you will be able to connect to various other sources within your ecosystem. That means within Microsoft ecosystem, like Microsoft Azure, Microsoft 365, or even the outside. Even for example, if in case you want to connect to GitHub, you want to connect to the other data sources, you can do that as well. Okay, so these are the things which are possible. Apart from that, if in case you do have your own services, your own APIs available, you can convert that as a tool as well. So let's say if in case you have got your open API tool created, you will be able to connect that to the Azure AI agent and use them for any kind of an processing. Secondly, there are MCP support available. So if in case you want to connect to your own MCP servers that you have created, you will be able to do that. And the last one is very important, which is agent to agent kind of an protocol. So that means we will be able to connect to the agent which does follow that A to A kind of an protocol and then have a connection with them. All right. So this is very informative thing. Like these are the things that you will have to create so that you will be able to create your agent, connect them to the multiple tools as well as to the knowledge. So again, here we do have knowledge. If in case you want to connect to any of the knowledge source, so it is for example, Foundry IQ, you will be able to use that. And if in case you have created any indexes, like the one that you can see here, you will be able to connect to those indexes as well. Now, if in case you go on to the data, this is a place where you will be able to see all of the data sets that you have created. From why those data sets are important, probably let us go on to that. But before that, let's start with creating our basic agent. Okay, so you can just simply click onto the create agent window here, and then from here you will be able to create your agent. Okay, so the agent that we are going to create here is like I will just call it as a hotel info agent. So this is the agent which is going to give us some information about hotels. So we'll click on create, and this is going to create your agent. And again, for example, if you have observed there was a hosted agent kind of an option as well, which we are going to explore. Again, from here, we can select the model. And as I said, I just have got two models deployed into my tenant, which is DPT40 and the embedding model. So that's the reason I get option here to see this deployed model. But again, I can choose any of the other model, get it deployed and use them for my agent. One more important thing is one agent can miss at least one agent can connect to any of the model. So not necessarily all of the agents in your Microsoft Foundry should connect to the same model. Okay. In the instructions, I can define the behavior for this agent, saying like, here is the AI agent, which will help user to find the hotel related kind of an information. Now, if in case you want this particular agent to look out for the information onto the internet, you can have this web search turned on. In my case, I do not want this agent to look out on the information which is available onto the internet. So I will remove that because I want this particular agent to follow the RAG pattern which I will give. So that means the retrieval augmented generation, the files or the information which I will give specifically to this agent, it should only look out the information from those sources only while answering the questions. Now to do that, what we can do simply is we can click upload files, and then we can browse for the files. We can get those uploaded here, and then we'll be able to use them. Now, for example, for many of you who already have seen this kind of an experience in the old Foundry portal, you obviously have noticed that there are two major things which are missing here. So one thing is we do not have to select the Azure data source. For example, we do not need to select here the Azure blob storage, And secondly, we do not have to select any Azure AI search here. Okay. Now you must be thinking, in that case, is it not using that? No, it is not like that. It is still using that. But again, here we have got concept of the vector searches. So that means you can still create your indexes. You do not need to host a separate kind of an Azure AI search as well as the Azure Blob Storage into this ecosystem, but it will be using them. So now what I will be doing is I will be using this index which I already have created, and from here you can see that this contains information about various PDF, which contains information of the hotels in which our maybe our business operates onto any of those cities. Okay, so I will be just using this. I will click on attach, and then this agent is going to use this as a tool. Another thing is, if in case you want to connect to any of the knowledge, so let's say for example, if in case you want to connect to the Foundry IQ, you can do that. And more importantly, if in case you want to connect to the memory, even you will be able to configure the memory. Right now, the service which I created is into the East US region, where it does not support memory creation, but you can do that. And again, we do have the guardrails for supporting the responsible AI. Okay, that's it. So I will just click on save, and then our agent is ready. So it is almost kind of an low code, no code kind of a thing, wherein we were able to create the agent very easily. So what I can do from here is like, I will say like find me um, hotels in Dubai, and then it is going to look out for the information which is available onto these tools or these knowledge sources which we have given, and then it will give us the information. Okay, so this is the information that it gives, and from here you can see there is a citation as well. But more importantly, we do have now YAML support for this. So we'll be able to make this as a deployable kind of an agent. Even we do have the code available so that I can take it out as a code and then get it deployed. But more importantly, in this ecosystem of new Foundry portal, we do have something called as publish at the very top. Because if you had used the old Foundry portal, we did not had this option directly, but right now from here we can publish, and then from here we'll be able to publish this agent to Microsoft Teams as well as to the Microsoft 365 Copilot. So that means I do not no longer need to take this code outside, create a bundle out of it, get it deployed into the Microsoft 365 ecosystem, but I can just click on only one single button, and this agent will be deployed onto the multiple other ecosystem as well. So for example, Microsoft Teams as well as Microsoft 365. All right. So that was very basic of like how you can create the agent. But more important to note, like you need to be very much aware which model you are going to use, as well as which tools, which knowledge sources that you are going to use here. Okay. All right. So let us stop here. We will go on to the next topic. Like we have one agent created now, but how we'll be able to create the connected kind of an agent scenarios.
So let's see what exactly these connected agents are. So at its core, it's a multi-agent architecture available in the Foundry agent service. So instead of building the one massive agent that tries to handle everything, you design a system with a primary agent that acts as a coordinator and multiple connected sub-agents that is specialized in a specific task. So the primary agent interprets the user's prompt, determines what kind of task it is, and then delegates it to appropriate sub-agent. And think of it like a manager who receives a request and assign it to the right team member. So what makes this powerful is a natural language routing. So the main agent does not rely on the hard-coded if-else logic to decide where to send the task. So instead, it uses the AI to understand the intent and route accordingly. Okay. So next thing we are going to discuss about the key features. So the first is a simplified workflow design. So by breaking the complex task across the specialized agents, each one has a clear focus responsibility. Also, it helps us to reduce the complexity of any single agents and makes the overall system much easier to understand and maintain. Second one is a no custom orchestration required. So this is the big deal. So traditionally building a multi-agent system meant the writing the custom routing logic, figuring out which agent handles which request and managing the hands off. Okay, so handling the edge cases as well. So with the connected agents, the main agents uses a natural language to route the task automatically. So you just described when each sub agent should be invoked and the system handles the rest. Third one is easy. is extensibility. So need to add a new capability like translation or the risk scoring. So just create a new agent and connect it. You don't have to modify the main agent at all. So with that, let's go ahead and check for this ticket triage agent. So I think we have a limited time, so we can just go directly in a demo, and inside a demo, we can just cover that one.
All right. So the demo that we're going to do here is for the ticket triaging. So that, let's say, for example, when a support ticket comes in, the triage agent will read that information and delegate that to the three specialized sub-agent that we have created here. So firstly, here we have got this effort agent, which will help us to estimate the work which is needed to work on that ticket. So that work could be small, medium, or large bucket. Again, we do have team agent, which will help us to identify like which team it should be assigned to, whether it is a front end team, back end team, infra team, or a marketing team, and then that ticket can be assigned to that team. And thirdly, we do have the priority agent, which can decide the urgency of the ticket, like whether it should be handled on a high priority, medium priority, or low kind of an priority. Okay, so this is the scenario that we have got. But now let us go into the demo and then see like how we'll be able to do that. Okay, again, these are few of the steps, but probably instead of going through them into the theory, let us go on to the demo and see how we will be able to create those connected agents. So to show you that demo, I will be going on to the Microsoft Foundry old portal, because as of now this kind of a functionality, it is not that fully available onto the new portal. So I will switch back to the Foundry portal, the old kind of a Foundry portal. And again, this is a place where we started creating our agents. So again, from here, I will go on to the agents. To save the time, again, we do have pre-created few of the agents, but I will go on to each of the agent to show you like how those agent works and how those are connected. So right now here you can see we do have agents. These are the four agents which are here, but let us go through them one by one. So firstly, we do have this priority agent. So this priority agent will help us to assess the urgency of the ticket, whether it should be high, medium, or low. So again, we are giving some kind of a logic here. For example, if the issue is user facing or it is blocking, then it should be high priority. If in case it is time sensitive but not breaking anything, then it's medium. And if in case it is just cosmetic or non-urgent task, make it low. So this is the only thing. Again, if in case you have got your own scenarios, probably you can add that as a knowledge as well. So if in case you are maintaining your own documentation or own methodologies, you can add that here as well. Second agent that we have got is a team agent. So again, this team agent will help us to decide which team that particular ticket should be assigned to, whether it should be front end, back end, infrastructure, or marketing. And then it will just help us to identify the team that should own that ticket. And then lastly, we have got the effort agent. So this effort agent will help us to estimate how much work that each ticket will require. And again, we want to get it into the buckets like small, if in case it can be completed in a day, medium, if in case it is going to take 2 to 3 days, and large, if in case it is a multi-day effort or maybe a cross-team kind of an effort. Okay, so this is the three agents that we have got here. But now let us come to the main agent. So this main agent is a triage agent, and this agent is going to use or connect to all these three agents, and then it is going to call this agent whenever needed and get the work done. Again, for this agent, we are using model deployment. And again, one more thing that I want to explicitly call out here is like we can have different models being used by each of the model or each of the agent. It is not at all necessary that all of the models they should use only one deployment. So probably, let's say for example, to calculate the effort, we need to have some deeper analysis. In that case, we can go for GPT-5 or any of the other model as well. And let's say this triage agent, they don't need to go into the merge detail. So in that case, we can just simply go with GPT-4. Okay, so that's it. So what we are going to do here is like we have given the instruction like this agent, it needs to triage the given ticket, and then based on the connected tool, it should determine the ticket's priority, team, as well as the effort that it will need. Okay, so that means we want this particular agent to perform three things. First thing is find out the priority. Second thing, find out the team who should own, and then it should find out the effort. Okay, so that means definitely this agent is going to need three capabilities, or it need to rely onto those three agents. Now, to make this particular agent aware of the other agents, we do have something here called as connected agents kind of a functionality. From here, you can click on add, you can select the agent. Right now, since I have consumed all these three agents here, connected them, I'm not able to see any option, but definitely when there will be multiple agents, you will be able to see them. You can give it a unique name, and this is a place where we need to give the triggering point for that agent, or when that particular agent should look out for the information. So let's say, for example, in this case, what we have done is for the effort agent, I will open up that, and here you can see that the triggering point is effort agent should be triggered when this main agent, the Raj agent, want to estimate how much work each ticket will require. Similarly, we do have the priority agent connected here, which should be triggered when the triage agent want to assess the urgency of the ticket. And then again, lastly, we have got this team agent here, which should be invoked by the triage agent when it needs to decide which team should own the ticket. Okay, so that's it. So this is how we'll be able to connect the agents. What I'm going to do now is that I have triage agent selected. I will go on to the try in playground. And what we are going to do here is like we are going to give some kind of an service now ticket that got assigned to our team. So here we will say like users are unable to log in to portal. Okay, so let's say, for example, this is the problem statement that we have received from our ticket. So what it is going to do is it is going to connect to the knowledge sources, or if in case it has got any of the connected agents. Okay, so it is going to connect to all those agents. So let us wait, and from here again you can see like it has started looking for those connected agents, because it needs to look into those three things like the team, the priority, as well as the efforts. So it has started looking onto those connected agents, whether those connected agents can help here. And from here you can see that it was able to get to the priority. The priority should be high because it is a blocking issue. Team, it should be assigned to is a backend team because it is related to the login functionality. And the effort estimate is medium because it might take 2 to 3 kind of days. Now, the thing is how we can decide whether it has called those three agents. So to do that, we can simply click onto the view run info, and from here you can see that it has connected to those three agents one by one. Firstly, using the same prompt that we had given, it connected to the priority agent and got the priority as high. After that, it connected to the team agent with the same query, and then it got the information that it should be assigned to the backend team with the explanation why. And then again, it connected to the third agent, which is the effort agent, with the same query, and then it got the effort estimate should be medium 2 to 3 days. And this was the justification, because obviously it will need some changes to the backend, but obviously it will not need any cross team kind of an efforts and everything. So that's the reason it came up with the effort as probably 2 to 3 days. And we got one agent which is calling multiple agents to get the work done. So right now, this price agent is calling 3 agents to get to the information or to answer our question. Okay, so this is how we'll be able to connect to the multiple agents. Now, again, let us see like if in case now we have got agents created into one ecosystem, can we call them from other ecosystem? Yes, definitely we can do that. So that means it is not limited that only agents which are created in Microsoft Foundry, they will be able to communicate each other, or only agents which are created in Copilot Studio, they will be able to communicate each other. Not at all. We can have one agent which is created in Microsoft Foundry can talk to the agent in created in Copilot Studio and vice versa. Okay, so that will be able to do. Again, these are the things that we need to do, but probably I will just simply show it to you in a demo, like how we'll be able to do that. So in this demo, what we are going to do, the first demo that I showed, wherein we created the hotel information agent in Microsoft Foundry, we're going to call that agent from Copilot Studio. Okay, so to do that, let me again go back. So if in case you forgot that agent, this is the agent that we have got, hotel information agent, hotel info agent. And we are going to call this agent into our Copilot Studio. Okay, so let me quickly go onto the Copilot Studio. So this is the Copilot Studio that I have got, and here I already have got one agent created here called as tourism agent. Again, this particular tourism agent has got information from various sources. For example, we have got Dubai as well as Thailand tourism information given to it so that it can use it as a knowledge source. Another thing, if in case I go on to the agent, this agent is already connected to the other agent which is created in the Copilot Studio. But now we are going to connect this Copilot Studio agent to the agent which is created in Microsoft Foundry. To do that, I will click on add an agent, and then from here we'll be able to create the or connect to the other agent. So this agent that you see here, the flight booking agent, is the new child agent, which was again in the same ecosystem of Copilot Studio. So that means tourism agent was calling flight booking agent, which is a one-to-one kind of a scenario wherein one agent created in Copilot Studio is calling another agent created in Copilot Studio. But now what we are going to do is that we are going to use the connected agents. So we are going to connect to the external agent. So that agent can be in Microsoft Fabric, Microsoft Foundry, Microsoft 365 Agent SDK, or even we can use agent to agent or A to A kind of a protocol. In our scenario, we are going to use this option, Microsoft Foundry. I already have this connection, but if in case you want to create a new connection, you can click on create new connection. The only authentication supported at this moment is Microsoft Entra user login. And here you will have to specify your Azure AI project endpoint. So to do that, you can again go back here and then you can click onto the home. And then from here, you are going to get the project endpoint. Okay, so you can, you can use that project endpoint to give it here, and then you will be able to connect to Microsoft Foundry or Azure AI Foundry, which was the old name. Once you connect, that's it. You need to now give it a name. Okay, so I will be calling this as the hotel information agent. Oh. And then description, I can use same thing like maybe help user find the hotel rated information. Now, main important thing here is like the agent ID. Each of the agent that we create in Microsoft Foundry has got an ID. So again, if you go back to the build, this is the ID which is of that agent. So I will again click on that hotel info agent, copy that, and we will add it here. Okay, that's it. And once you click add and configure, this particular agent has been configured. Now, all of the requests which will come to the Copilot Studio agent, if in case needed, it can use the hotel information agent to call, and again those call will obviously go to the Microsoft Foundry agent, and then the information will be retrieved back. Okay, so now let us use this test panel to test it out. So I will say like suggest me hotels in London. Okay, so what it is going to do is it is going to look out for the agents which are there, and then it will find the tourism agent will find that okay, there is a agent called as hotel information agent, which will help us in this case. Okay, so let me just try to do it one more time. But okay, now from here you can see it has started execution, and then it should work on that. Okay, if in case it still doesn't work, let me just try to give another. Oh, sorry, I think I just copied the wrong way. So I will say like. Oh. Suggest me hotels in London. Okay. All right, so now it will find out that okay, it has got a connection to the agent, which is the agent in Microsoft Foundry or Azure Foundry. So you can see that this tourism agent has invoked this agent which is in Microsoft Foundry. So this tourism agent is in Copilot Studio, but it has invoked the agent which was in the Microsoft Foundry, and we got this information. Okay. Now, obviously, please do not trust me as I say, because we need to find out whether it has already whether it has really called the Microsoft Foundry agent. So to do that, we will go back to the Foundry agent. So this is the hotel information agent that we are configured. Now, if you go onto the traces tab, this is the place wherein you will be able to see all of the responses. So for example, if you remember the very first time when I invoked this agent, this was the very first call which went probably half an hour before when we created that agent. But let me just open up the very latest call which came to this agent, and then from here you can see like it has translated that call into the find all recommended hotels in London. Okay, and then it has given me the information, the message. So this message includes all of the hotels, for example, the Buckingham Hotel, then we have got the City Hotel and so on. And that is the same information that we are seeing here. Okay, so the Buckingham Hotel, City Hotel, and so on. Okay, so that means we will be able to call agent from Copilot Studio to the Microsoft Foundry as well. All right, so with that, let us move ahead. And the last part that we just wanted to cover for this is the hosted agent. Okay, so now that we are moving into the final section of this talk, so we will talk here mostly about the hosted agents. Okay, so these hosted agents, they are kind of an agent which will help you to create your own orchestration or the containerized kind of a system. So first thing is like it will help you to bring your own code. Secondly, it will help you to containerize your agentic AI. Thirdly, it will give you the managed kind of an infrastructure. And then fourth thing, they are kind of an enterprise grade. So you can, so that means it already comes with the built-in security, compliance, governance, as well as the observability. So you don't need to worry too much about the hosting of this. Now, how to create those hosted agents. So to create the hosted agents, or before I jump into creation of hosted agent, let me again go back here. So if in case I go onto the agent section, here you can see that we do have agents. So that means I can click on create agent. I can start creating the agent. One thing about the agent is like agents are non-deterministic because they do use AI. So we cannot control how the agents are behaving. But again, if in case you want to control that, we do have something called as workflows. In the workflows, we can give the deterministic nature to the AI. So let's say, for example, we want all of this agent to run in a sequence. So we can do that. So here is the start. So we will click on to the start and then we will call one agent. Once that call is done, we want the other agent to invoke. We want to pass the information from one agent to the next agent. So all those things that we can do with something called as an workflow. Now the third thing here, which is probably invisible, which again falls under the agent section, which is the hosted kind of an agent. So that means you are creating your own agent, you are giving them the hosting environment. So to do that, we'll have to go onto the Visual Studio Code, and we do have here something called as Microsoft Foundry Toolkit. It is going to retire in June, but it is already covered as a part of AI Toolkit. So from here, I have already connected to my Microsoft Azure Microsoft Foundry. And here you can see this is the project that I have connected to. And from here, I can just simply click on create agent, or I can press Control Shift P to invoke the agent creation. And I will select Microsoft Foundry, create new hosted agent. I can select whether I want to create this agent into the Python or C#. So I can select Python. I can select any of this API. So we will not go into those details. So let's say this is the API that we're selecting. We'll select probably Echo. We'll select the default folder, and then this particular agent is ready. So now from here you can see it has created the Docker container for your agent. So this is the Docker container in which this particular code will run, and then this will be hosted in as an agent file. Okay, so again we do see agent YAML here. And again, this is the documentation for that. This is simply going to be an echo agent, which will just give you the echo. That's it. Okay. So again, for the container, now that when we want to deploy that to the Microsoft Foundry, again, just open the command palette using Control Shift P, get it deployed. The agent YAML here contains all of the information about the name of the agent, the Docker file, the ACR, container registry, and the resource size as well. Okay, so we can just simply click on that. Probably I'm not going to deploy this right now because we do not have time. But here you can see we do have default ACR Azure Container Registry option, or even we can customize that. So if you go for the customization, you can select the server where we want to get it containerized and everything. So you can do all those things. And then once you are done with your deployment, you should be able to see the agent here. And here you can see that, okay, so I will have to change my project. So this is the project where I have it deployed. So here you can see that we do have certain hosted agents. So I can run those agents to get the information. Okay, so I can pass on the messages to this agent, and then we'll be able to get our work done. Okay, so that is another simplistic way, like how you can create your own hosted agents. All right. So with that, I guess we are just on time. So once again, thank you very much for joining us today. I hope this session give you multiple options to create the agents, how you can create multi-agent kind of scenarios, how you will be able to connect to agent created from one platform to the other platform. Probably I will also try to cover A2A kind of a protocols, maybe in any of the upcoming session. But definitely I will be answering the questions in the chat offline. But again, if in case you have got any question, feel free to get in touch with onto LinkedIn, YouTube. So this is a place where we always welcome the new connections, and then want to discuss out more other things. All right. So with that, once again, thank you everyone for attending. Thank you organizers for giving this opportunity. And then back to you, Amit.
Thank you for the wonderful session.
Yeah. Thank you. Thank you. So I can see there are a few questions in the chat, but definitely I will answer those, and then we can make a space for the next speaker. But quickly onto the very quick questions here. Like there is a question from Neha. Like, do we have any license cost? Obviously, this comes under Microsoft Azure. So you need to have Microsoft Azure subscription, and then you will be able to use Microsoft Foundry. Second question from Girish. Again, it is related. Microsoft Foundry, is it for free? If in case you want to use it for free, you can get the Microsoft Azure trial license, where it comes with almost 200 USD, and you can use it for free. Rest of the questions I can answer offline. Yeah.
Hi, Nanddeep. This is Gangadhar. It said there's one more question from my side. So, is there
Yeah.
any major difference between the agents that we are trying to create from Microsoft Foundry and Copilot Studio and agent to agent? Or
The
those are the
major
same functionality?
difference,
Yes.
they almost offer the similar kind of an functionality, but Copilot Studio is mostly for the low code, no code kind of an option. Wherein, if in case you want to create your own orchestration which is controlled by topics, you can do that, or even you can connect to various sources. Microsoft Foundry takes it one more level ahead, wherein you will be able to fine tune your model as well. You will be able to index your models as well, and even you will be able to create your own tools, connect to them. So these are kind of a bit advanced functionality which are supported into the Microsoft Foundry. And again, as I said, if in case you want to create the workflows kind of a thing, you will be able to do that in Microsoft Foundry. But again, these are the two platforms which are available. I will not compare them very much side by side, like this is the best one or that is the best one. But in very nutshell, if in case you are looking out for low code, no code kind of an option, no complex kind of an model selection and all, you can go with Microsoft Foundry. But definitely, you can go with Copilot Studio. But definitely, even Microsoft Foundry with new Foundry experience, even it is a low code, no code kind of an platform. Yep.
Okay, got it. Thank you. Thank you
Yeah,
both
thank
for the
you.
insightful session.
Yep. Thank you.
So, Amit, shall we start the next session?
we have our next speaker as Nandan Hegde. So we are very excited to welcome you, an experienced data architecture trainer and Microsoft Data MVP with deep expertise in Microsoft Fabric, Azure, and C+ technologies. Recognized as a Microsoft Fabric super user, Azure community champion, and multiple time MVP awardee. Nandan actively contributes to the tech community through training, blogging, and knowledge sharing the data and cloud ecosystem. Yeah, looking forward to your session, sir.
Thank you for the warm welcome. So, hello everyone. A very good afternoon to you all. Thank you for joining this session on modern data integration patterns, that is GraphQL in Microsoft Fabric. Before we proceed, a little bit about myself. I am Nandan Hegde. I work as the Director of Data and AI at Synapse. I'm a part-time trainer at Cloud Labs or Spectra organization. And as called out, I'm a Microsoft Data Platform MVP and a Microsoft Fabric super user. You all can reach out to me via my LinkedIn profile or via my Twitter profile. Now, enough about myself, and let's move on to the crux of the topic, that is GraphQL. Now, what is GraphQL? Most of you might be familiar with the QL terminology, that is the query language. So, what is GraphQL? So, GraphQL is basically an open source query language that was initially created by Facebook, which then became open source, that is mainly designed for APIs. So one can consider GraphQL as an alternative to the REST API. And there are multiple benefits or comparisons across when to use a REST API to when to use a GraphQL. Now, in case if I have to explain GraphQL in layman terminology, let's think of an analogy. That is, let's think of a restaurant. Now, in the traditional REST API world, you order from a fixed menu, meaning one endpoint gives you customer details, another gives you order details, and another gives you payments. But imagine if you want everything, you may need to place multiple orders across customers, orders, and payments. But with respect to GraphQL, it's like telling the waiter exactly what you want on one plate. That is, give me the customer name, the last three orders, and the total balance in one query rather than having it across multiple queries. And in that case, the server gives exactly that. Nothing extra or nothing missing. That is the difference between a REST API and a GraphQL. Meaning, in case of a GraphQL, it enables users to fetch data from multiple sources using a single query. Whereas, compared to REST API, GraphQL is much more flexible and allows users to retrieve only the data that is needed, thereby reducing the amount of transfer that is happening between the client side and the server side. And it also uses a single endpoint, reducing the number of requests made to the underlying server. Now, what does that mean? Correct. Now, these are the terminologies that I explained in a couple of minutes with respect to that restaurant analogy. So, basically, let's take an example pertaining to that. So, this majorly represents the difference between a GraphQL and the REST API. If I have three different entities, I have to query it three times. Like if I want the user details, if I want the posts detail and the comments detail, I have to query it three separate times via the REST API. But in case of GraphQL, I have a single endpoint via which I can combine, query the users, posts, and the comments aspect. So a single flexible query fetches data in GraphQL while REST needs multiple endpoints. So in case I have a user profile screen, I have to get the corresponding user ID. Corresponding to that user ID, I have to get his orders and his payments. So I have to make three separate API calls. And each call may return lots of unnecessary data. Now, what do I mean by that? We'll take a look in a couple of minutes. Whereas in case of a GraphQL, I just have to pass a single request. That is the user ID and the name and the corresponding last three orders that I want with the amount and the balance. So a single response itself provides me with only the required fields that I need rather than providing me unnecessary data, which in turn reduces the amount of data that is getting transferred from the server and the client side of the things. That is the benefit of GraphQL. Now let's understand in detail with couple of examples with respect to GraphQL and REST API. Now, as I said, in case of GraphQL, you can fetch exactly the data that you need. Meaning, in case of REST API, it returns huge unused data. What do I mean by that? Let's say that the REST API has multiple, for a corresponding attribute, it has multiple columns. Entity, it has multiple attributes like name, age, address, phone, preferences, and let's say 100 more columns. But in front end, I only need the name and or the age. So in that case, unfortunately, in case of REST API, I cannot control that. It would always provide me the entire data set. Thereby, even unused data, I am querying it, thereby creating load on the server. But in case of GraphQL, I can only request only the attributes that I need. So in this case, I can only fetch the name, but it does not mean that I cannot fetch other columns. I can by adding some additional attributes within the query itself. So it allows the user with the flexibility to only request the data that is needed, thereby benefiting the tag that is fetch exactly what you need. Now the fewer API calls we all saw in the previous slide as well, correct? That is, REST often needs all the endpoints to create a relationship between them. Whereas GraphQL combines them into one request. That is, it provides us with one common endpoint. Now, in case of complex data relationship, correct? So now let's think of how do I want to represent complex relationship? When I say complex relationships, let's consider that I have a connection with another Microsoft MVP in LinkedIn. He has two other connections and one is a common mutual connection between us. And that mutual connection has two other MVPs as his connection. So as and when your network grows, your relationship becomes much more complex. In that case, REST API becomes difficult to do that nesting over. And that's where the GraphQL comes in play. It makes it easy to understand the relationship between the data. So GraphQL naturally helps us handle connected data. Like every customer would put some orders. Now orders are pertaining to the products and every product would have some reviews. Now in case of REST, I may require many changed calls. Whereas in case of GraphQL, I can fetch all in one structured query rather than multiple change call. So that is the benefit that the GraphQL provides us. Now, there are multiple core GraphQL operations that one can do. And whatever I'm discussing as of now is not specific to Microsoft Fabric. It is generic GraphQL concept, as GraphQL is an open source language. Correct? It is not specific to Microsoft Fabric. We'll take a look in Microsoft Fabric in next couple of minutes. So now, in case of GraphQL, you can create three core operations. One is you can query the data. That is the normal aspect, correct? So in case if one has to query the data, one can consider it as similar to, in case of SQL terminology, one can consider it as select keyword equivalent for querying the data. Then there is another terminology that we use in GraphQL called mutation. Mutation basically corresponds to the command that enables data modification on the server side. So basically one can consider it as the CRUD side of the aspect, that is create, update and delete statements within the SQL. But there are some other custom operations also that you can perform in GraphQL aspect. And the third core operation is the subscription. Basically, GraphQL allows subscribing to real-time data, event-based data. But a point to note, Microsoft Fabric GraphQL as of today only supports query and mutation operations on the GraphQL with the API aspect. Now, I made a couple of statements with respect to Microsoft Fabric. Correct. Now, let's understand what Microsoft Fabric is. So, Microsoft Fabric is basically a software as a service that Microsoft has created that provides everything, right from data movement to data transformation, data storage, real-time intelligence and analytics, and reporting. And all of this is hosted on one logical layer called OneLake. So, Microsoft Fabric is basically an end-to-end data and analytics platform designed for enterprises that require one common unified solution. So one can consider it as one-stop shop for everything in your data world, right from data extraction, data ingestion, data preserving, and data sharing. Now, that's where GraphQL comes in as a part of the data sharing aspect. Now, as an organization, as an enterprise organization, I might have a requirement to share data with external vendors. So now let's consider that I have my own startup called Data Sharks, wherein I do conduct training sessions. Now within my organization, I do want to hire some external trainers as well. Correct. So for that, I reach out to a contractual team to start or the external recruitment agency to hire the resources. So at that time, I do have to share certain company details with them, correct? Like what are my locations where my company is present across, what are the current resources present across, etc. Now, within Microsoft Fabric, there are internal storage layers like databases and other aspects. One can consider similar to Azure databases and other aspects. Now, in order for me to grant users within my organization's access on the data, I can create Power BI reports or I can directly give them access on the database, which ideally one should not do, but we do give that read-only access. But imagine if I have to share data with external vendors, they're outside my particular tenant. So in that case, and does it make sense for us to give them direct access on the database, which might have some additional data? No. So that's where GraphQL comes in, wherein one can share data with external vendors via the API for GraphQL feature. So GraphQL is a managed service within Microsoft Fabric that Microsoft Fabric provides. Remember, GraphQL is a generic concept, but within Microsoft Fabric, Microsoft provides an API for GraphQL managed service that allows for easy integration between our data sources and the data consumers. So let's quickly go on to the practical side of the things before too much theoretical. Correct. Now, as I said, I have to create a GraphQL. So for that, I do need a dedicated a Fabric trial capacity or a dedicated Fabric capacity. So now I'm within a Fabric workspace. So here, I create a new item and I search for GraphQL. Can you see here? There's an option called API for GraphQL, wherein you can create an API for GraphQL to easily connect your applications to Fabric data sources. Now, let me provide a name, GraphQL 2. You can provide any name, correct, that you all want. Now let me go ahead and create it. So now a GraphQL interface is getting created. Now initially it is asking me to connect to some of the data sources. Now while connecting, it provides me with two options. One is I can connect to the internal Fabric data sources. Okay. let me explain the data sources that are present in Microsoft Fabric. So you have something called as Lakehouse. In data ecosystem, one can consider Lakehouse as equivalent to the data lake concept. Data lake is the one that helps you preserve structured, semi-structured or your unstructured data. You have your warehouses, you have databases and multiple other databases. Now, in case of GraphQL, if you want to connect to Fabric data sources with single sign-on authentication, what does that mean? Imagine whoever user is accessing the API, the data that needs to be output to him must be based on the authorization side of the things. Meaning, only if the user has access on the underlying data. As I said, GraphQL, consider GraphQL as a bridge between your underlying data and the user. So, only if the user has access on the underlying data, meaning he is authorized to access it, then only allow him the query. That's the single sign-on authentication. Whereas, in case if you want to, SSO is supported only for Fabric internal data sources. But in case if you want to connect to some external source, and as of today, the external source that is supported is an Azure SQL database itself, and internal Fabric sources you can use via save credential. In that case, you'll create a connection and any user who has access to that endpoint would be able to access the data because it would not authenticate and authorize via the user's personal identity, but via the saved credential itself. So in our case, let's go with the single sign-on aspect. Now, if you'll see, it provides me multiple internal data sources that I have created and which I have access to. A SQL database, warehouse, mirror database, analytics endpoint, and other aspects. Correct. So for now, let me proceed with the SQL database. Now, within the SQL database as well, I can go ahead and select which all tables do I want to provide it within that. Let's give a couple of minutes. So now here, if you see, I want to select customer table, product description table, product model table, and product model product description table. Let me take a look. Product model product description table. So I can explicitly select which all data I want to be present within my GraphQL endpoint. So for now, I have selected within the database, within the SQL database, 4 different tables. Now, once you connect to a data, that is, after connecting to one of the data source, the original canvas that we saw, correct, gets divided into multiple sections. That is the schema explorer, query editor, query variable editor, and the query result set. Now the schema explorer basically displays all the data sources and the available tables and schema for the item. What do I mean by that? Does it mean that I can only select one of the data source? The answer to that is no. I can select multiple data sources. So now let me click on get data again and let me select a warehouse in this case. So the schema explorer displays all available tables and schemas for the corresponding item. Correct? Let's wait for the tables to load. It would take a couple of seconds. So here I select the date and the geography table now. And then I load that. Now if you all can see, within the schema explorer, I am able to see. Let's wait for a couple of seconds. We'll be able to see the different sources, that is the database as well as the warehouse, and the database and the warehouse and the corresponding tables associated with that. And I can also see which all columns are present within that. Then is your query editor. Now, query editor is used to write queries for the data. Now, query variable editor is where you can define variables to parameterize something within your query. And your query result set displays the results of your queries. So now let's go step by step. First is, I want to get the top 10 record. First meaning, in case if I have to convert this equivalent to the SQL aspect, in case if I want select top 10 records, correct? So there I'll have first 10 records corresponding to every data table, a corresponding query gets created here. So if you see for the customer table that I imported, a customer query equivalent got created. Now I can disable this so that that won't be consumed, that won't be able, no user would be able to consume that. But in this case, I want to get the data from my customer table. So for the corresponding table, I have the equivalent query that has been created, customers. So this is the syntax wherein you will have the query as the keyword, provide the corresponding query name, that is customers. Then first is a keyword similar to top 10 records, similar to top record. And in this case, I want top 10 records. Items, it stands to the corresponding columns or attribute that I want to fetch from the corresponding entity. So in this case, I want top 10 customer IDs. So now once I execute this, I can see that it has provided me in the form of customer ID 1, 2, 3, 4 and aspect. But if you all see here, within the customer table, I have multiple columns present. In case if it would have been a REST API, I would have got all the column details, even if I just needed the customer ID itself. That's where GraphQL comes in, which helps us reduce the number of data movement happening from the server side to the client side. Now imagine that I want to bring in some additional columns. So in that case, let's say I want the title of that corresponding customer, whether he's a Mr. or a Mrs. So I can see that most of my customers here are it's a joint aspect. So whatever attributes I need, I can bring the corresponding attributes. I can bring in the first name as well. I want their first name. And I can execute the corresponding queries. So this is basically GraphQL simple query aspect. Now let's increase the complication of the queries step by step. So up till now we saw that I only queried the customer details, correct? Now imagine that if you remember, let's go back to the slide that we had, correct? Here we saw that, imagine I have multiple tables or multiple outputs. GraphQL helps me execute it in a single interface itself. And we'll take a look on that aspect. But before that, I forgot to explain one thing, or I did represent, but within GraphQL in Fabric, these are the different sources that are supported. That is the Fabric Warehouse, Fabric Lakehouse, Mirror Database, Fabric SQL Database, and this is an external source, that is the Azure SQL Database. Now, corresponding to that, the operation that one can do is, in case of Fabric Warehouse, Azure SQL Database and Fabric SQL Database, one can query and mutate the data. Mutate meaning do CRUD operation. But in case of Lakehouse and Mirror Database, one can only query the data. Now, one would guess why only query the data? Why not read the data? It is because in case of a Lakehouse and a Mirror Database, GraphQL is referencing the SQL Analytics endpoint of the Lakehouse and the Mirror Database. And one cannot do CRUD operation via the SQL Analytics endpoint. SQL Analytics endpoint is just a read-only interface that Microsoft Fabric provides. And since GraphQL is referencing the SQL Analytics endpoint, you can only query the data. You cannot mutate the data. So now within a single source, I have the customer table and the product model. Correct. Now corresponding to the product model, I have the corresponding product models queries. Now within this itself, I can go ahead and fetch my corresponding product model data as well. So within this items, this customer table, this query represents the customer side of the things. So now if I copy this and rather than customers, if I add product models, remember this is case sensitive. So even if you see the query, P is small. If I do not add the case sensitive aspect, it would throw an error. So now within the product model, I have a column called name. So let me bring in the name. So now if I execute this, I'll be able to see the customer details, and then I can also see the product model details in one query itself. Rather than executing two separate queries, I combined all the data within one common query itself. That is the benefit of GraphQL. So now we saw how one can execute a single query, how one can execute multiple, how one can extract different entity data within a single query. Any queries before we proceed ahead? You all can unmute yourself and ask in case. Okay, will the graph API request be treated as an interactive or background by the capacity? Today, queries from external sources are treated as background. As I said, GraphQL acts as an interface itself. It's considered as similar to SSMS itself. So it would be treated more as a background side of the queries itself. Now, any other queries before we move ahead? Okay, I'll consider that as a no. So we saw how we can combine multiple entity queries, extract multiple entity data within a single query. Correct. Now imagine that I do want to filter out the data. Correct. Meaning I want the top 10 records of the customer, but I want to filter out customer IDs. I want to only get customer IDs that are less than 3. So in that case, I have pre-created certain queries rather than typing it at runtime to preserve the session time. I'll explain what the query does. So what this query does is, I want to query the customers. Within that, I want top 10 record, but ideally there won't be top 10 records because I'm adding a filter condition. Filter condition is equivalent to the SQL var. So let's assume that I want to execute a query on my database wherein I want customer IDs less than 3. In that case, what would I have done? I would have created a SQL query that select star from the table where customer ID is less than 3. But rather than symbol, you have terminologies called LT, EQ. LT stands for less than. EQ stands for equals. That like the logical comparison. So here I'm using the filter keyword. And what is the filter criteria? When I want to filter on the customer ID, which are less than 3. Now, earlier it said select star. In case of select star in SQL, it helps me fetch all the data. But I only want 2 columns. That is the customer ID and the title associated with that customer ID. So my SQL query would be select customer ID, title from the customers table where customer ID is less than 3. So this is the equivalent of the GraphQL query for the same, wherein since there are only 2 customer IDs that are lower than 3, I was written 2 rows. But now, if you all see here, the scope that I added here was a hard-coded value, correct? Now, would most of the organizations have hard-coded value present across? No, correct. It would want to be as parameterized as possible to get the corresponding set of the data. So for that, there comes a concept of variable. So in case if I have to change this hard-coded value, what I have to do is I have to create a custom query wherein I state that within this aspect, I have created a variable called customer ID. And it is of type integer. And then I am passing this customer ID here. But from where do I provide the value to that variable? It's from the query variables here. So in that case, I'll add the value as 3. So now in case if I execute it, it would again provide me the same aspect. So in case I update it to 1, so a user based on the sorry, did anyone had any query?
No. It was just somebody's
Okay.
mic was open. Yeah.
Okay. So most of the organizations or the downstream vendor prefer the flexibility to get the details based on their criteria. That is the parameter side of the things. And that's where the variable comes into play. Now, if you all would see here, I have two scope of things. I have two different data sources. Correct. Now, couple of minutes earlier, when we were discussing with respect to the GraphQL, we had discussed something with respect to the relationship, complex relationship and other aspects. Correct. So GraphQL does help in creating relationship between the tables. But there are a couple of limitations pertaining to that we'll take a look in a couple of minutes. So the relationship in API for GraphQL is like those in traditional relationship database management system that allows combining data from multiple tables within the same query. They can, but there's the one limitation that is they can only be created between tables from the same data source, not from the different data sources. And these are the references from which this slide was created. But let me now move on to the practical side of the things. What I said, you can create relationship between different tables, but then the different relationship that can be created within the table is only for different tables that are present within the same data source. Meaning I can create relationship between either of these 4, but I cannot create a relationship between these 4 and any of these 2 tables because these are different data sources. So in this case, let me go ahead and create a relationship between product description and product model product description. Now, how do I know that? Because functionally I know. If you take a look at this table, it contains a column called product description ID, which is the primary key for the product description table. So in this case, what I'll do is I'll create a relationship. There's something called as a manage relationship aspect. So I can create relationship. Now, there can be multiple product description ID here, but there can be only one product description ID here. So it is many is to 1. Now from which table I want to create it? I want to create it from product description. But if you see here, I'm only able to see 4 options rather than 6. I have overall 6 tables. It is because you can only create relationship between tables that are present within the same data source. So within product model product description, product description ID, I'm mapping it to product description table and the corresponding product description ID. And then I'm creating the relationship. Now, once the relationship gets created, It takes couple of minutes because equivalent schema is getting created. What I mean by that, correct? So this, if you'll see here, a relationship got created based on the product description column. Now there's an option here called export schema. What this does is, now what this does is, it provides me the entire data and schema details that are present. If you see, it states that I have a geography table and it contains these set of columns, geography ID of this type, data types. It basically contains the metadata pertaining to that corresponding GraphQL. And one thing that I forgot to state is, whatever aspect columns are present here, those are case sensitive. So imagine that, let me change here from title to title. If I execute this, it would fail. It would fail stating that the field title does not exist because the column name is case sensitive, that or the schema values are case sensitive pertaining to that. Now we went ahead and created a relationship. Now why do we create
for the players and as well as for the fans as well?
Can everyone go on mute if possible? Okay, thank you. So what does this relationship do? If you remember the initial query that I executed, that is the customer and the product model, there was no relationship between those two. I was able to fetch two independent data sources within a single query. But imagine if I want to join, like select star from model product description, left join with product description, and I want them as a part of one query itself. That's where the concept of relationship comes in. So in this case, let me paste a query that I've already created, wherein this is my query table, that is product model product description. Within that, I want these three columns. But then from the product description table, I also want these columns. If you remember earlier, we had split it as two separate item aspect. But since now we want everything in one run, it is part of that run itself. Can you all see here? Rather than it coming as two separate arrays within the JSON, it is now a part of nested JSON itself. Wherein I got the product model ID, product description ID, and corresponding to that product description ID, I am getting its description and modified date. When did the product get modified? Another aspect. So one can consider relationship as creating a join equivalent scope of things. I hope you are able to understand the initial query that I executed, via which I was able to fetch the customer and product detail, but both were separate as separate arrays. But in this case, everything is present in one common array as nested JSON. That is equivalent to the join scope of things. Now, finally, let's come to the mutation side of the things. Up till now, we have only been using the query functionality, correct? But then GraphQL does provide us with the mutation capability as well. What does mutation capability mean? So let me go ahead and parallelly connect to our database. So this is my database, which I had imported as a source within my GraphQL. Now, if you'll see here, by default, whenever I imported certain tables, multiple mutation, similar to how queries got created, mutations also got created, like create customer, update customer, delete customer, create, update, delete, create, update, delete. But then if you see here, for date and geography table, I do not have are not in that case, I can execute a query. So in that scenario, mutation is the C. For query aspect, we selected the query keyword. For mutation, the keyword is mutation. Within nuisance, let me explain. Query, for that corresponding query that auto gets created, I am selecting that queries. Whereas, since this is a mutation, within mutation, I have to select the corresponding mutation that I want to execute. That is the delete product. Now, within that product, I want to delete product. I want to delete the product ID 706. And I want it to return the product ID and the name that I deleted. So in that case, I'll execute this 06 and the name was HL Road. Now this record has been deleted. Now in case if I select minimum, it would no longer be 706. It would be a different one because I executed the mutation of delete statement which deleted the corresponding record. So this are the query and the mutation operations that you all can do via API for GraphQL. But now the question begs is, why do we need that as a data integration point? Correct. Up till now, whatever I have been doing, I had been doing it within the Fabric ecosystem itself, which is part of my tenant. But the main aspect that I said it, a data integration aspect, correct? I do want to share it with external users. So at that time, that's where this concept of endpoint that gets created. What I mean by that is GraphQL creates a single endpoint. So I need to share this endpoint with the corresponding downstream user. And then I have to share him with some credentials for SSO authentication. Other than validating the authentication scope via interactive browser, I am taking the credentials of the one who is currently executing the notebook, that is notebook utilities. So let me copy this code and just replace the authentication side of the things in this notebook. And now in case if I execute this, now it is taking my particular the user who is triggering this notebook. It is taking my authentication and I'm able to see the corresponding data corresponding to that query that I have. But then this is for internal users within the organizations, correct? But imagine if I want to share credential with an external vendor who is not part of my tenant, at that time, I do have to share something called as a credential for the vendor to authenticate to my Graph API within my corresponding tenant. That's where the service principal or the app registration, those you all might have heard, would come in. So for that, the prerequisite is basically, so those who are new within to this app registration or service principal, under Azure Active Directory or Microsoft Enter, there's something called as app registrations. One can consider app registration similar to service account, username and password, but in your Azure Active Directory side of the things. So there, I have to create an application, create an app, but one prerequisite is under the API permissions, I have to grant it a delegated permission within Power BI service for GraphQL API.execute all. What do I mean by that? There are multiple permissions that are present across. So under Power BI service, I want to provide a delegated permission, and within delegated aspect, there are multiple separate permissions, but I'm interested in GraphQL, API.execute all. Now, what does delegated mean? Delegated means is, even though I have provided it execute all, if and only if that service principal has access on the underlying data, then only it would be able to access it. So once I have provided the API permission, then there are two other aspects that I need to do. That is, corresponding to that workspace where my data source is present, I need to grant that service principal access on that source. It can be a workspace level access, or I can directly grant it access on the underlying source, that is the SQL database. Another aspect is, under the Fabric admin portal, I do have to enable something called service principal can call public Fabric APIs and can access read-only admin APIs. Based on that, what happens is that service principal would have access to the API, and via that API permission, that is GraphQL.execute all, it would be able to execute it. So in this case, I've already granted the GraphQL app permission on the workspace and the API permission. So in that case, the authentication scope only changes. What do I mean by that? So I already have a notebook created preemptively. So if you see, everything else after the header remains the same. It's how the authentication token is getting generated. So in this case, I have created a parameter called tenant ID, client ID, and client secret. I'm passing it at runtime via node. Ideally, I'll show in a couple of minutes. And for what am I authenticating to the Power BI REST API? And then it is creating a credential based on that client ID, client secret, and generating a token. And that token is being used to authenticate to the corresponding API. So here, if you see the client ID basically uniquely represents the corresponding API ID, client ID. Tenant ID is your tenant ID. Now, how do I create a client secret? Under certificates and secrets, I can go ahead and create a secret. Secret is like creating a keyword. So yesterday I created a secret, correct? SZ0. SZ0, correct? So now I'll be triggering this code. So via this client ID, client secret, which is username and password, it is generating the corresponding token, authenticating it, and based on authorization, returning the corresponding output set. Correct? Now, since you all were able to see the credential, this is a bad way of coding. Since this was just a demo, hence I have passed it as a hard-coded value. Ideally, as an architectural aspect, you need to preserve this credential within Azure Key Vault and integrate your Azure Key Vault at runtime, or get the credentials at runtime from Azure Key Vault within the Fabric notebook. Since this is just a demo, I have hard-coded it, and you all can see I'm able to get the data. Now, in case if any one of you have copied the credentials via snipping tool, it won't work because I'll be deleting it. So once I deleted the corresponding client secret, the secret value that even if you all are copied won't be usable. I can generate a new one. So always follow the best standard, that is provided, keep it within the Azure Key Vault and trigger it. So this is how external vendors can authenticate to the GraphQL SQL Analytics endpoint, the single endpoint, and query all the entities and extract whatever data is needed by them. So this concludes to a simple aspect of the primary aspect with respect to GraphQL and Microsoft Fabric. Thank you all. Any queries, concerns?
We have one question in the chat, but it was already answered.
It is with respect to, sorry, can you
Graph API
repeat?
request.
Okay. Anything else, team? Okay. In case if there are any queries, do reach out to me via LinkedIn and we can discuss this offline. Thank you all.
Sure.
Have a
Thank you
great
for the
day.
wonderful question. Thank you. Wonderful session. Thank you so much.
Yeah, I think Indira has already joined. We can start the next session.
Yeah. We are very excited to welcome Indira, Microsoft AI and Data Platform MVP and Director at Kids Tech, a highly experienced data architecture with expertise in AI, data platforms, and cloud technologies. Indira is widely recognized for her leadership, innovation, and contribution to the data and AI community. Let's welcome her together and looking forward to her session.
Hello, everyone. Okay, I'm just going to share my screen before I start.
Yeah.
You can hear me, right? Okay.
Yeah. Voice is a little low, but yeah.
Okay. Now, what about now?
Better.
Okay. Okay, so first of all, welcome everyone. And I think it's almost ending time for Global Microsoft Analytics Community Conference. I'll start with a question. I don't know how many of you are familiar with Fabric, but you might be familiar with data pipelines if you are involved in data. So how many of you have had data pipeline that was supposed to run, let's say, overnight, and when you go back to the office in the morning, it was still running even at 9 a.m. And when your stakeholders needed the report, the data is still running. How many of you have had this kind of scenario? All of you might agree that this is the reality for traditional data movement. So we copy, we transform, we load, or we copy, we load, and we transform. And by the time the data reaches the analyst, it's already out of date, right? So today's session, think about, I don't know why it's, okay. Think and don't move. That phrase captures exactly what we are going to explore today. So it's called Fabric, Microsoft Fabric Mirroring, which fundamentally changes how we think about getting operational data into our analytics platform. So instead of moving the data, we actually synchronize it in near real time without creating extra copies and also without building complex pipelines. So by the end of this session, you will understand what fabric mirroring is and how it works under the hood and what sources it supports today, what are the GA sources and what are the preview sources, and also how to evaluate it for your own data estate. So I think we have about maybe 50 minutes probably. So let's continue. Let's try to understand what fabric mirroring is. Okay, so next is, I think it's, also before I continue, I hope you have been doing the community challenges and filled the participation form for getting the DP600, DP700 vouchers and Amazon.in gift vouchers. So I'm just going to proceed with this one. Okay, so here is our agenda today. So we'll move through these 8 topics. Of course, eighth one is Q&A. We start with the problem, which is the data movement problem. Why existing approaches to data movement are painful and expensive. Then we will define what fabric mirroring is and walk through its architecture. What are the and see what the supported sources and scenarios are, and what is zero copy and near real time sync, and also what kind of security governance and compliance aspects are for Microsoft Fabric mirroring, and also what's the business value and ROI, what will be the cost savings and things like that. And also there will be a demo of connecting. I think I'm going to connect Azure SQL Server to Fabric. And also, let's see if we have time. We'll have a look at the best practices and some Q&A. Finally, okay. So before talk about the solution, let's make sure we'll all understand what the problem we are trying to solve. So most organizations today have operational data living in the transactional systems. Like it can be on-premise SQL Server, Oracle databases, Snowflake, Cosmos DB, Azure SQL, whatever databases. And then you have a separate analytics platform where you create a data warehouse or a data lake, or nowadays we are creating the analytics platform in Microsoft Fabric. The challenge is getting data from the first place, which is the operational transactional system, into the analytics system. And the traditional answer have been we have been creating ETL pipelines, data copies, and schedule batch loads, right? So the first problem is latency. Batch pipelines run on schedules. So it can be hourly, nightly, sometimes weekly, or for large data sets. That means your analytical reports are always looking at the past, never at what is it right now. So for operational analytics like inventory levels or fraud detection or customer churn signals, this latency is not just convenient. It's like a business liability. That's one pain point. So high latency is one pain point. The other one is high cost and complexity. So you have every copy of your data requires storage, right? So every pipeline requires compute, storage and compute. And maintaining custom connectors, transformation logic, and error handling code requires engineering time. So a typical mid-sized, let's say, organization might have dozens of pipelines feeding a data warehouse, and each one has a potential point of failure. So that's another pain point. The other one is data inconsistency. Okay, so when you have data copied to multiple places on different schedules, you inevitably get conflicting numbers. Always you struggle to find what is the source of truth. The finance team is looking at data for last night's batch, and the operations team refresh, let's say 2 hours ago. Executives are asking which number is right, and always I have been in those situations where the executive team is asking which numbers are right, because finance team is saying these are the numbers right, and the operations teams are saying these numbers are right. So there is always a trust issue in the data platform. So that because of these data inconsistencies. Another pain point is governance. So governance gaps. Governance gaps is a serious issue when data is scattered across multiple copies in different locations. Enforcing security policies, tracking data lineage, and also demonstrating compliance is an enormous complex task. And there is also engineering overhead. The team spend 60 to 70% of their time on data plumbing rather than delivering actual insights, which is only 30% of the role. So that's an inverted ratio that needs to change. So, and also finally, data silos, business critical, what do you call, data that lives in what do you call that lives in operational systems simply cannot be reached by your analytics platform without a significant engineering investment. So there is an engineering overhead and also a siloed ecosystem. So to for all these pain points, the fabric mirroring can be a solution, one of the solutions. So let's now look at what fabric mirroring is. So the fabric mirroring is a near real-time zero copy data synchronization capability, which is in Microsoft Fabric. And the keywords here are near real-time and zero copy. So let me unpack these both. Near real-time is means that changes in your source database are reflected in one lake within seconds, because you are not making a copy, you are just syncing. So you don't need to wait for hours, or even there is no batch processing as well. So we are talking about here latency measured in maybe in a few seconds for most of the workloads. And also zero copy. Zero data copy means the data is not duplicated into a separate proprietary format, or into a separate database or something like that. Mirror data lands in one lake itself, which is the unified storage layer for all Fabric workloads. So which will be in the Open Delta format, Delta Packet format. And these two are the main pillars for fabric mirroring: the near real time and also the zero data copy. So near real time capability is powered by the change data capture, which you can, if you enable, like in SQL Server, you can see the changes within seconds. We will see that in more detail in when we go further. And zero data copy is the most misunderstood concept. It does not mean that data doesn't arrive in one lake. It does. What it means is that there is no intermediate staging copy, no transformation layer that creates yet another version of your data. It's just a mirror. That's it. The mirror data is in one lake, and that is the analytical copy. So that is the one source of truth. And then comes the one lake integration, because the data lands in one lake in Delta Packet format. It is instantly available for in every Fabric workload. So you can use Power BI on it. You can use Spark. You can use SQL Analytics endpoint. You can use notebooks, and you can use data pipelines as well over that mirrored database. And lastly, we have the fourth pillar, which is the unified governance. And because mirror data exists within Fabric platform under the same workspace security model, all your existing policies apply automatically. So role-based access controls, sensitivity labels, and also purview lineage, all are inherited and all are enforced. So this is this is very important for a lot of industries where managing data governance across siloed systems is costly. So next comes, let's look at I think the architecture, how it works. So here let's walk through the architecture from end to end. So you have, let's say, these are all the sources that you have that are supported at the moment. You have Azure SQL DB, Cosmos DB, Snowflake, and others. You have those are your sources for operational databases. And then you have a change data capture engine for these sources. So when you enable this change data capture on your source systems, this component connects the source database and reads from its transaction log. When you enable a CDC, it reads from the transaction log. Um, so it does not issue queries against your operational tables. It reads the log file, which is a passive operation. So so that does not add a load to your production database, because you are querying the CDC engine rather than the operational engine. So every insert, update, and delete that occurs in the source is captured as a discrete change event. So you have the mirroring service. The mirroring service receives those change events, processes them, and writes them to OneLake. So this service handles the translation from the source database's native format to Delta Lake format, because it's coming into OneLake. And it also manages the initial full snapshot when you first set up the mirroring. Then when you first set up the mirroring, the seeding of all the existing tables, existing data happens, and then transitions into the incremental CDC mode. So the mirroring service is fully managed by Microsoft. You don't need to deploy it, or you don't need to scale it. So you don't need to monitor any infrastructure. It is all done by under the hood. It is all done by Microsoft. So you can configure it and let it run. In the demo, we will see how we can say future tables also can be mirrored and things like that. And then talking about OneLake is where the mirrored data lives. So you have the mirrored data DB tables. Everything is in Delta Parquet format, and you have the metadata and lineage, access control, or auto delta, sync, and things like that. And then finally, all Fabric workloads like the Power BI, Spark, SQL notebooks, and pipelines all have access to this OneLake data, which is mirrored data. So that is the main high level architecture for Fabric data warehouse. Fabric mirroring. So now the main thing is what I want you to take away from this architecture diagram is that there are no pipelines that I have shown you. There are no custom pipelines to build, no scheduled jobs to manage, and no intermediate storage layers to maintain. You just configure the connection once, and the platform will most of the time take care of the rest of the mirroring service. So that is the architecture. And now let's go into supported sources. What are the supported sources and scenarios? So as of today, Fabric mirroring supports a few key sources. First one I wanted to share is the Azure SQL database, so which is generally available. It uses logical replication via CDC, and supports full table mirroring, and tracks schema changes as well automatically. So this is most matured mirroring source today. And if you have analytical workloads running against Azure SQL DB, so you can straight away move. This can be set up within minutes. I could set up a mirror for Azure SQL database in about maybe 5 to 10 minutes max. Yeah. So, and then next comes Azure Cosmos DB. So Azure Cosmos DB, also I think it's GA now. Cosmos DB mirroring uses the change feed API integration, and also Cosmos DB's native mechanism for tracking changes to containers. The data is converted from JSON documents into Delta Parquet format. It's mainly NoSQL to Delta Parquet, and also this is particularly powerful for event-driven and high throughput services. So that is Azure Cosmos DB. Next one is Snowflake. Snowflake mirroring uses streams and tasks API. So Snowflake CDC mechanism is tasks API. This is a cross cloud capability. There is a cross cloud capability as well. So if you have your Snowflake set up in AWS or Google Cloud and not in Azure, there is a cross platform capability, and Fabric mirroring will still replicate it to into one lake. So that's the because if some organizations have their Snowflake instance in AWS, and then if they are trying to use Fabric, that also is supported. So because of this multi-cloud, this thing, that is also very powerful. And next comes Azure SQL Managed Instance. Now this one is under preview. So this managed is it uses log-based CDC and managed identity authentication, and also you can use enterprise workloads. And I think there is and also Fabric SQL DB also uses native is also a native source, and it is. If you are using the built-in SQL database in Fabric, mirroring is essentially instantaneous because it lives the Microsoft Fabric SQL lives within one lake itself, and that is GA Fabric SQL DB. And then open mirroring. This is in preview. Open mirroring is it allows any source to publish data into one lake using a REST API landing zone, REST API based landing zone. So this means custom applications, third-party systems, IoT platforms, and partner connectors can all participate in the mirroring ecosystem. And so if the source list continues to grow, and I think you have, I missed Oracle as well here. There is Oracle also. I think it's still in preview. Is also a supported source. So the list of sources that support Fabric mirroring is growing, and I think there is PostgreSQL also is in the works, and also on-premise systems. On-premise SQL Server is also a definite source that you can try for data for Fabric mirroring. So that's one. Next one is, what do I have next? Do I have? Okay, now let's pause the theory part and then let's say see a demo. I have recorded this demo last night, so let's see. So here what I have is okay, so I have is it running? I have the this pre-SQL DB in the SQL database in my portal, which is a Azure SQL database. And I am trying to connect this, I am trying to enable Fabric mirroring for this particular, I don't know, somehow it's not working, looks like. Yeah, it's working. So here I'm going into the Fabric DB, sorry, Azure SQL DB, and you can mirror the database in Fabric in two ways. You can straight away click on the mirror database in Fabric, which is in preview. I will show you the way I have done it in Fabric. So in Fabric, I have this test workspace, which is a Fabric workspace. So I clicked on new item, and then I search for mirror. And here you can see you can see all the sources that you can mirror. So I have chosen the mirrored Azure SQL database. So you can see the various things supported. So Azure Databricks catalog is also supported, wherein you can get the metadata. So I have clicked the mirror Azure SQL database and then chosen the Azure SQL database, and then you give the server there. So to get the server, you go to the overview of your SQL database and then copy the server name from the Azure SQL database. So I have copied and then pasted and tried to create the connection. I have used SQL authentication here. Giving the password, and here I will and then I hit create, but I will encounter a error, I guess, because I did not provide the database name. So if you go at the top, yeah, so there is no database name. So I need to give the database name here, which I get it from that particular SQL database. So, and then if I give that, then and then connect. Here, what I get is I get another error called not the database name, but the other error is I think I need to enable system assign managed identity. So how you do that is you need to go to the server itself and then go to security and then go to identity, not the database part, but the Azure SQL server part. And then you need to set that status to on. And because I don't have any other user assigned managed identity, I don't need to update the primary identity here. If you have multiple, then you will need to you will need to choose the primary identity. Once that is done, and when you connect, my Azure SQL has three tables there. So you can see all the three tables, and this was the automatically mirror future tables. That was the one that I was mentioning. And now you can create the destination by giving your own name. So what I have given is, I think I have given SQL -db -mirror, and then create mirror. This took about, I think, couple of minutes. And once the mirror has been created, so it's provisioning the mirror database, then also it provisions the SQL analytics endpoint, and then it configures the replication, and then it starts the replication. So these are the 4 steps that happen when you create a mirror database. And then when you create additional tables, they will automatically be mirrored. They will automatically mirror when you create those new tables in the Azure SQL database. So here I have all the 3. They are still running. I think the configuration is not yet done. You should see in the artist, you should see 16 rows replicated. Yeah, now you can see 16 rows replicated because I have inserted 16 rows in the artist table. So that's how you can see the mirror. See at the top, you can manage OneLake security, and also you can manage configure replication, or if you want to stop replication, you can do that as well. So in the workspace, when I look at it, the SQL DB mirror has been created, and the mirror database and SQL endpoint is also created. So that's what I wanted to show here. Yeah, so that's and then you can see the tables. Yeah, and then I'm showing the artist table where I have created 16 rows. Okay, so that's what I wanted to show in the demo. So let's go to the next one. Okay, now let's go a bit deep into the zero copy and near real time. So, um, this slide, this is a technical deep dive for mainly data engineers and architects in the room. So, how CDC, we'll go and understand how CDC actually works in the context of fabric mirroring. So, first is log capture. So, every enterprise database engine like SQL Server, Cosmos DB, Snowflake maintain a write ahead log, which is the transaction log or equivalent change stream. So this log records every transaction before it's committed. So the Fabric mirroring connector reads this log using the source's native CDC API. So for Azure SQL, the SQL Server CDC feature based on reads based on the transaction log. For Cosmos DB, it's the change feed, and for Snowflake, it will be the streams. So the critical point is this is only read only operation. So against that log and not the tables, not the actual tables. So because of this, your production system will not be impacted because there are no queries run against the operation tables. So your production workload is not impacted. That's the main, because it runs based on log capture rather than. So what this typically does is the latency is only less than 60 seconds, so less than a minute. Okay, so that's one thing. Now, next step 2 is change processing. So once change events are captured through either the streams from Snowflake or change feed from Cosmos DB or transaction logs from SQL Server, they go through the change processing stage. So in each of the change data CDC captures, you always get a operation and a LSN. So you have the operation type as insert, update, delete. Sometimes you get before delete and after delete. So you get the timestamp, you get the primary key and the changed column values, which these are the event in a standard event is passed in a standardized format. So update events use a before and a after. Before update, what is the data, and then after update, what is the data. So the mirroring service knows what the row looked like before the update and after the change. So this enables accurate delta upsert. So instead of inserting and appending it, the mirroring service upserts the data in one lake. So the schema changes like column additions, renames are detected and handled automatically. You don't need to do anything wherever possible. Some if sometimes if breaking schema changes occur, then they may require some reinitialization. So that so this change processing, so there won't be any zero data copies. So this step involves no data copies. It will be exactly the same. So the next step is once the reading is done and change processing is done, then the next one is one lake write. So the changes are written into one lake in delta Parquet format. So the inserts become appends and updates become upserts, delta upserts, which are in the merge operations, and then deletes become delete operations. So the delta lakes acid guarantees mean that even if a partial batch of changes is written, the table remains consistent. So readers always see a valid snapshot. So the mirroring service also handles delta file compaction automatically. So periodically rewriting small delta files into larger, more efficient ones. So this is mainly critical for query performance over time if people are trying to query the mirror database. So ACID guarantees are there when writing into OneLake. So the step 3 ensures that ACID guarantees are there. And then the final step is availability. So once changes are committed into OneLake as Delta Parquet format, they are immediately available in Fabric for consumers. So you can create semantic models using Direct Lake. You can connect Power BI in Direct Lake mode, reads the Delta files directly, and there won't be any import cache to refresh, and also um, so there is a no latency for hourly or weekly refreshes. You just read the data from Power BI within seconds. And also the Spark Python notebooks and SQL endpoints also see the new data immediately. And because they query the Delta log to get the latest snapshot. So typical one more I have. So this is schema drift handling also is done automatically. So mainly typical end-to-end latency from source commit to OneLake availability is under 60 seconds. That's what is shown here, and 0 additional data copies, which we already discussed, and ACID guarantees are there, and schema drift is also handled automatically. So this is the main technical deep dive that I have. I just wanted to go through. We have time, so we have time. Okay, so let's cover the security, governance, and compliance aspect of it. Now, mainly the Fabric mirroring was designed with enterprise security requirements in mind from day one. So let's look at Entra ID and rollback, role-based access, RBAC. So authentication and authorization are handled through Microsoft Entra ID, Azure Active Directory, which was previously known as Azure Active Directory, and there are no separate user accounts or custom security databases to maintain because it's already handled by Entra ID. So access to the mirrored data is controlled through Fabric workspace roles. If you have and also if you have item level permissions enabled, so based on the access that you have, either RBAC or workspace roles, the same model is used for other Fabric artifacts as well. So if a user has reader access to a workspace, they see the mirrored data. If they don't have access, then they don't. So similarly, row level security and column level security for the source from the source databases will be can be also complemented with Fabric's own row level security capabilities. Now the next one is data at rest encryption. So all data is stored in OneLake and is encrypted at rest. So Microsoft managed keys are used by default, and also with support from customer managed keys through Azure Key Vault. Most of the enterprise organizations use Azure Key Vaults with strict key management requirements. So data in transit between the source database and Fabric is encrypted, and that encryption is via TLS point 2. And then now comes let's look at private endpoints. So the private endpoints for organizations that need to keep traffic off the public internet, they have private endpoints. So it supports private endpoints. I think it started from last August, I think. Yeah. So private endpoints connectivity for Azure hosted source databases is there, which means data sync traffic flows entirely within the Microsoft Azure network. And then you have the sensitivity labels. So if your source data if the source data has sensitivity labels, that will be automatically mirrored in the Fabric mirroring data set as well. Now, talking about Microsoft Purview integration, this is where the governance story gets really powerful. If you, when you enable mirroring, the mirror tables are automatically registered. If you are using Purview, are automatically registered in Microsoft Purview Azure as data sets. And Purview scans the mirror data and then applies automated data classification using built-in data classifiers like PII and financial data, health records, whatever you have in your data classification. And sensitivity labels from the source propagate to the mirror database as well. And end-to-end data lineage is tracked. So you can trace a Power BI report metric all the way back to the source transaction in the operational database. So which is very useful for lineage. And yeah, I think that's what I wanted to cover. Okay, so now the final thing that I want to do, I want to cover is how to justify your that fabric mirroring is the best scenario to your leadership teams. So main thing is here you can say that there will be 70% at least reduction in the data pipeline costs because you are eliminating the ETL pipelines and you are not moving any data. So that removes the compute cost. Main thing is compute cost. So it also removes the engineering cost. So the time your data engineers spend building data pipelines, debugging them, and then maintaining those pipelines is expensive. So that cost is reduced. So you can quote that 70% reduction in data pipeline cost will be there. And organizations that have migrated from batch ETL to, let's say, fabric mirroring, they report significant reductions in the infrastructure cost as well. So, and also the next one is 10 times faster time to insight because the data engineers spend less time because they are not creating any ETL pipelines and things like that. So that time is there, and also because of the data latency, because the data latency is dropping to seconds from hours or sometimes weeks to seconds. So the business can act on information in near real time or real time. So operational decisions that previously required waiting for a day or a couple of days, those because the insights are available in real time, they can make the operational decisions faster. So for example, for like dynamic pricing or real-time inventory management or fraud detection. So these are the scenarios where you can use fabric mirroring and propose fabric mirroring in order to make faster decisions. And also zero redundant storage copies needed because you have seen that fabric mirroring does not have any copies, zero copies, whereas in your traditional architecture you actually move the data from operational database to a staging area and a data warehouse and a reporting layer. There is a you usually make, I think, at least because the data moves through these stages, there are 4 copies of the same data. So each one costs money to store and keep synchronized. So with database mirroring, the one lake copies the analytical layer. So you can directly plug into your one lake to use Power BI. So there is no storage. There is no storage cost involved. So that is one more use case. And sources via mirroring. So here, these are if we go through the key use cases, operational analytics, you plug in Power BI reports on live transactional data in Power BI without impacting the source database performance. So that is one use case. The other one is unified data mesh. So you federate multiple operational systems into a single governed one lake for enterprise analytics. So that's one more use case. And you have the app modernization. So you are decoupling analytics from the legacy transactional systems. So you are mainly gradually migrating to modern platforms. And regulatory reporting. So you are maintaining real time compliance views over operational data without creating any regulated data copies. And your data, because it's real time, your AI and ML readiness is without any custom ETL pipeline engineering processes. You can run your AI and ML training and inference pipelines on the mirror database. And also you can eliminate redundant data warehouses or ETL infrastructure and associated compute storage costs, and then optimize the costs. So these are the business value and what do you call ROI with fabric mirroring. And one coming to the next one, we look at I think there is some time. Okay, so we can look at best practices for fabric mirroring. So here, first thing is make sure your CDC is enabled on your source database before you begin configuring mirroring in the Fabric portal. So this sounds obvious, but sometimes what happens is um, you forget to, let's say for example, you don't enable CDC on a particular table, and then you are trying to mirror that. That's a common setup for failure. If the database is not configured for mirroring, then you will have a lot of problems. So you make sure that you enable CDC on your source systems before configuring mirroring, and also use managed identities for authentication, which we have seen. Otherwise you are going to get an error. Avoid service account passwords and things like that. So use mainly system assigned managed entities, and also start with the initially subset of tables, and gradually increase to validate performance. And also there is a limitation which I haven't I should have made a limitation slide. There is also a limitation of 500 tables for a database to be mirrored. So what you can do is you can mirror the same database. If you have, let's say, 1,000 tables in a particular database, then what you can do is you can mirror into first database 500 tables, and another mirror database the other 500 tables. So you can do it that way based on your requirement. So you can mirror in that way. So that's the main setup of the best practices for setup. Now let's look at performance. So monitoring the mirroring status dashboard in Fabric portal regularly. So you make sure that you monitor it regularly. It shows the replication lag, throughput, and also connector health. And also make sure you set up alerts if lag exceeds, let's say, a particular threshold. And avoid wide transactions in source. So a single transaction that modifies millions of rows can create a burst of CDC events that will temporarily increase the replication lag. So design your operational workloads with this in mind. So for sometimes what you have is you have a wider table with, let's say, 256 columns. Let's say you have and then that is a very frequently changing table. then you need to consider how to replicate that table for performance. And also, you use one lake file compaction on a schedule. So delta files accumulate over time, right? And small files hurt query performance. So Fabric handles some compaction automatically. But for high throughput sources, you may want to trigger some compaction manually via, let's say, a Spark notebook or something like that. So that is the best practices for performance. Now let's look at governance best practices. So apply wherever possible, apply sensitivity labels to your Fabric workspace before onboarding the sensitive source tables. So labels applied at the workspace level propagate to newly mirrored assets automatically. So make sure that you apply the workspace sensitivity labels before you onboard the sensitive sources. Then enable purview scanning post setup for auto classification. So immediately after setup, you enable purview scanning. The sooner purview classifies your mirror data, the better your compliance will be, posture will be from day one. And also the document the mirror scope in your purview business glossary so that the tables are for discoverability purpose. So which tables are mirrored from which sources and who owns them and things like that. So this is essential mainly for enterprise scale deployments with multiple mirroring configuration. So that is about the governance best practices. And finally, we'll get to the operations best practices. So main thing is again set up monitoring alerts for replication lag and connector health. Don't wait for a business user to report stale data. So try to detect it proactively, and also test failover and reinitializing procedures in your testing UAT databases first, UAT workspaces first. And also review schema change impacts. Sometimes because you are database development is going on, sometimes the DDL changes might require remirroring. So make sure you are doing all those tests before you put the data into production. So test the data whenever you have the schema changes in the development and test environments first before you put the data into production. So that's the best practices for Fabric mirroring. I think. Okay, one last thing is comparison. I just included this just to maybe you can use this for justifying traditional ETL versus Fabric mirroring. We have already covered this one: data latency, storage costs, so zero extra copies. Whereas we have seen high storage cost, and engineering is also effort is also high, and schema changes usually automatically handled. And governance, if you are using Purview, it's unified with Purview and Fabric. And scalability is also automatic scalability. And time to production is yeah, I would say minutes to hours max. We have implemented a couple of mirror tables, mirror databases in production. And operational overhead is low, I would say, which can be used as a managed service. So that is the that's what I have for you. So in order to summarize, the data movement problem is real, and if you can use Fabric mirroring, and if you have the compatible data sources, I would suggest you use Fabric mirroring instead of using the ETL pipelines, particularly when you have CDC enabled. So and also yeah. What else I wanted to say? So this is so no pipelines to build, no copies to manage, no custom connectors. So it is easy. We have seen how easy it is. Um, so what are you looking for? Start syncing today. So you stop moving data, start syncing it, enable mirroring in your Fabric portal, and connect your first supported source, explore data via SQL endpoint, which we have seen all this in the demo. I didn't build a Power BI report on live data because I didn't have much data in my Azure SQL database. But yeah, if for more resources, you can go through the Microsoft Learn docs, like Microsoft Learn Fabric path. So that's what I have for you today. Any questions?
We have few questions in the chat box.
Okay, yeah.
What happens when business systems have continuous heavy transaction like e-commerce or banking? How do we manage performance and cost in such cases? Do you mirror only selected tables or use some other approach? Yeah.
Okay, so it depends on the number of tables in your database. If you have, let's say, more than 500 tables, then what I would suggest is um, create two mirror databases from the same source, and then divide the tables in both the mirror databases. Um, Even if there is heavy transactions, if the CDC is enabled, you will the mirror database will be effective. We have used for high transaction tables as well. So yeah, the mirroring is a better option compared to building ETL pipelines and where the CDC is enabled. Any other question? I think cost is the big part. Customer keep on asking for mirroring because of that. Yeah. Main thing is because ETL pipelines, you always run these pipelines. I think mirroring is a better option. Updates data in near real time using CDC. What happens when there are too many updates happening continuously? How frequent? Case Reddy Rashmita. Does it affect performance or increase cost in real projects? No. Mirroring does not increase. It depends on the capacity that you use. So let's say, for example, you have a mirroring database in one workspace. That can be, let's say, for example, you can use F32 capacity or F16 capacity for mirroring database. You can use another workspace where you have let's say F64 capacity to plug in the Power BI report as a direct lake, because you have more Power BI users. Then you can split the workspace into two workspaces and you can use it. So I hope I answered your question, Rashmita. And fabric mirroring, Deep is asking, can fabric mirroring helps in development for testing without effective live dashboards? Like I have SAP as my source system and store data in Lakehouse, but I want develop new views and development with SAP is not yet a source for fabric mirroring, Deep. So I don't think you can use fabric mirroring for that. So Deep, did I understand your question?
You can unmute and ask in case need.
Deep, you can unmute yourself and ask the question.
Yeah, I don't think Deep is there in the call, so that's okay.
Yeah.
Mm.
Thank you so much for answering the questions. Yeah. Thank you for the informative session. Thank you so much.
Thank you.
Thanks, Indra. Thank you, everyone who has
See you.
joined since morning. Now we will have a 1 hour break in this room. We are going to join back at 3 p.m. The ID will remain same. So I'm just going to pause this here. I'm going to stop the recording and also going to pause the YouTube live. But we'll have the same meeting ID will continue here. So maybe if you just want to stay on the mute, you can do. But we'll connect back at 3 with Rajendra, Ongole, and followed by Kevin Chant, and we have session from Lakshmi. So it's interesting 3 sessions coming in the same room. So uh, join back us on 3 p.m. Thank you, Indra. Thank you, everyone who has joined since morning. 841804. So Chala. ओ पोरी दिलदार भैयारी वे. Chand. Urbalen.
So let me give it back to that. So this is the first use case that whenever you want to take anything around the newspaper, it's just a matter of getting the user input, selecting the element, getting everything from the regional part grinder and telling it take the right API. If any one of you have used the MCP also, MCP also goes in similar fashion. MCP lets you to connect your applications to customize application to the Power BI. And in the back end, when you build the MCP, Power BI also has a Power BI service application, but a bunch of things you can ensure. So it's the first anytime the conversation behind that or if you know what a better it because anytime in the back end it's all about metadata. Right? There is no leakage of data here by the way because you're just keeping the endpoints and you're just getting the metadata, you're not actually extracting the data. You build some garbage also around it, but it's not, it's just like content story around the metadata of the report. Yeah. Now I'll talk about the second use case, and this also I have built some product. Maybe I'll show you this time for it. This is Power BI restaurant. Right? So let's say the problem statement, and this problem statement is also very common in Power BI. When a company grows, right, everyone is building a report. But let's say I have a company which is working since 5 years, right? Now, 5 years down the line, a lot of people have built some reports. Now, after 5 years, how will I know how many reports are actually used? Or is there any report which is broken? Is there any report which is having a duplicate report already present? Or maybe question number three, out of 500, can I eliminate 20 reports if they're not being used for, let's say, last 2 years? Or for example, if the refresh is failing for last 3 months, right? These kind of scenarios. This is called rationalization. Means if you have the entire Power BI tenant, you can actually find how many reports you want to keep, how many reports you want to eliminate, how many reports you want to review. If you know how the metadata works, if you know how the API endpoint works, this is a piece of cake for you. For example, the problem statement is 100 of reports present, which ones are used, right? You can list the workspaces that, hey, these are the workspaces. In each workspace, there will be some dataset present. You will get the dataset when you hit the hyphen and the hash backslash admin backslash dataset ID. You get the metadata and the response from API, which is having the last refresh time also. Now, I can use this last refresh time to know, let's say, if my report is not refreshing last 1 year, that means no one is using it, right? Or maybe last 2 years. So if I use this API endpoint, I can actually find how many reports are not used. And of course, keep appending more rules to define what reports to eliminate, but this will be one data point for that. Okay. We have activity events also. In the activity events, you can see how many people are using your report. Now, whenever we build a report, right, it's a very famous problem statement that are people even using it or not? Right? Is it even adopted in the company or not? If my report has not even been accessed, let's say one time, maybe once in 3 months or 4 months, I should question the usability of that report, right? So maybe I can have that as an input to tag that report as, hey, I need to make it. Maybe I'll have a user access variable. So I hit the user API to find who is having the access because let's say I have people giving a report. I need to reach out to the person who has used it, for example, or who has built it, for example. Now, if by using the dataset metadata and activity event, I get to know that hey, no one is using it. I can't just delete it, right? But if the business needs
I welcome Rajendra. I made you the presenter.
Hi, Amit. Good afternoon. Yeah, thank you.
Can we test if your screen sharing is working?
Yeah, Amit. Yeah, able to see my screen?
Yes, screen sharing is working.
Shall we start? Amit, can I share my screen and we'll get started?
Moderator, are you ready? Rajendra, please share your screen again.
Yes, Amit.
Moderator, are you there? Okay. So let me set the YouTube live and then I think we can start. Just give me a minute.
Sure, Amit.
So hello everyone, back to room one. I welcome Rajendra along with you, and now we are going to have a session on real-time intelligence in Microsoft Fabric. Rajendra is a Microsoft Data Platform MVP and he's contributing heavily on real-time analytics. So he's one of the best person in the town to talk about real-time analytics. So Rajendra, please get started and
Thank you.
let us know more about real-time analytics in Fabric.
Thank you so much, Amit. Thank you. Thanks, everyone. And afternoon, after lunch, so make sure that the session should be very interactive. And if you have any queries, right, please post your queries, or you have an option to unmute yourself. You can speak as well if you have any queries. Make it as an interactive. That's what I'm expecting. Okay, we are learning together. So maybe some things you will get to know, some things I want to learn it from your end as well. So the topic here, if you're observing, get started with real-time intelligence in Microsoft Foundry. So what I have segregated this concept in another, like with the 3 levels. We'll try to understand the real-time analytics first, okay, and the architecture. And there should be a polling as well, like some of the questionnaires I have framed it. So I'm expecting the answers on the chat as well, okay, from your end. And it's a kind of 3 levels of polling. So real-time analytics is the first level. We will try to understand the concepts, what it is and how it is going to work out as per the architecture. Next level is on the event stream wise, how we will try to inject the data and we will understand a few of the important components and functionalities there. So there also I have created some 3 questionnaire of polling, and the last level is event stream. So where you will get to know more about the event stream and Eventhouse collaboration, how we will try to combine, how we are going to extract the ingestion, and what kind of an databases we are going to use it to store the data in the event houses and how it is going to support. There also have framed 3 of the questionnaires. So you can post your queries in the chat. It's a completely choices based on ABC, something like that. So whatever you feel as per the learning curve, the answer is you can post it in the chat. That helps actually. And again, yesterday we discussed about ontologist technique in Microsoft Fabric, and we discussed very well. We come to the, the discussions part. I got the much impression on what is an ontology, how we are going to make use of this ontologies in your real-time activities too. And it's good to learn the ontologist technique. And before that, everyone, I would like to thank Global Microsoft Analytic Conference team for giving this opportunity. Amit, Chandak, Bharat, and Aditya, where I'm presenting this second day as well on the topic real-time intelligence. And ready, Amit, given a brief about myself, I'm Rajendra Ongole, and I'm a Microsoft MVP and Power BI Plus Fabric, and also I'm an MCT. If you want to reach out to me, you can scan the code and you can connect me via LinkedIn. If you have any queries related to the topics, I'm happy to help you here. Yeah. So as I said, the agenda very clear. We'll try to understand about the real-time analytics first, and event stream wise, how this Microsoft Fabric, how we are going to inject the data, very clear, and the event house wise, where the data will be get stored. 3 important major areas. I'm not going to showcase you, maybe if time permits, I will showcase you as a part of a demo. Okay, everyone aware of some sample data too, they can work on, but fully we will work on the architecture part and what are the important components and where we will get start on this real-time intelligence. That part we are going to discuss. So if you're observing real-time intelligence in Microsoft Fabric, most of the time, if you're general scenario, like if you're order some items, we will track the orders and where it is and when it is going to deliver and everything. Like a streaming, the data will be get streamed. It is not going to be static or else maybe on-premises source system. We will try to understand the track of the information, where when it is going to deliver, what kind of an items it is, and is there any delay on the items. These kind of a techniques and terminology, we can track it via real-time analytics. So if you're observing, this is an architecture. On the left-hand side, the data set should be, data sources should be some, many of the sources, like example, it's supporting change data capture of Postgres source systems or Kafka source systems and many other real-time log analytics as well. Maybe if you are going to work on energy sector with IoT sensor data, which is minute by minute or second by second, data will be get changed in the form of a number of records, and each and every record we will call it as an event. And to track it or to inject the data, there should be some process. We need to have some process where how we are going to extract it, what kind of a mechanism we are going to use it. So here, if you're observing the components part, event stream is for the data ingestion part. like in Power BI terminology, we will make use of the get data to check which type of a source system we are going to use it. Like that, here if you're observing, we have to make use of the event stream to get it, extract the data by connecting the different various variety of source systems. And from there, maybe the data should be something like unstructured or semi-structured. You have to perform some different type of a transformation. Maybe you want to perform some grouping activity, or you want to perform some data filtrations. These are all activities and terminology you're going to perform on this event stream itself. Data extraction and as well as data transformations or processing part, where it will be taken care of the event stream, which is one of the cohort where we can try to pull it over the information. And it is not, and one more thing, this is not a storage container event stream, and there is a layer, another layer where we will try to create it to store the real-time data. That part we will have it as the Eventhouse. Okay, Eventhouse part, you can create multiple KQL databases, KQL source systems to KQL informations, but Eventhouse, in each and every Eventhouse, you can trigger and configure the multiple query sets as well. And if you're observing, the query set is going to helpful to write on the top of the connected tables, some of the built-in queries, like maybe if you're extracting the gigabytes to the petabytes of data, what kind of information we are extracting to test it, and some of the queries will be get it framed. And even if you want to check the last RLs generated timestamp files, we can source that information from where it is coming, how the operations has been triggering. This kind of a set of operations will be configured via this KQL query set. By default, few of the queries will be get triggered, and on the top of it, maybe if you want to write few more queries, in such kind of a scenario, we can make use of this KQL query set, and a lot of commands and operators are there, just like how we will perform some example, one of the statement. If you want to write a select statement, we will use the SQL databases. Like that example I said, KQL database also, we have some commands, like a project is the command, which is almost equivalent to the project command is equivalent to the select statement. Like that, we can query the information, we can store, and we can see the analysis on the output of this particular window. Sometimes, if you want to see along with the data plus visualizations, this real-time intelligence is supporting real-time dashboards too. Already we are aware the Power BI is also window where we can try to see the analysis in the form of pictorial, that is a diagrammatical representation. This real-time intelligence is also supporting to track and see the analysis and then second by second and minute by minute analysis wise real-time dashboards too. These are all information if you're observing. You can pull it over the real-time hub. Once, whenever you're creating the Microsoft Fabric workspaces, you can see the real-time hub as well. And all this has a foundation of one Lake foundation. Your data will be get as a one single copy, one single source of truth. And from there, you can configure either for the real-time intelligence, or maybe you can do some advanced statistical analysis via data science projects and so on. So the data should be a single truth, one single copy, where we can try to make use of any kind of workloads. So real-time intelligence is also one of the workload in Microsoft Fabric, where we can perform the different or variety operations. So fine. So Rajendra, how can we get the notifications in Power BI? We know the setting alert configuration. The similar concept here, the name only instead of calling it as a set alert, we have a name called activator. Maybe I want to trigger in alert or as email notification to someone by configuring this. Maybe the values has been getting changed more than some number. Such kind of a scenario, we can set it as an alert as well by the three different approaches. Anyway, we are going to discuss in the further slides. So we can automate these actions by using an activator. And we can also see the real-time alerts via sending an email, or MS Teams wise, we can set an alert. And maybe the specific person wise, if Fabric workspaces also will be get it added, and we'll see that further analysis. If you have any questions on this concept or something, please post your queries too. There are approaches where we are going to extract the data. So as I said, real time, once you open your app.powerbi.com browser part, any of the workload. On the left-hand side itself, you can see real-time hub. The name has been changed, real-time hub. From there, we can see the multiple ways of connecting the data, as I mentioned. Like, is that going to be in a Kafka source systems or IoT sources or log analytics examples, data source systems wise. We can get it configured. And even we can see the further analysis and dashboard preparation via real-time dashboards too. Can you please mute somebody? Can you please mute?
I appreciate you for not saying it. You found a real good man here. He's a real good man.
If you don't mind, can you please mute?
No.
Thank you. Can you please mute? Anybody is there? Moderator?
It's a collab. Okay. Is it brand new? Brand new. It's morning, Missy. Morning, Sheldon. Hi.
Yeah, thank you. So if you're observing another snapshot, inject and transform real-time data. These are the different ways. So data source, there are 4 important functionalities or formats we have. On the left-hand side, if you're observing, I mentioned the data source, data transformations, data destination, and as well as operator. So 4 important criteria. So if you want to extract or else to pull the data, we can make use of the data source. As I mentioned simply, 3 of the sources from external sources, like from Amazon Web Services wise, we can extract it, or maybe the Fabric event wise, we can get it pull over. And anyway, for practicing part, some of the sample data, Microsoft Fabric has been added, like stock related information or yellow taxi data, like point by point. Maybe I want to say an analysis based on minute by analysis. So these are the different ways of sources which has been supported. And coming to the data transformation, these are all activities which you are going to perform at event stream itself. You will cleanse the data, and you can also perform the different ways of transformations by using the filters or grouping or aggregating the data with managing the fields. Maybe if you're having the more number of columns, and if you want to see the analysis based on few set of columns for the front-end analysis part, we can also use the manage column functionality to exclude multiple columns. And here, the data destination, where do you want to store this information? The transformed, after the transform, the data cleansed information, where do you want to store it? Is that going to be in the one lake, or that is a Lakehouse part, or maybe you can configure in the Eventhouse itself in the form of a GraphQL database, or maybe for the external connectors too, maybe it will be supporting for the external connectors too, we can use custom endpoint. Recently, I have come across one of the energy sector based project, which I am currently working on, RTA related. So sensor information is coming in minute by minute. There should be something like a Windows function, temporal Windows function has to be used, where each and every record, we will call it as an event, one single event. So in each per minute, how many number of events has been get it triggered? These are all the analysis we can capture by using some of the temporal Windows functions too. In the next slide, I'm going to showcase to you the Windows function and the multiple approaches of multiple functions, 5 different functions that is supporting on your real-time functionalities part. Where and what kind of a trigger or triggering alert it has been getting configured, how the event has to be getting stored, is that a bunch of or else a batch related events has been processed on a single time period, or maybe after simple example, I will tell you. After completion of my session, next session will be get it activated, or else maybe the another speaker will be comes up. So that means this particular 2 to 3 timestamp or 3 to 4 timestamp, 4 to 5, my session is currently running. After my session, another session will be get it started. It's a real time. Like that example, there should be a temporal Windows function where we can use the sliding approach or hopping. So we have to decide it, how the session is getting triggered and working on. So there are specific functions here, 5 different functions, which I'm going to showcase to you on pictorial base, so that easy to get it captured and understand as well. So here, if you are trying to inject or transform the data, this is the approach where we will perform the data extractions and transformations and storing the information on data destinations part of either the Eventhouse or Lakehouse or derived data streaming processes too. You can always, whenever, if you capture the data, you can always see the test or as the data results downside of it. What are the columns you're utilizing? Or maybe if you want to store the data in the form of a JSON, we can also store it or else save it the data information on minute by minute as well. Fine. Another, if you're observing where we are going to store it. So if you start with real-time analytics part, we get to know for the data ingestion part, we are going to use event stream. And inside the event stream, as I mentioned, data sources we can get extracted. We can any type of real-time source systems, like example I mentioned, like log data analytics or Kafka related, Confluence related source systems, or streaming information like PubNubs and so on. After that, where and how we are going to store this data, what kind of a supporting mechanism, if the data is coming from gigabytes to the petabytes, what kind of a storage or a scalable storage mechanism we are using. So real-time intelligence have a specific or peculiar database name called KQL database. We will call it as a custom query language. It's not as same as SQL. We know SQL statements like DML, DDL kind of a commands wise, it has been segregated. But here, KQL statements part, some are familiar, like as I mentioned, like sort by, group by. These are the search operation functions are similar as like an SQL, but it's almost like differentiation is there. It supports both SQL plus KQL, but for the data optimizations part, as you are working on that gigabytes to, because it's a real-time data, you're going to work on the gigabytes to the petabytes, always supported to use optimization part KQL database. Because it's having the timestamp when the data has been getting loaded, or which number of events or as the records has been getting configured or triggered. These are all the information will be getting stored on KQL itself. So inside the event house acts as like a cluster. Event house is a cluster. Inside the event house, you are going to create the KQL databases. Either you can create a one single or multiple databases as well. Like that, it has been projected on the environment part. You can see what is the utilization, what is the storage capacity, how many number of records are at what time the number of records has been getting added. As I mentioned, again repeating, number of records. Each record we will call it as an event in the real-time streaming part. Each record, because it's going to transform by minute, right? Or second by second, as per the business requirement. So it has been integrated with the Copilot as well. So still some preview feature functionalities are there. So we can get start even learning the Copilot, how it is going to assist with your queries. Maybe I want to write KQL. I'm new to the KQL language, which I'm not sure how we are going to project it. So we can take a help from the Copilot assistance by simple natural language English. Automatically the query will get converted to your KQL setup as well. What are your expectations? But its separate license part is there. So this completely storage area will be get it available or else get it mentioned at the event houses. Fine. If you want to get it to visualize the real data, so what if maybe we'll get a question like Rajendra mentioned, like real-time dashboard is there, even the Power BI is also supporting for the data visualization. You can see the main differences here. The most of the interactive analysis that tile-based information, it is supporting even the page by page as well, the real-time dashboards too. You can see the analysis on a real-time components wise. Within the event house, you can see a prompt like a real-time dashboard preparation. You can click on the button and you can add the similar like a page level analysis. And coming to the Power BI, it's just like we know the traditional level of connecting to a table, and from there you can simply drag and drop mechanism. And based on the auto refreshes part, you can see the latest or new numbers. You can either it's of a choice based on if you want to prepare on the real-time dashboard, you can prepare it from the event house. We can trigger and configure the real-time dashboards via tiles. And also we can set the setting and alert notification for the data activity prospect. And we can maybe as per the data changes or conditions part, we can trigger the notifications to the users. Like the similar concept, even the Power BI, if you are very good and if you want to bring some more advanced analysis, we can also prepare via Power BI. So both the features are available once we will get started for the data visualization concept. It supports both of it, real-time dashboards as well as the Power BI reports. We can build it over inside. Fine. As I mentioned here, activation part, we have a specific functionality, activator or setting an alert. There are few important functions like events, as I mentioned, right? Each record in a streaming data, we will call it as an event, one event. In each event, how many number of records has been getting triggered? That is important. Is that above level or else below? Number of records are getting slowed. These are all the things we have to validate it while working on the data notifications. And there is one more object name called object real world object concept. And we can also trigger the alert notifications like example conditions, maybe based on some values, or else if it is accurate number, contains data or not contains data. These are all the conditions configurations. By using the rules or defining the rules, we can trigger the action category. And finally, we can set the properties and action configuration of the 3 levels by sending an email or messaging via Teams, and even run the existing Fabric items too. These are all the items, if you're observing on the right-hand side, either the running of your queries. You can set the alert by using a 5 minutes of interval. The frequencies of lot of frequencies are there, even by 1 minute wise, 5 minutes wise, 10 minutes as per the business requirement. And conditions plays a major role on which level of configurations we are using. Is that event is meeting a grouped summarized value or a certain specific value. So these kind of notifications we can make use of by checking the conditions and value-wise, conditions-wise increase or decrease. These settings we can configure via this activator. So if you're observing, if you are trying to understand this real-time concept, there are 3 important things. For the event stream, we are going to inject the data processing and perform the transformations. That's what we understood. And coming to the next level, the data storage part in the Eventhouse, we can get it stored in the form of a KQL database. And for the triggering an alert notification, we have an activator. We can configure the automation process via this activator. So moving on to the next slide is going to be the polls. I'm expecting answers from your end. So please post your answers in the chat box. I will read the questionnaire. So as per your understanding, I'm expecting the answers as well here. Which Microsoft Fabric real-time intelligence component should you use to inject and transform data, real-time data? 3 important functionalities I have added: Eventhouse, Event Stream, Activator. So Rajendra, can you extract the data via Eventhouse also? No. Eventhouse acts as a set kind of database inside KQL database. From Eventhouse, we can start the data. We can have an option like a get data, and you can extract the data. I'm expecting an answer for this. The first one. Which language is used for? Sorry? Can you please mute? Which language is optimized for query real-time data in an Eventhouse? 3 different languages: Python, SQL, KQL. Yeah, so SQL, KQL, it is supporting for the best and optimization.
So we have Sanjay Chandra here. So firstly,
if you don't mind, can you please
join me in welcoming Sanjay Chandra. He's a lead data engineer in Canada, specializing in Azure Databricks and.
So I'm muting myself. Sorry for that. Okay. Getting disturbances. So last questionnaire, if you're observing, last one, third one. So this is the first poll, if you're observing, on the real-time concepts part. Which Microsoft Fabric real-time intelligence component is used to visualize and explore real-time data in the form of tiles? So in Power BI, we are aware of, we will prepare the visualizations like a bar chart, stacked bar chart, or maybe as per the business interest, we can use a scatter plot chart or time series wise line chart or bar charts. So if you each and every chart, we will call it as a tile. So as like that, and the real-time intelligence part, we can also prepare the real-time dashboard. So option is second one, real-time dashboard. For the second question, answer is KQL, Kuster Query Language. Even you can write the SQL statements too, but better You are going to work on the very huge sources, very huge data part, from gigabytes to, as I mentioned, right, petabytes of data. In such kind of a scenario, to handle seamlessly, always preferable to use the KQL. Even SQL is also supporting. You can write the SQL statements too. Going in further slides, I'm going to showcase to some of the commands, which will be very helpful to you. But as for the optimization, better to use for this KQL. And for the first questionnaire, if you're observing, inject and transformation, data transformations. Just like we know, right, in Power BI, once we extract the data, we'll perform some basic transformations like checking the data types, right, managing the columns, number of columns, or maybe number of columns. After that, you want to filter the data. These are all the activities you can perform at just like in the event stream part, not on the Eventhouse or Activator. So option B there. So hope you like it, the first polling. So I'm expecting answers too. So I will see the answers later. We'll move on to the next part, next level of learning. Okay. Real-time concepts, I hope it is clear. We'll move on to the next part. Use real-time event streams in Microsoft Fabric. We will go a little bit of in deeper, okay, on the event stream. As we already are aware, data ingestion and preparation, we are going to use the event stream in Microsoft Fabric. We'll go a little bit in detail, what kind of sources it is supporting, what are the different transformations it is, we can make use of it in the event stream regularly, okay, regularly. And even we can also observe some of the functionalities that are provided or observed in the event stream, how to publish it, these kind of concepts we will discuss on this part. And followed up with few set of questionnaires, okay, 3 questionnaires as a part of polling. Okay, please observe the things. Whenever if you are getting start the data extraction via event stream, as I mentioned, the source is important. What type of a source you are extracting? As I mentioned, you can play, if you want to learn this real-time data, how it is going forward, please remember, mark my notes. Going forward, most of the companies will expect real data only, real-time data. Okay, minute by minute or second by second information itself. Not like currently, we're extracting the data and we are scheduling it day and night sometime. And tomorrow morning, my end user is going to look over the report. Not like that. Going forward, definitely we'll get this kind of a requirement, which is in the real-time part. Real-time dashboards necessary is very, very needed. So whatever source you're extracting, where the data is coming from, that we need to get it understand. And once we got the particular source extraction, we can make use of either it is an example, Azure, log analytics, or Kafka source systems, or Confluence part, or from external data sources. Okay, we need to identify and we have a proper connectivity from the source to Fabric ecosystem. Definitely, we are going to make use of the components from the event stream, the data extractions, ingestion part. And from there, we will take to the next level. If you're observing here, source is there. We know, example, I mentioned it as a bicycle, or maybe you can also use for the sample data like stock data, which will be triggered from morning 9 to 3:30 p.m. on daily basis, except excluding Saturday, Sunday, minute by minute, or second by second, how the values are getting tracked and see that analysis. And where we are going to store that information, the data destination plays a major role. Because it's a real time, the data should be very huge. Is that going to be stored on the lake houses, or maybe the data will be getting stored on existing Eventhouse to the KQL databases? These things has to be getting listed. Even as I mentioned that in the real-time prospect as well. And on the top of it, here, as you are observing source and destination, recently one more layer Explorer is added, that is operator. What type of operations we are performing. Like, as I said, right? It's not going to be the raw data, get it sit or store anywhere. Event houses with the KQL databases and so on. We will perform some transformations, some required transformations, checking the number of columns. Maybe instead of extracting all over the number of more than 200 or 300 columns, we will try to limit modify the number of columns too. Or maybe if you want to perform some grouping criteria, group by categories too. Okay, like aggregating the data, we will process it and we will perform few of the transformations like a group by, filters, managing the union, joining the data from one to another. Okay, else combining, merging activities, and finally the data will be resides we will decide either it is the Eventhouse or Lakehouse or any other external streaming source systems too. So here, one more layer is there other than the source and destination. What type of an operators that have been performed on your right hand side sources, extracted streaming source system. So these components has been listed on your event stream. But the data, again repeating, the data is not going to store on your event stream. It's going to reside inside as per the choosing, like event houses inside the KQL database or Lakehouse or any other external source streaming source systems. This is how the extraction we will take it handle. So maybe we'll get a questionnaire. What type of a sources it is supporting? Yes, yesterday, 2 or 3 days back, as per the monthly release from Microsoft Fabric, few more new data sources has been added. And these are the current, if you're working on the real-time part, these are the current data sources. Azure Event Hub. I'm currently working on IoT data extraction because one of the project sensor related information I'm extracting via cloud, which is changing the data by minute. So we have to capture each and every record in the form of by using the temporal windows command, which I'm going to cover it on the next slide. And these are the set of data sources where series is transfer change data capture. Either it is an Azure SQL database or Postgres or any Google Cloud Analytics, Kafka as I mentioned, blob storage house, is there any samples? Maybe for your first learning curve, you can also play with some of the sample data provided by Microsoft, like stock market or real-time weather as per your location, wherever you are located. It has to get changed, right? So you can also play with the real-time weather related stats. Okay, and the values or data will be sit on your dedicated destinations, like is that in the Eventhouse or Lakehouse or external custom endpoints too. These are the supporting destinations currently. Okay. Few of the transformations which I have mentioned here, whenever if you're after extracting the data, we will definitely perform some transformations like managing the fields or columns, or maybe if you want to filter with some of the records with particular year, or maybe if you want to see some particular timestamp, I want to perform some of the unions and join conditions. These are the left-hand side, some of the transformations, which we are familiar. For summarizing the data, we will use the group by transformations or union with similar number of columns. We will try to, instead of loading it as a separate table, we will do the union, join it and combine all together. And maybe we will perform some of the set of joins, which we are already aware, like a left outer, right outer, and so on. This right side, the specification is temporal functions is very, very important. I have prepared one slide for you. Let me showcase that. Let me know once you're able to see my screen. So as I mentioned, the temporal 5 different functions are there. Tumbling, sliding, session-wise functions, hopping, and snapshot. If you're observing, the first one is the tumbling. So as I mentioned, each and every record in the streaming data, we will call it as an event. Assume that in the first time series, we have this particular workflow, okay, work activity, multiple events are picking up. And each and every, if you're observing, each and every stream is not at all overlapped. There is some time frame gap. And the next event will be get started with set of or batch of records. So this kind of a setup, okay, tumbling windows function, such kind of a scenario, you're going to use, it divides the event stream into a fixed, it is not at all overlapped. One event, one workflow to the another workflow. And there is some limit, time gap is there, and the next event will be get start after the finish of the first workflow. So each and every event belongs to one Windows function. Minute by minute, either you can perform the aggregating functions like sum or average or counting the values. It definitely works as per the scenario. There should be some time gap. No overlapping exists on whenever if you're configuring the data, real-time data processing part, this tumbling function. Another sliding, how it looks like. There is, if you're observing, without completing the first workflow, another workflow already gets started. That means overlap is there. So it's not missing any data in between itself before finishing out. Second workflow will be get started. So data overlap is happening, and the hopping part, data hopping part, if you're observing, another event has been get started immediately. Okay, like that, if you're observing W1, W2, how it has been overlapped, this kind of a scenario, whenever if you're calculating the rolling averages or cumulative analysis, such kind of a scenario, this kind of a sliding functionality will be very helpful. And below, I have added some little bit of coding there, like how we can try to make use of the sensor data summarization function wise. So this is an KQL database part. We can write it and we can see the analysis. Approximately, I mentioned with multiple, like 7 workflows ecosystem. Like that. One more, if you're observing, next function is sessionize function. There should be a gap. Each session have a little bit of, huge gap after completion of the session. Even though complete each and every session have a group of activities or events which works together, and once it is completed and have some ideal time, and the next session is getting started. And if your data comes in this kind of a flow, you are going to make use of session function, sessionized function. Okay, like session 1, session 2, there should be a gap here, session 3, okay, gap. And it is ideal for, as I mentioned, alert mechanism. And if you have an ideal time to get start with the next session, this kind of functions we are going to use, a temporary function, we are going to use it. And if you're observing another function hopping, this is as same as sliding. See here, overlap is there. It's having an overlap, okay, and having a fixed size of another event, producing the same overlapping mechanism as like a sliding, but hopping, there is a disrupt. Okay, it is not taking everything, okay, the events, the records, in the same manner as like a sliding. There is a gap, and as well as after in between itself, the second activity, second workflow activity event has been getting started. So if you are trying to prepare the real-time analysis on an overlap based, your data comes up on every time, 10 minutes of Windows interval with 5 minutes of change, data capture change, such kind of a scenario, hopping function will be beneficial while configuring it event streams level. And the last part is snapshot. Completely a group at particular timestamp. So if you're extracting the data, real-time data in a group wise, or else a batch wise, all the events has been configured as triggered in the form of one single group. And until the wait is going to be until for the next event or as next set of batches or events will be get it happen, it will wait and then process further. This is nothing but a snapshot. Or as maybe in the simple term, we will take a backup by using a snapshot and it will be make visible for further analysis until the first analysis will be get completed. Like that it works. Most of the real-time projects I'm currently as using here, tumbling function, which my interval based, okay, aggregating as well as once completing that without any overlap, I want to capture the next event. I'm using the tumbling. And I have to try for hopping as well. So how it will be work based on the real-time analytics. So these are the different functions that we have when we're trying to configure the type of data, real-time data, and you can configure these functions. That's what here I have mentioned, temporal functions. Okay. Fine, that's what I have prepared for next, okay, second set of question it is polling. I'm expecting an answers from your end. So this is the second part. What is the primary function of Microsoft Fabric event stream? I'm expecting an answers in the chat. Please post it for first one. Second, what does temporal Windows transformations enable you to do? Is that performing and aggregating event data in stream based on specific time period, or automatically enabling the schedule timers, deleting the retention of the period? Please read the options and answer for second one. I have explained the temporal Windows function in detail. Please check it. Okay, maybe just if you are taking as already a snapshot, just observe it. And the third one is, what is the purpose of Fabric activated destination in an event stream? Any guesses on the chart? Anybody? Any guess here? We just discussed about event stream functionalities, components, as well as Windows functions. Windows functions, there are a set of functions, as I said, 5 different functions are there. How it is going to work based on the time frame. I will read the answers as well, no worries. The primary functions of Microsoft Fabric event stream is injecting and transforming the real-time data. That's the first option. Third option for first question. For second one is, what do temporal Windows function transformations enable you to do? It's going to perform the activities specific time period and aggregate the event streams, event data part. First option. Third one, what is the purpose of Fabric Activator? The main activity of Fabric Activator is data sent to an activator, and it is get trigger and send an automated emails via multiple ways, like an email or Teams, or you can also Fabric ecosystem wise we can configure. Option A. Okay, first one. For third one, for third questionnaire, first option is the answer. Moving on to the next last part of activity. See here, work with real-time data in a Microsoft Fabric Eventhouse. So, as I said, 3 layers I have configured our today's session. We discussed about real-time analytics. We discussed about event stream analytics, real-time data. And third concept here, work with real-time data in Microsoft Fabric Eventhouse. Okay, please understand. So we are already aware, event stream is for the data ingestion and the data transformation. How this event house with some of the KQL functions has been written here so that it is helpful to you. Okay, please observe. Via Eventhouse, as I mentioned, each and every record in a streaming data as an event, one event. And each and every Eventhouse contain one or multiple KQL databases too. Either you can import the data by using the get data option, which you are observing on the right-hand side, get data. And from there, you have to get it configured from the importing from a static files, like importing the files, or maybe if you want to configure the real-time data via event stream and so on. But as I mentioned, one or multiple KQL databases, we can get it, create Eventhouse. Eventhouse acts as like a cluster here. So in an Eventhouse, you can create multiple KQL database as per your project defined, and you can write that in the form of a query set, KQL query sets too. Some of the queries you have, if you are observing on the left-hand side, first one is a KQL query table, which is an automated related. And you can similar as like a SQL wise, you can see the similar commands like a where command, sort by. Okay, these are all the things we will observe in the SQL part as well, SQL part. And below, if you are observing, that is a SQL statement. Even you can execute your SQL statements too. But better for the data optimizations part, preference should be on the KQL with a simple statement like where command. Our project is almost as same like in select statement. Project is the command which you are observing. Project is nothing but a select statement almost. Select trip ID. These are the columns which I'm trying to pick it over. Okay, these are the columns like a trip ID, pick up, date and time, fare amount, and so on. Okay, and order by and by using design. This is common here, designing or assigning as per the data sorting order, we can configure accordingly. Okay, you can make use of it. A few more effective ways of KQL databases wise. How we are going to filter means, this is simple. So if you're observing, automative is one of my table of data source, which I have given in the form of a table information, and project is a select information. These are the columns which I want to get it extract. The data will be getting filtered as similar as like a where condition. What are the last 30 minutes ago? How many number of records I want to observe? In such kind of a scenario, filter and greater than timestamp. And those are the number of columns for the further analysis. So here, if you're observing specifically, I'm using a pipeline is the operator. So it works as in the form of 2 things. For logical operator wise separation, operator wise to call the multiple columns, and even for the concatenations too. Okay, ampersand. So ampersand also one of the functionality we can make use of it. And along with that, for data summarizations like average or summation or minimum or maximum values, to finding out, we can use summarized function. Okay, pipeline should be common. Whenever you are entering the table, that is an automated table. Once you click on the enter button, automatically the pipeline will be get added, and from there, conditions as well as summarization functions will be get added here. Okay, so once you open once you can start working on the KQL database, there is a guide setup also available. You can go with this guide as well. Okay. And for the optimizations part, as well as syncing with existing values, summarization of the values, we can also, materialized view also has been created in the while defining the table level. So materialized views and parameter creations also works on your transformations part, data loading as well as query setting part. And I just written few of the statements, materialized view as well as the storing functions, which you can take it. Okay. Few more questionnaires before moving on to the little bit of showcasing of a demo. Few more last questionnaire here, last set of questions. What is an event house? Expecting an answer from event. What's the purpose of using project operator command in KQL, question query language queries? Just to discuss. How can you create a reusable parameterized query for KQL databases? Expecting an answer, please post your answers there. Anyway, I'm going to read it. Event house is nothing but a data to store your real-time data in the form of an SQL database, KQL database. Not SQL, KQL database. One or multiple, okay, more KQL databases we can get it to create on an event house too. As I mentioned, project operator works as like a select statement. So to specify number of columns, which column to include on your query output, we can make use of this project on your question. For materialized view part, reusable parameter, we can create the storing function on materialized views on the top of it. So create the stored functions. We can make use of this parameterized queries in the KQL query database. Fine. We will work on a little bit of the front end view, how it looks like. Okay. And then if you still have any queries, I will take your queries. Okay. Let me showcase to you another window. Hope you like this. Hope you got the idea, the number of functions that we have whenever, if you're configuring the data as per your source of information, like is that a minute by minute of time intervals, or is there any gap between one set of events to the next set of events? These are the 5 different functions. Let's move on to the little bit of demo. Okay. I'm using the same workspace. Yesterday we created one of the workspace, GMUSC. Okay, I'm going to use the same workspace. So here, as I showcased to you, if you want to get it, extract the data and try to see the information, here itself you have an option like a real time. Once you have a proper workspace with a Fabric trial license or Fabric related workspace, Fabric capacity workspace, we can get started as well if as per your defined projects. On the left-hand side, you can get started with adding the data, type of data. So these are the different variety of data source systems that is supporting on your real-time source systems. So for your practice part, some of the sample data we can make use of like a stock market as a set, some of the sample sources like stock market or bicycles, hello taxi, even the weather related also, we can start utilizing. So variety of sources. Okay, data sources. So from here, we can get started and create the event information and perform some of the transformations, get it stored on your event houses, and further proceeding with the real-time dashboard. Let me showcase to you one of the example with stock analysis itself. Okay, let's do instead of real-time showcasing, I just do this sample data itself. Stock market. See here. Assume that you are going to extract one of the real-time data, that is the stock-related items. By default, you can see the source name, source stock market. On the right hand side, maybe if you want to change the streaming naming conventions, you can change it. Underscore is preferable. Maybe you can change as per your business needs. And click on next. Okay, I'm just following the same set of naming conventions. Okay. And you can see where we can review it, what type of a source you are extracting. Example, I'm using the stock market. Maybe if you are trying to get connected to the log analytics, you can see the log analytics architecture. There is a source and dedicated detailed information, and how we are going to project or where the values, that streaming information will be getting stored and which workspace. Those details you are going to observe in the form of a review. Okay, here. These are the two steps: configure, review plus connect, which type of a source. These details you can observe it. Please keep in mind the type of icons that we are using. So if for event stream, this is the streaming icon. If you're observing yellow, pink color streaming data part. Let's try to see what happen if we can start get connected to this. It will take some time, few minutes for the processing. If there is any issues, right? If there is any connection based some issues or configuration level some issues, automatically it will stop up to this part itself. Even though if it's connected, it will get stopped and throws an result. Okay, it's not able to connect, or else the permissions issues, or even maybe there is a data connectivity wise, there is a timestamp or ping level issues. These network or these configuration throughput issues will be get registered there. So whenever if you are finding those real-time issues, we can see the stats and that particular window, and you can just raise the tickets internally, okay, within your community or organization. Fine, let me get started. So here, once you complete it, connected, even stream sources get connected. Maybe if you want to perform some transformations on the top of this particular stock market, you can open it. But as of now, many other columns are there, multiple columns are there from the stock market. But I want to perform some of the transformations, like I want to filter the data, or else I want to manage some of the number of columns, removing unwanted columns. Such kind of a scenario, you can directly open your event stream from here itself. I'm opening here. This is the look and feel. If you're observing on the left-hand side, event stream has been get open. These are the number of columns, the raw data from the stock, which is an active. It's been available. And here you can perform some transformations on the top of it, like grouping or union. Maybe if you're joining some another sources, or maybe if you want to manage number of columns, you can perform here at this level. Okay. And as I said, if you can click on here. 1 second. Yeah. Please observe. I want to, these many columns are there. I want to control with the timestamp, or maybe sector I'm interested, and bid price. Okay, these are the bid price. These are the 3 columns. I'm very much interested to see the analysis. Here, we will perform some transformations. Like example, as I said, managing the columns. You can select it, add the columns. What are the columns that we are looking for? Timestamp, sector, bid price, add it. Say few columns only I'm picking up. But fine, after performing, I want to see the result also, right? So where do you want to see, and as well as where we are going to store these results? That is important. So see here, these are the number of columns, which I'm very much interested. We can perform, and further, if you want to set the destination, here you can configure the destination, or from here also you can set the destination by clicking on this and adding the parallel nodes. So I'm using the standard process, adding the destination. Maybe I'm going to create and load this information onto my one of the event house. I will create it in new event house name, stock. Stock DB. Table, if you want to give it as a new name, you can create it as a new table name, or some by default already stock DB is there. It will also project it, or older tables also you want to replace with the existing table, you can also replace it. Like that it works. Okay, but basically we will use creating a new table as a specifically for this project. Okay, some another table as well. I'm creating a new destination of the table. Create it. Just glimpses I will showcase to you and then we'll stop. Okay. And don't forget, here we can have to get it connected. See this? We have to give a connection to this as well. And the input data format should be on the JSON file format. And you can also see where we will try to configure the query set from the Eventhouse, and as well as some more important functionalities like real-time dashboard, how we can try to navigate those informations and so on. We will observe it in a short. Let me create it as a new table. Stock managed fields. Save it. Currently, we haven't published. Once you publish, it went to the live mode. Okay, let's try to publish it. It will take some time. So, as I mentioned, we can get start from the left-hand side real-time hub and get start with the data extraction via event stream and perform some transformations. So this is currently loading. So if you're observing, these many columns are there. We picked few columns only: timestamp, sector, and the bit price. Still it is loading. Once completed, once the data is going to available, let's try to navigate to the event house itself. So how we are going to navigate from here, we can configure the same set of event stream which we have been get configured stock DB, and we can see that further analysis to event house. It's loading. Let's see. Any questions, Smita? Do you have any questions?
Yes. Can you
Yes.
can you hear me?
Yes.
Yes. So by the
Yes,
time it takes time to load, maybe we can take few questions.
Yes, go ahead. Let me check the
Okay.
question.
Just
So
want to
there is
inform
question
you
from
that
Rashmita.
people are also continuously answering questions what you are giving here on YouTube, and so a lot of answers have been given. There is no question there, but yeah, by one answer, two, three questions, answer one, answer one, two, answer two, one, answer three, one. So thanks the YouTube audience to be really active, and just want to inform that there is a lot of action happening there.
Okay. Is this question answered? How do teams decide whether to perform filter? This is the requirement, right? As per the requirement based, we will perform many as kind of a transformations like filtering or joining. These are the transformations we will be getting performed. But where it will be get stored is the very important as per the performance prospect. How many number of columns we are picking up. So here you are asking two questionnaires and aggregation in SQL versus handling them. Here also we will perform the multiple transformations inside Rashmita. So as I mentioned, so event stream level, you can perform the transformation. At the event house, we have a query set functionality. There, you can perform the different various levels of aggregations too. So as I mentioned, KQL query set part, you can write the KQL statements, whether the various like a summation or aggregating functions like a count or doing the based on the timestamp files, we can trigger and configure it, and we can perform those activities too. Any other question here? I mean, these are all questions with answers, right?
Yes, Rajendra. And we also have one more question saying that in
Yes.
real business project, how do teams decide which window type to use for streaming data when they need both fast results and accurate processing?
This is how there are 5 functions as if you're observing. Tumbling, sliding, session is how the data is coming. Is there any interval timestamp between one number of events to the another event? Yes, in such kind of a scenario, we will use the tumbling. No, it has to be cover the last 10 minutes data, which is partial. After that, we will get the full data. In such kind of a scenario, we will make use of sliding, like overlapping the data. Okay, existing if you're observing, overlapping analysis from which W1 to the W2, which is an overlap. I want the previous 10 minutes earlier record plus the new data. So based on our databases, how we are pulling over. So type of information on a minute by minute or second by second wise analysis, we will try to pick these type of functions. So 5 different functions out there. So if it is overlapped, then obviously within a time frame of 10 minutes of interval on every 1 minute, if you want to get it updated, the hopping function, you can choose the sliding. Without any overlap mechanism, there should be a sequence. After completion of the first job, second job has to get it executed, and there is a time frame limit. Such kind of a scenario will get started with this jumping functions. Like this, we have to choose within these 5 Windows temporal functions. That's what it just framed it in this way. Okay, or maybe if it's a bunch of activities, which is group of activities, group of events has been triggered or working. In such kind of a scenario, you can make use of a snapshot. Okay.
Yes, Rajendra.
So this has been completed. And I just want to showcase the table and then we will wrap up. Okay, how the table will be get it available. I'll just try to showcase and we will wrap up. So this is where you can also find some of the KQL guidance, okay, from the Microsoft Learn portal. So most of the time I will also relay on these comments. So if you're observing KQL quick query references, so it's very, added advantage, maybe which kind of a functions. Most of the functions are similar as like an SQL, but it's a better to use this KQL guide to make use of your type of, okay, either it is a sorting or grouping. Okay, or else maybe if you want to search that particular number of columns, okay, you can make use of this KQL guide as well. Okay, fine, I'm done. And if you have any questionnaires, I'm happy to answer. And if you want to reach out to me, you can connect me via LinkedIn. I'm happy to help you there. And again, one more time, thanks, Amit and Global Microsoft Community Platform team for giving this opportunity for yesterday's event, ontologist topic and real-time intelligence topic with the 3 different layers which we discussed for today, real-time analytics and Eventhouse and event stream. Thank you.
Yes, Rajendra, thank you. Thank you for your time and helping us understanding about building an enterprise ontology with a demo and making the session engaging. Thank you so much. I have also shared your LinkedIn profile in the chat. Maybe if anyone wants to connect, they can connect.
Thank you. Thanks, Amit.
Thanks, Rajendra. We already have the next speaker, Kevin Jain, with us. So let's welcome.
Yes. So we are excited to welcome. Hi, Kevin.
Hi, all. I appreciate the fact we're running a couple of minutes over schedule, so I'll make sure that I do a bit of catching up for everybody here. So you've probably already seen this slide already about today's event. And now my clicker has decided not to. Moment. There you go. So, welcome everybody to today's session. Microsoft Fabric and Azure DevOps, the story so far for 2026. Now, as you can see in the overview section, basically I'm going to cover how to use Azure DevOps to perform CI/CD for Microsoft Fabric. Now, before I go any further, if you've not entered this competition already for the event, please do so. Start back again, just in case everyone needs to take a QR code, etc. Hopefully one of the moderators will fire a link for you in the chat as well. So here's the agenda for today's jam-packed session. First, I'll quickly go through my bio. Then I'll do an introduction to Azure DevOps. Then I'll talk about configuring Azure repos for Microsoft Fabric Git integration. Then I'll talk about using Azure DevOps and AI with suggested workflow options. Then I'll finish off talking about CI/CD for data warehouses and SQL database in Fabric. Very quickly, a bit about myself before we get started. My name's Kevin Chant. I'm a lead technology advocate living in the Netherlands, Microsoft Data Platform MVP, certified trainer, etc., etc. and you can find me online in a few different places. So let's jump straight in. Reasons, first of all, to perform CI/CD for Microsoft Fabric. Just a reminder for all the attendees. If you are attending with Teams, feel free to put the questions in the chat. If I need to repeat something, feel free to try and let me know. So, reasons to perform CI/CD for Fabric. First of all, faster and consistent releases of the Microsoft Fabric items from one workspace to another. And also, just as importantly, early detection of issues, because the sooner you detect issues in a stage, the better. As this diagram clearly shows for you also, as you can see here, what this diagram is essentially saying is that the earlier you detect an issue, the least work basically you will have to do to resolve potential issues. So now a bit about Azure DevOps. It manages the application lifecycle management, all the way from creating an initial work item to doing the release. In reality, Azure DevOps itself is a collection of services, like some of the example ones you can see on the screen here. So for example, Azure Boards to manage your work items, Azure Repos to maintain your Git repositories that are stored in Azure DevOps, and Azure Pipelines to orchestrate your deployments. There's two main versions of Azure DevOps: Azure DevOps Services, which is basically the cloud-based version, and Azure DevOps Server, which you can install on your own server. Just be aware that at this moment in time, only Azure DevOps Cloud Services is supported for a lot of the Fabric CI/CD options. And there is now an MCP server available for Azure DevOps. So basically, you can do certain tasks in Azure DevOps with natural language. So those of you looking to work in a more agentic kind of way or just with AI may be interested in working with it. So I'll very quickly go through a walkthrough now of Azure DevOps and a little bit of a hint of AI as well. So this is Azure DevOps when you first go into it. At the top left-hand corner, you have an icon that represents the account you're logged into Azure DevOps with, as well as the tenant, because that has a bearing on the organizations that you will have access to. Now, these organizations can be ones you created yourself for testing purposes, or it can be ones provided to you by work. Now, if you have the right permissions, it's a bit bigger here. It seems to, yeah, that's better-ish. You can change various settings at the organization level. So as you can see, there's quite a lot of options here. Obviously, this is only a 1 hour session. I'm not going to go through all these options. Some key ones I will highlight, for example, if you want to link an Azure subscription to a new organization, you would click on billing. If you want to connect or disconnect from an Entra tenant, you would select Microsoft Entra. If you want to customize your work items, you would select process. So for example, here I can click on process. You can see I've made a copy of the Scrum work item. Just help with some terminology here. A process is basically a template for how you work with work items in Microsoft Fabric. So essentially, this is how you work in Azure Boards. You can customize it. If I click on this particular version here and click on product backlog item, those of you who've worked with product backlog items in my Azure DevOps before will notice I've added a stakeholder column here. Just a small example of how you can customize your work items in Azure DevOps. Another one I will highlight is in the pipeline settings. Now, Microsoft a while back introduced the ability to be able to disable the classic pipelines. So basically, there's two types of pipelines in Azure DevOps. There's what's known as classic-based, which is all GUI-based, and I'll show that in this session. And there's also YAML pipelines, which is basically you can consider as code. It's all YAML-based. So here, if you can't find the way to be able to work with GUI pipelines, basically the classic editorial releases in Azure DevOps, it's probably because your Azure DevOps administrator has enabled these settings. And as you can see, there's a variety of other settings available here that you can go through. Now, before we look at projects, a couple of other things I will highlight here. First of all, well, actually, I'll go through projects first, and then I'll mention about the marketplace, because it makes it easier for everyone to understand here. So if I go into a project, as you can see here, all the projects, when you create them, they can contain the default services like I was mentioning earlier. So on the left-hand side, we've got Azure Boards, some Azure Work items. You have Azure Repos, and if I click on here, you can see a visual representation of your Git repository. You have Azure Pipelines to orchestrate your deployments. If I click on here, well, I can quickly show you. So for example, here is an example of a classic pipeline. If I click on Edit, you will see it's all GUI based. So you basically add tasks on the left-hand side. It's quite intuitive to work with. Whereas if I click on this particular one, you can see it's all YAML based. So that's what I meant just now, the difference between classic and YAML pipelines. Then you have test plans, and this is where you can manage your test plans and test cases directly in Azure DevOps without having to work with spreadsheets. I quite like this because it means that you've got one golden source of truth for all your test plans. And then you have Azure Artifacts, and this is where you can store, for example, long-term packages directly in Azure DevOps. If you come from a GitHub background, this is essentially the same as GitHub packages. And just like at the organization level, you can change various settings at the project level. In the real world, out of the two, this is probably the one you will have the most influence over. So as you can see, I can assign people to teams here. I can create service hooks to third-party web services. You can connect to GitHub. Now, there has been some discussions recently. A lot of people are actually migrating their repositories from Azure repos over to GitHub to take more advantage of working in, well, take advantage of working in a more agentic way. There's quite a fair bit of material relating to all of this online. Microsoft does provide a migration aid as well to help move your repositories from Azure DevOps to GitHub and keep all your existing links and your work items, etc., if you so wish. Not going to dive into it right now. I'm just highlighting the fact that that is a potential option. You have various pipeline settings here, and this is where I will highlight a key thing relating to service connections, because you create service connections to things like resource groups in Azure or directly to an entire Azure subscription or tenant, like you can see here. If you are going to create a service connection to connect to anything at all in Azure, like a subscription, etc., always give your service connections a user-friendly name, because if you go click, click, click all the way through, you could end up exposing sensitive details in your service connection name, such as your Azure subscription ID. And whereas you may think that's not a big deal, if your Git repository, if you end up hard coding in your service connection and it becomes publicly available, your subscription ID details will be cached online, potentially. And there's a few other settings here as well. You'll notice at the bottom, I've got some settings you may not have in your project relating to extensions. You can extend Azure DevOps services by installing extensions. Some are free, some come at a cost. What I can do for you now, click on here. I will open up the marketplace in a new tab. And what I will do here, I will just type in Microsoft Fabric. So, and click on search. To cut a long story short, up until March this year, even though Microsoft Fabric has been around for nearly 3 years now, there's not been any at all Azure DevOps extensions for Microsoft Fabric, specifically for Fabric, available in the Azure DevOps Marketplace. As you can see now, Since March, 3 have now appeared. So first of all, there was the deploy Microsoft Fabric with CI/CD appeared, and then the Fabric automation tools appeared a few weeks later, courtesy of the Microsoft team behind Fabric CLI. And then a few days after that, a new one called Fabric Catalyst has appeared. I'll put the link to the first two in the chat for everybody. So if you are using Azure DevOps and you're looking to be more efficient with your code when doing deployments, you can look at these two, well, the two options I put in the chat, and you can look at the third option as well. By my own admission, I've not looked in the detail in the third one as of yet. I have done the first two. But it's not just Microsoft Fabric extensions you can install to make yourself work more efficiently. You can, for example, install the very popular sprint goal extension. And that means then when you're working, for example, with sprints, you can add a sprint goal to your sprint task board, and you can add it to a dashboard as well. So a couple of other things I'll highlight in each project. You can create dashboards. And of course, typical, I'm doing a live demo, so a widget's photo load for my burn down. But as you can see here, the sprint goal extension, you can add directly as a widget in the dashboard, which means that every time you do a stand-up, you can remind your whole team what the sprint goal is. You can also create powerful wikis as well. And I will admit, I did not create these wikis by hand. And this very nicely brings me to my next demo. So I actually created them with the Azure DevOps MCP server. Now, if you're working with MCP servers, you can work from them called desktop, you can work from in Visual Studio Code. I'm working with some in Visual Studio Code, as you can clearly see here. I've gone through the steps to. So I'm just going to make sure that the Azure DevOps MCP server is started. So if you press Control Shift and P, that will list your servers. You don't want your MCP servers if you have a list of them running all the time, because that can end up causing you a high amount of usage if you're using GitHub Copilot and VS Code, for example. So I'll give you an example now. I'll see if I can pop the chart out so you can see more sense of this. So here, as you can see, I'll make this bigger for all the audience because I appreciate some of you will be seeing this on a smaller screen. So as you can see, I am using natural language here to get information from Azure DevOps. And I'll answer the question in the chat shortly. So I'm going generating lists here. But what I actually did, if I scroll a bit further down, actually, it's saving me scrolling all the way down for you. Basically, those wiki pages I showed you just now, I actually created with this MCP server. So in fact, this MCP, Azure DevOps MCP server can be used to create those nicely detailed wiki pages. Depending on your prompting skills, you can make them as detailed as you like. And it can do something else as well, which I'll show you in a future demo in this session. So I'll leave this open for now, but be aware, you can use this to create rich wiki documentation as well. Now, there's a question in the chat. How do teams decide whether to use classic pipelines or YAML pipelines in Azure DevOps when building CI/CD workflows? Well, it partly depends on your preference, but to be honest with you, Microsoft had reasons for introducing those settings. There are some potential issues with working with classic pipelines. And one key point I will highlight is that if you work with a YAML pipeline that stores a YAML file, or maybe multiple, depending if you're working a bit deeper with it, in files in your actual repository. So when you move your Git repository somewhere else, or if you import it into a new organization, for example, it's very easy to set those YAML pipelines up again because they're so portable. Whereas with a classic pipeline, it's not so easy to reproduce them if you have to create a new one. So for example, you'd have to go into a classic pipeline, extract all the different schema, YAML schema used for the different tasks, or have them side by side and sort out all the GUIs again. So to be honest, how you decide if you want to be efficient and you want to work in a proper infrastructure as code way, you should really be looking at YAML pipelines. Also, another question's just come in the chat. When connecting Azure DevOps for services like Fabric or Azure Resources, what are common mistakes teams make in service connections? Well, the first common mistake I've highlighted just now is just going click, 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 instead of giving the service connection a name. The second one is most of the time relating to authentication. So for example, if you want to use an Azure key vault and it's got a firewall configured, and you want to get the secrets from that Azure key vault within your YAML pipelines, etc., you have to make sure you, excuse me, you come up with a way to securely connect up over to Azure key vault. Now, contrary to common belief, if you select an Azure key vault allow secure Azure approved Azure services, that list of Azure services does not actually include Azure DevOps. So you have to consider either if you've got your own self-hosted Azure DevOps agents, your Azure DevOps pools, you'd have to put your IP addresses of your connections into that, or look at something like managed DevOps pools. So that's the main issues, is naming and connectivity. So that is Azure DevOps, a very brief overview. It is a large ecosystem. You can do a lot with it. This is a short introductory walkthrough. And I wanted to highlight about the MCP server as well, because it can make your lives a lot easier. Now, let's talk about Microsoft Fabric Git integration. Now, Microsoft Fabric Git integration allows supported items in a workspace to have metadata synchronized with a Git repository. To be more precise, it allows you to synchronize a workspace with a branch in a Git repository. Now, it supports cloud-based versions of Azure DevOps and GitHub. You can look to use GitHub instead, but there are some things you will have to consider, like working with personal access tokens. It requires Microsoft Fabric or Power BI Premium capacity. And it supports Fabric items at various levels. So for example, if you create a Power BI report in a workspace that is configured with Git integration behind the scenes, it will create a Power BI desktop project. If you create a SQL database in Fabric, behind the scenes, it will create a database project. However, if you create a Lakehouse, behind the scenes, it will save a container for the Lakehouse name and any details about shortcuts, and that's it. It does not save the metadata at this moment in time for your nicely curated Delta tables. So here's an example of items that are currently supported by Git integration. As you can see, some of them are in preview. It does support interesting things like data agents. So if you're looking at data agents at the moment, you'll be pleased to know they are supported by Git integration at this moment in time. As you can see, there's other things supported that are in preview, like all gaps, etc. And as I mentioned, things like lakehouses, notebooks, etc. And quite interestingly, Maps is currently supported and in preview. So when it comes to configuring Fabric Git integration with Azure DevOps, it utilizes Entra authentication. It can be a user or a service principal. The user requires access, or the service principal as well, will require access to both the workspace and the repository. If you are going to look to use the service principal instead, bear in mind that the service principal will need to be added as a user to your Azure DevOps organization. Actually, just going to put a link about Git integration in the chat for you all as well, whilst I'm at it. Now, I just want to dispel a myth here. Unsupported items can still be deployed in the same workspace. So if you have Git integration configured, you want to work with unsupported items, which aren't many at this moment in time, you can still deploy them to the workspace. Now, have some security considerations. Keep your organization and your repository in the relevant region. That can be quite important, especially if you're dealing with things like GDPR, etc. Keep your Azure DevOps organization private, because if you do end up, like I mentioned earlier, exposing your Git repositories, they can end up, even if they're just cached in your region, they are still a little bit exposed if you make them public. That brings me to my next point about avoid exposing sensitive details in repos and pipelines. So, for example, as some of you are probably aware, at times data engineers can do some interesting things, like when they're testing, like putting access keys for Azure Data Lake storage accounts directly in notebooks. You want to avoid doing that and committing the changes with those access keys in there, so they don't end up being stored in your repository. And with that in mind, you may want to configure or consider even configuring what was previously known as GitHub Advanced Security for Azure DevOps. Most people just commonly call it Advanced Security now. So basically, GitHub Advanced Security, all the features from there have been ported over now into Azure DevOps. This means that you can do things like code scanning, etc. It will actually detect things, various types of secrets, such as Azure Data Lake storage access keys. So if somebody does try to commit to a branch and you've got advanced security enabled, it will prevent them from being able to commit that change to your Git repository. Now, it's good, but like with all good things in the world, it comes at a cost. So read the small print, because it does backdate so many people who've done a commit to your repository in so many days. So bear that in mind. And I'll do a Git integration demo for you all now. So I have a blank workspace, which I imaginatively call blank workspace. If you go to workspace settings and then Git integration, I will make this bigger for everybody watching. I can click on Azure DevOps and I can select an account. I'll select my Entra account, and then I can go through this intuitive drop-down list to connect up to an organization and select a folder. Git folders can be important, especially if you are considering setting up multiple workspace groups in one Git repository, because then you can have a different group of workspaces in a different subfolder. Now, I have already done this, so what I will do, here's one I configured earlier. And as you can see, I've got it all configured here to connect up to an Azure DevOps organization, project, repository, etc. Now, when you have Git integration enabled, a couple of interesting things will appear in your workspace. You'll get this Git status column by default. It'll tell you whether your Fabric items are synchronized with the Git repository or not. Bear in mind, this only synchronizes the metadata, in other words, the schema. Doesn't synchronize any data. You'll also get some additional functionality here. So including now, you will be able to see related branches as well. But what you can do here, you can go through a GUI and select features like branch out to workspace, etc. Or you can check out a new branch, or you can switch to another branch. So it could be you're working on a feature A branch behind the scenes it's connected to, but you may want to connect it to another feature branch instead. So you can select switch branch. Branch out to new workspace, I will cover a bit more shortly, but I will actually open it up now to save the benefit of everybody. So what this will allow me to do is effectively make a copy of a workspace and branch somewhere else. And when it does the copy, it will copy over all the items, but not the data itself, just the metadata, the schema effectively. And there is something new that was announced at this year's FabCon. You can now branch out to a new workspace, but only do it for selected items. This is very useful if, for example, you've got a lot of items in a Fabric workspace. You want to branch out to what's known as a feature workspace, but focus on any particular items. So I thought I would highlight that here. So I can also show you a nice, in case you didn't know, when you've got Git integration enabled, you can click on the ellipsis in the source control, click on view repository. This will take you to the correct repository, and this is very useful if you've got a large number of repositories and you want to go quickly to the correct one. So I wanted to highlight that for all of you here. So, moving forwards. Last year, Microsoft released an article. So last year, Microsoft released an article about suggested CI/CD workflow options. Not last year, September 2024, I should say. So here I provide guidance on how Azure DevOps fits with Microsoft suggested CI/CD workflows. Just put a link about it in the chat for you all. So first of all, I'll talk about the recommended development process. So whichever way you do a release, in other words, whichever way you decide to do the CD, they recommend the same stance, but whichever way you're going to do your deployments for the development process. So the development process is what you do at the start. You can think of it of doing the CI part of CI/CD, because it is part of the process for doing your continuous integration. So what Microsoft recommend is that you actually work with feature branches like other software developers have done over the years, and then merge your changes back into the next branch. It could be the main branch or it could be a dev branch, depending on your environment. And I suggest you take it one step further and actually introduce unit tests to be performed automatically when you go to do your merge from your feature branches to the next branch on in your stage. And here I showed doing it for Power BI reports, because you can use Tabular Editor, for example, to check your semantic models. But you can also do it for other Fabric items like data pipelines as well. And you can do it for data pipelines. For those who don't know, there is a really good framework to do this called the Data Factory Testing Framework. I'll put a link for it in the chat. Now, there's various ways you can branch out the new workspace. I already showed you the first couple of options just now with that functionality in the GUI, but you can also automate it in an Azure pipeline. And this is how you can automate the branching out. Now, Microsoft actually has scripts available in what they call the Fabric Toolbox that you can go through to do this. And it shows you how to do it. And first of all, get what's known as a Fabric Bearer token, which is a special authentication token you get. And you can store it in Azure Key Vault. Alternatively, you can slightly tweak their script and actually put that bearer token in as a parameter once you've gone into your browser's developer tools. I'll show you how to do that shortly. So some advice for branching out. So if you're going to work with these feature branches, keep your updates short, basically. Tidy up your branches and potentially workspace afterwards, because there's currently not an automated functionality to remove unused branches in Fabric. So I'm going to very quickly go through a couple of demos now. So first of all, I will show you the pipeline on how you can branch out to a new workspace. In fact, I will show you that we move the Teams busy thing. So first of all, I'll show you the Microsoft script to do this. I'm going to go in and find it very quickly in Fabric Essentials. If you're not using Fabric Essentials, it might be worth looking at. It provides basically lists of various Git repositories that can be useful for you to perform various tasks in Fabric CI/CD. And at the moment, as you can see, it's split between community and Microsoft repos. So I'm just going to go into the Microsoft repositories and scroll down to Fabric Toolbox. And if I open up the Fabric Toolbox and I go down, you will see that there is, get back to it. Might actually do to save myself some time here. Just type in branch. So you select CI/CD branch out in your workspace. If I click on there, that is the script that's available. And what I will quickly do, just made a quick choice there to put that in for all of you as a link as well. But this goes through the guide, as you can see, on putting some scripts in our Azure DevOps. You will have to put a post-deployment notebook somewhere as well, because what this does actually has some great extra functionality. It will automatically do rebindings for you, but it can also transfer data if you so wish. So what you can do, and I will show you this because it's quite good. You can have a post-activity notebook, which you will need to connect to do the deployments. And Microsoft provides the script to do this. And if I scroll down, you'll see that it's got options to import all the data as well as doing all the rebindings, etc. So it is worth looking into. Now, what you can do as well, as I mentioned just now, you can tweak it slightly and actually have it as a bearer token parameter as well. So instead of getting a bearer token, running a notebook to push a bearer token to an Azure key full secret, for example, if you don't have access to an Azure key full, you can use this method instead. Which means that when you go to run this particular pipeline, and it comes up, what I'll do actually, it's a quick trick for you all, by the way. If you want to run a pipeline in Azure DevOps, a YAML pipeline, and you want the parameters to be very similar to before, go into the last successful run and click on Run New. And that will bring up all the parameters that were used previously, and you can just overwrite as you see fit. So as you can see, all the parameters that you will require to enter are here, and I added a new one for the Fabric token for authentication. And these tokens, by the way, only last for typically 60 minutes. Right, so continuous integration, I will show you a very quick demo of this. So I've got this Power BI report locally. I'm just going to change the page name here. You don't need to squint to see it. Just be aware that this Power BI report is saved as a Power BI desktop project. So it's basically saved as metadata. Now, when you save a Power BI desktop project, you will get a couple of things installed. So you will get two subfolders, one to represent the report itself and one to represent the semantic model, like you can see at the top here for that AdventureWorks report. And you will get a PBOP file as well. And if I click on that, you can see it's just literally metadata relating to the fact that it's a Power BI desktop project. So I've just made that change. And because this folder, which contains the Power BI desktop project, I've already initialized what's known as a Git repository, I can stage my change. You don't have to always do this in Visual Studio Code, by the way, it can stage automatically. You can write your commit message. If you're lucky enough to use GitHub Copilot and VS Code, you can get it to generate a message. I would not use this all the time though if you're using the GitHub Copilot free license, because it will count towards your credit. So I'm just going to commit the change, and because I've got a remote set of Azure DevOps, I can synchronize my change. Now we head back over to Azure DevOps. I open up the repository. You can see it just now I made a change. What I'm just going to very quickly do so if you update a change in Azure DevOps in the branch for the Git repository, branch for your connected to your workspace, you will have to go into your workspace and update. You can update this with an API as well if you want it to be done automatically. Microsoft provides sample PowerShell scripts for this. So anyway, it's done for my feature workspace. Say I want my development workspace to be updated. I then have to raise what's called a pull request. And a pull request is basically me asking permission to merge updates from one branch to another. When I start this pull request, you'll see it's starting a pipeline in Azure DevOps, and that's because on my dev branch, I have what's known as a branch policy in place. And here I've got build validation, and I'm saying that every time somebody wants to do a pull request, run a particular pipeline in Azure DevOps. As you can see, the pipeline is running at the moment, and what it's essentially doing, if I click on edit, it's doing my continuous integration tests on the Power BI reports in that particular folder. So once the pull request, the pipeline is finished, I'll be able to go into my pull request and then do the approve. And I'm going to set it to autocomplete so it does it behind the scenes already for the benefit of time here. So that is one way you can do continuous integration tests with branch policies. Now, a quick cover the release options. There's 4 by Microsoft. And I'll elaborate on all of those quickly now. So first, some Azure Pipelines terminology. Pipelines are configurable process to run tasks. Variables are predefined variables that you can enter either in or out of the pipeline. My personal advice, put them out of the pipeline. Do not expose variables. Parameters, which are values entered when the workflow is started. And an agent does all the work for the pipeline. So basically, Azure DevOps, when you start a pipeline, Azure DevOps doesn't magically do the work itself. It sends the instructions over to what they call agents. And these agents you can think of as virtual machines. They can be either self-hosted agents that you host yourself or ones hosted by Microsoft. So let's go. Release option 1, Git-based deployments. This is where you connect multiple workspaces to the same Git repository, but have them all connected to different branches. So have, for example, one workspace connected to your dev branch, another workspace connected to your test branch. And then every time that you are happy with your updates you've done in dev, merge it over the test. Much like what I already covered by going from feature to dev branch. Here's a diagram to help you all visualize how it looks. So essentially, do your change, do your merge for a pull request, and then update your next workspace on in the chain, whether that's test, production, etc. Next option is Git-based deployments using a build pipeline. This is where you deploy the different workspaces using Azure pipelines instead of having each workspace connected to a branch. You just have one connected to a repository, and you have that as your source of truth, and then use Azure pipelines to deploy from that source of truth to other workspaces. So here's a diagram to help you visualize how that looks. So basically, you would do your typical development process up into your feature branch. So you merge what's going to be effectively your golden source of truth, which is typically going to be connected to your development workspace. And then instead of doing another pull request, for example, to a test branch, what you actually do is start an Azure pipeline, and that will deploy typically with API calls directly the items, create those items directly in the workspace of your choice. I have some Azure pipeline recommendations, which are mostly for this particular option, since it is the most popular one. Since someone asked me earlier, as I said, consider YAML pipelines. Apply sensitive values, store them either in Azure DevOps variable groups or in Azure Key Vault. Implement an approvals process for production workloads. Now, if you are working with Azure pipelines, these do not necessarily have to be manual approvals, even though that's usually required, at least at the start of projects, to build confidence. There are other types of approvals processes that can be done as well. And I suggest looking at tooling as a layer of abstraction. For example, with our PowerShell modules, the ever-increasing popular Fabric CI/CD Python library, and the Fabric command line interface. I'll show you something interesting about a couple of those shortly. Third option is using Fabric deployment pipelines. This is where you perform all your pull requests, basically your typical development process first, to a workspace that represents your development environment, which is actually going to be your development stage in a Fabric deployment pipeline. From there, you can orchestrate directly within Microsoft Fabric the deployments to the different stages, or alternatively orchestrate with Azure DevOps. Now, here's a diagram to show you how it looks if you orchestrate with Microsoft Fabric deployment pipelines natively in Fabric. Here's a diagram to help you visualize how it looks if you decide to orchestrate with Azure pipelines instead. One advantage of doing this is that currently there's not an approvals process in deployment pipelines, so you can add an approvals process in Azure pipelines instead. Another advantage is that you can perform what's known as data ops. So, for example, like you can see here, use Azure pipelines to orchestrate the deployments to your different Fabric deployment pipeline stages, and then call a notebook to be run to actually populate a Lakehouse with data. Something you may want to consider, especially if you've inherited somebody else's Fabric deployment pipelines. Now, there is a recommendation for deploying the multiple customers, solutions, tenants. Basically, if you want to deploy to a workspace that's in another tenant. This method is very, very similar to option 2. However, at this time, you do your test and dev and test stages in your own Fabric tenant, and then deploy to the production workspaces in the other tenants using Azure pipelines. This can easily be achieved by adding additional parameters to the same pipeline you use in option 2. And to be honest with you, most of the time it would be the same parameters anyway, because depending on how you're authenticating, so if you're already authenticating by manually entering, well, not manually, but with a service principal connection, with a client ID and an app secret, you would add the parameters and then put in the ones for the other target tenant instead. By the way, if you are looking to do deployments in your own tenants and you're working with Service Connection and you're currently using service principals with the app ID and secret to do the deployments, you may want to consider long-term actually creating a service connection with workload identity federation installed instead. That will save you having to recycle your, or renew, I should say, your service principal secrets values. So here's a diagram just to show you how this particular option looks. So as you can see, do all the development and test work in your own Fabric tenant, and then deploy to the workspaces elsewhere. Now it's time to do some demos. So what I will do, so I've already shown how to deploy with Git integration already, to be honest, because what I showed you earlier, from going to feature to development, you can also do from development to test. So I will quickly go past that one. I will show you Fabric deployment pipelines first. So we go into Microsoft Fabric, and I won't focus too much on deployment pipelines because they are heavily documented. I'll show you quickly here. So as you can see, this development workspace is the same one I showed you earlier, actually. So you can work with a feature branch and then merge your changes to the development branch, which is connected to this development workspace. And then use the nice UI provided in Microsoft Fabric to deploy to your various stages. Now, one thing I will show here is about the deployment rules, because you can customize those to your own choice. So here is how a deployment rule, for example, to change a data source can look. So as you can see here, I'm changing the source to be from a development SQL database to a test SQL database. Now, as you can see, you can orchestrate this directly in Microsoft Fabric. What you can also do, though, instead, is orchestrate it in a Azure DevOps pipeline. As you can see here, I click on Edit, and I can just run tests. So Microsoft does provide scripts to help you do this. You can tweak those scripts like I've done here if you want to. And as you can see, I've actually changed it so it actually gets the token first and then tests the token length. However, it's entirely up to you how you want to do this. Now, you can also deploy with Fabric CI/CD. And I will very quickly go over the Microsoft repositories again. So Fabric CI/CD is basically and I'll go to the page in question here instead of the repository. So if you go to the GitHub repository for Fabric CI/CD, it will read that you can go to the Fabric CI/CD GitHub page. And in fact, what I can do is put the GitHub link in the chat. So what essentially Fabric CI/CD allows you to do is a Python library which allows you to deploy the contents of a folder that's got the metadata for various Fabric items from one workspace to another. So I do have another question in the chat about guidance. Chopin, can you reach out to me after this session, please? Because I have 10 minutes left, so I will do that afterwards. So anyway, Fabric CI/CD, like I said, very quickly, it allows you to deploy items that have been configured with Git integration. So for example, just go straight to the repository. So see here in the Git repository, I've got a workspace subfolder that's full of metadata for different Fabric items. I can use Fabric CI/CD to deploy all of those items. There's guidance, there's various posts relating to how to do this online. I will show you how a release pipeline for this looks now. So let me go straight to here. So first you can install a version of Python. That needs to be done, otherwise you can end up with syntax errors. And authenticate by your method of choice. And then initially you could deploy by calling a Python script that has various settings in there, like you can see here. However, now you can also do what's known as configuration-based deployments, which essentially means instead of having very complex deployment Python scripts, so I go to the Fabric CI/CD here. So instead of having a parameter file which is complex, long and complex like this, it can be shorter. And you can move everything to a central configuration file for multiple deployments. You just specify the environment. And you can customize it as you see fit. I quite like this idea of using configuration-based deployments. And as I will show in a minute, you actually need to use this if you want to use what's known as the new fab deploy command. So that is how you can deploy with Fabric CI/CD in a nutshell. And like I said, if I use the Fabric CI/CD config file instead, I click on this particular task. The main key point to highlight is, as you can see, the task is a lot simpler now. I don't need to pass through as many arguments because it's all in that central configuration file. So it is worth looking into. Now, one other thing I will highlight, as I mentioned, there are a couple of Azure DevOps extensions installed. There is one to do Fabric deployments with Fabric CI/CD. I've got it configured here. It's called Deploy Fabric Items. So as you can see here, you do get nice help guidance as well for the individual items. So I'll give a description of the various settings, and there are a couple of different ways you can authenticate. So you can authenticate with a service connection as well. If you've got workload identity federation enabled, it will support that. So using this task, using this Azure DevOps extension, means you no longer have to create a Python script to orchestrate your Fabric CI/CD deployments. Now, the other thing I will quickly highlight about working with Fabric CI/CD, Fabric CLI, the Fabric Command Line Interface, which I put in the chat earlier, will allow you to use what's known as a fab deploy command now. And that fab deploy is actually a wrapper for Fabric CI/CD. So if you're using configuration-based deployments, like I mentioned just now, you can issue a fab deploy command and just put in the location of your configuration file, and it will do the deployment for you. And you're probably thinking that I'm making it sound simpler than it is. And I'm going to show you now. No smoke and mirrors. This YAML pipeline works. If I scroll down, I have put in additional logic to check workspaces there, but essentially my deployment is now orchestrated with this one command, and I specify the environment I want to deploy to. Now, as you can see, it does mean you need configuration-based deployment enabled. I've got a few questions in the chat, which I know I need to answer shortly. So I will just quickly I showed you already the Azure DevOps MCP server. The thing I left out towards the end is that actually I can use natural language to run pipelines as well. However, I do need to quickly finish this last section about doing the CI/CD for data warehouses and SQL DB and Fabric. So essentially, you can do deployments to SQL databases in Fabric, and Fabric data warehouse is the same as you have done with SQL Server related databases over the years with state-based deployments. So basically, you can have a database project, and like this particular one in question, which contains all of your metadata for a database, and then you can deploy that way. There's various reasons why you may need to do this. As you can see, it could just be you're not using using Git integration or any of the other features yet. It could be that you've got multiple data warehouses or SQL databases in the same workspace you want to perform CI/CD with. Or it could be that you want to keep the schema updates for those particular items isolated, which a lot of people are doing at the moment. Here is a diagram to show you how that looks, because there's two different ways to do it. You can either work with a database project or you can extract the schema. Question: ADO deployment of warehouses, does it copy over stored procedures views? Yes, if you're doing it with DATPack and through the other methods that some people are using at the moment, because it's just deploying the contents of that database project I just showed you in Visual Studio Code. And in fact, in a data warehouse now, you have a little button that says SQL database project. You click on there, it will download a copy of the SQL database project for you onto your machine in your location of choice. I'll skip the demo for this for now because I want to do quickly the summary and then answer the questions. To summarize, Azure DevOps caters for Fabric CI/CD requirements. For best coverage of items with CI/CD, use Microsoft Fabric Git integration. There's various release options for multiple needs. So if you, for example, want business citizens to do deployments natively in Fabric, you can do so with Fabric deployment pipelines. If you need more complex requirements, then you can look to use Azure pipelines. If you want a nice layer of abstraction on top, so you don't have to do hundreds of lines of API calls, use a layer of tooling such as Fabric CI/CD Python library, or the Fabric command line interface, or even PowerShell. And they're not mutually exclusive, so as I showed earlier, you can use a combination of them. Can modernize your CI/CD practices with AI. As you see, I'm using the Azure DevOps MCP server. And traditional SQL CI/CD is still an option. Now, I need to thank everybody, but whilst I'm doing that, in the last 60 odd seconds, I will quickly go through the questions. So, can we deploy all the items to different workspaces using CI/CD YAML pipelines? Answer is yes, you can. Do you always have to use Fabric deployment pipelines? No, as I showed in the session, there are other ways you can do this, including with the Fabric CI/CD Python library, or even the new fab deploy command, which acts as a wrapper for it. So in real projects, how do teams decide when to use Fabric deployment pipelines versus, to be honest with you, most of the time, it depends on who's going to be responsible for the CI/CD. If it's business citizens predominantly, then it may be that you want to use Fabric deployment pipelines if it's not complex requirements. If you need to do things like change a lot of the values between the different workspaces, in other words, with parameterization, then you're going to have to look to use something like Fabric CI/CD Python library. Now, I will just scroll back up because the second moderator is next speaker is already here. Definitely not going to take up their time because I know that's going to be a really great session. So, if there's no other questions, by the way, there was one other question. You selectively deploy, but you can use the parameterization I mentioned earlier. If you're using Fabric CI/CD, they have an items in scope per value, and you can define the individual Fabric items in there. So you don't have to define all of them. With configuration-based deployment, that now can be even higher level of filtering for you. So it's probably worth looking at the configuration-based deployments in Fabric CI/CD. And variable libraries do help massively, especially if you name your value sets and variable libraries to match your deployment environments, because then when you're deploying with Fabric CI/CD, the value sets in your variable libraries will actually dynamically go to the correct environment name, which is great. There was a question by Shabnan as well. Let me just go up to the other one. What did I miss as the next question? I deploy using GitHub Actions and Service Principal having a permission issue while accessing the direct lake report in the new QA workspace. I would look to do your rebindings. It depends on how you're doing the deployments. If you're doing it with Fabric CI/CD, you can do semantic model rebinding now, and that you can link that actually to a Fabric connection. So you can actually, if you're using Direct Lake, if you're using a Fabric connection, you can do your rebindings with a new rebinding parameter that's now available with the Fabric CI/CD Python library. I hope that answers your question. Anyway, that's me. That's all the questions. I'm sorry if the questions were fast answered. I really need to make sure the next speaker has time. It's going to be a fantastic session next for all of you as well. So with that being said, I'm going to put myself on mute, put my camera off. Thank you very much, everybody.
Thanks, Kevin. Thanks for such a wonderful session. And I know there are still pending questions. But yes, we have the last session coming in and Lakshmi is already in. Moderators, all to you. And thanks everyone who stayed for a day long. This is the last session in room 1 and we are going to end the day with that. And this will also be the end of the conference. Probably the other room will also wrap up in another half an hour or 1 hour. So all to moderators and Lakshmi for, I think, one of the amazing sessions going to be on Power BI visuals. I know Lakshmi has an expertise on that. I have seen some of his work and that's really amazing. So we have an opportunity to learn from her today.
Thank you, Amit.
Yes, we are actually excited to welcome Lakshmi. So she's a Microsoft MVP, data analyst, Power BI specialist, and she's also a certified Power BI analyst, currently working in the Institutional Effectiveness Department at Missouri University of Science and Technology. She's also passionate about creating and innovative Power BI reports that not only make data pop up, but also provides actionable insights. So today's session, Lakshmi is going to talk about breaking the limits of native Power BI visuals. She'll be showing us a live demo. And so, as you all know, uh, artificial intelligence is everywhere today, but many conversations around it are filled with buzzwords that make it feel confusing or complicated. So this session breaks down AI into simple, easy to understand ideas using real world examples and relatable analogies. So please join me in giving a warm welcome to Lakshmi. Welcome, Lakshmi. Over to you.
Everyone. Thank you so much to the moderator. Quick question. Can you see my screen?
Yes.
Perfect. Perfect. Okay, let's get started then. Give me 1 second. Perfect. Before I begin, I want to welcome all of you to the last session of Global Microsoft Analytics Community Conference 4. And I've personally been attending since yesterday, and the sessions were amazing. So kudos for that. Quick information about the contest the group is running. I think you'll find more information in the comments. Make sure you take part in these challenges. You can win these examination vouchers and Amazon gift vouchers as well. With that being said, I want to quickly start by giving a huge thank you to the organizers, moderators, and everyone behind the scenes making this scene happen, and especially over the weekend. Hi, everyone. So, this session is breaking the limit of native Power BI visuals. Before I tell you what this session is about, I want to know how many of you actually work with Power BI. So, all the Power BI developers in the house, I want you to comment and let me know. And I want to see how many of the Power BI developers are here. Comment in the chat. Any Power BI developers? Perfect. Great. You are going to have lots of fun then. Okay. So this session is about pushing native visuals beyond what they look like they can do. We're not going to use any custom visual, no complicated hacks, and no sacrificing performance. Also, it's going to be completely demo. Feel free to stop me wherever you want if you're stuck somewhere or if I was too fast. The slides are just here to make sure I don't forget what I want to say. Before we begin, quick introduction about me. My name is Lakshmi. I am the Power BI Data Viz World Championship finalist for 2025 as well as 2026. I love making dashboards less frustrating and more fun. I am also a Microsoft certified Power BI data analyst. If you have any questions about the PL 300 certification, feel free to reach out to me. I am also a Microsoft MVP in the data platform specialized in Power BI. I love Power BI. I play around with Power BI all day. So I post a lot of tips and tricks on LinkedIn, also post detailed blogs on Medium. You can scan the QR code if you want to get in touch with me or if you want to see some of my work. On a professional level, I'm a data analyst at Missouri University of Science and Technology. And on a personal level, I am a dog mom. So that's my dog, Casper. Love going on adventures. Both of us are foodies. And I'm a huge advocate of diversity and inclusion. With that being said, let's quickly talk about why the session, right? Like, I mean, we do already have Power BI native visuals. Why are we even talking about this? Let's talk about the native visuals reputation, right? What people think are they're very limited, they're very boring. You always need a custom visual if you think that there are no features available. And honestly, I used to think the same, right? But after experimenting a lot, I realized something very uncomfortable that Power BI was not limiting me, my imagination was, right? Now, after playing around with the formatting pane of every visual, I found out there are a couple of great features that are being underutilized. So, what actually happens with native visuals is the defaults are overused. So, once you put in your fields and you see a visual out there, you're like, okay, I'm good. So the default are not that good. That's problem with the native visuals. Next is the design intent is missing. You are creating a visual, but you don't have an intent behind it. So today we're going to get that intent mindset as well. And then, like I said, the features are always underutilized. There are so many features in the formatting pane that are hidden, and all of us are underutilize those. So before I move on to the next slide, I want you to keep this in mind that Power BI is not the limitation. Your approach to it is, right? And then, like I said, why the session is very simple. Most dashboards technically work. They load, numbers are correct, charts are existing. But what happens is users still ask the same question that the dashboard already has. Why? Because users are feeling overwhelmed. Sometimes what happens is the important KPIs or the important insights, they get hidden. So this session exists because what we're going to focus on is features instead of understanding. And then what we generally do is we just start building everything instead of designing stuff, right? So this is the reason why this session exists. And what our goal today is just from report building, we are going to shift to experience design, right? We're going to upgrade how we think. Can we mute the audience, please? Okay, let me go ahead and mute everyone.
Sure, I'll do that.
Perfect. Sorry for that, guys. Okay, let's get started. What the plan for today is first, we're going to reset our mindset. We will open Power BI and I'm going to show you small new techniques. We are going to start like from basics and then we'll go a little advanced. By the end of the session, I want you to think that you do not need new visuals or custom visuals. You can actually play around with the current visuals to get a lot of features out of it, right? Let's dive right in. Before I start with Power BI, I want to show you what we're going to do. First, we're going to play around with modifications of the bar chart. This is a very simple, plain looking bar chart that we always make. What we are going to do, like I said, we're going to start with basics. We're going to talk about how to make it more insightful. Like here, you see all the positives are green, negatives are red. Then you will see I took the same default visual and made it a little more appealing by using couple of features. I will tell you how. Then we're going to talk about how can I convert a simple bar chart with lots of elements in it to a lollipop chart to make it look effective, neat, and clean. And also, bonus, I will show you a couple of other versions of this lollipop chart too. Then we're going to talk about dumbbell charts. What are dumbbell charts? This is a simple bar chart. We're going to convert it into a dumbbell chart like this just by tweaking a couple of features. I will also talk about when you can use it and how this is far better than using the bar chart. Then we're going to talk about butterfly chart or a tornado chart. This is a simple bar chart that you see. We are going to create something like this. You see how it looks like a butterfly, right? Left and right. And another version, something like this. I will also, when I create these visuals, I will also talk about when are the scenarios you could use these. Then we're going to talk about progress bar charts. Like instead of just showing me the values of Monday, Tuesday, Wednesday, here you can clearly see the progress. Then I will show you another version of a progress bar chart. Then we're going to, at the end of the session, my favorite part is we're going to design this particular widget. And I will show you how you could do it immediately. And then I will also talk to you about why this particular design works, why this looks beautiful as well as inside. Meanwhile, I switch my screen. I want all of you to stay tuned. How do I do it? Just give me 1 second. I'm just getting my Power BI screen for now. Yes. Could anyone verify that you see my Power BI screen, please? Yes, perfect. Okay. So, great. Thank you, guys. Okay. So first, like I said, we're going to start with the very basic bar chart. You see, let's first look into the data set before I show you that I have not done anything in the backend. So this is my simple table. I have products, I have my current sales value, I have my previous year sales value. What I did, created a simple measure. What is my measure? Variance. Variance is basically current sales minus previous year sales. That's it. Those are the only things that are here. Converted that variance into percentage. Perfect. And then my requirement is to show percentages on a bar chart. what do we all of us do? We open a bar chart, we throw in the variance percentage, we throw in the product value. That's it. Okay. Now, quick things here. One, I am not really able to quickly point out what is good, what is bad, unless I look into these data labels or I see what are the bars which are in the negative direction. Two, you see how every bar looks like it's floating. There is no reference point to it. I mean, I do see percentages on the top, but I don't have any reference point. So what I'm going to do is quickly replicate this. We're going to play around this visual. First, just for the design purpose, let me switch off the data labels to make it clear and clean. Like I said, the first thing that I'm going to talk about is whenever you create visuals, have a baseline to it. Now, you don't get that by default in Power BI. But do you know, like when we play around with visuals, right? Let me just quickly open Paint. Like when we draw visuals on a sheet of paper, what do we generally do? We always start our bar charts like this, right? I mean, we are like y-axis, you have an x-axis, and then you plot a chart, right? So this is how you should approach your designing in Power BI as well. So what I said is first, I need a baseline for my visual. Now, if you look into the format pane, the baseline can be set by using a reference line, right? So here you have this reference line in the bar chart. You also have it in the column chart. So this is the column chart. Switch on your reference line and then add line. You see how Power BI automatically gives you inbuilt lines, like you want a minimum line, you can have a maximum line, an average line, median line, or percentile line. But now what we're going to do is a reference line. So go ahead and click y-axis constant line. Once you do that, you set the value to 0 because obviously you want 0% to be a baseline. Do you see this blue dotted line? Now that is going to be your reference line, your baseline. What I'm going to do is just converting into like a grayish shade or maybe a darker shade of gray. And then, okay, sorry. And then just changing the style to solid to show me that I have a baseline ready. You can play around with the width, I mean, formatting settings accordingly. Do you already see a difference between the previous and the current version? Now my bars are not floating anymore. They have a baseline. Perfect. We're good with this. Next, I want the user to look at my visual and quickly find some insights, right? So what I'm going to do is color code them. How do you do it? Is by creating a simple measure. Quick tip right here, wherever you're presenting or trying to show your measure to everyone, do not just open this little measure bar and show them. You can actually zoom in and zoom out your measure bars. I just do it by clicking control and then use your scroll button on the mouse to increase or decrease the size. I use it all the time when I'm presenting. Right. So now what I've done is written a simple, very simple DAX measure called variance color using an if statement. If my percentage is more than 0, give me a green, else give me a red. As simple as that. Now, I always prefer using DAX instead of playing around with the colors here or by adding rules. So keep the DAX ready. Then go to your columns, click on effects, your conditional formatting, and then field value, find that particular field, hit OK. Now, do you see how it has immediately become more insightful? I know that my focus areas are B and F right here. Now, these, to be honest, at a beginner level, this is perfect. But once you go to a professional level, when you throw this particular visual with a couple of other visuals, this particular visual is going to take all the attention. In order to avoid that, what we're trying to do is minimize the size of the width of the bars. Now, Power BI does not have any feature where you can go ahead and decrease or increase the size of your bars or your columns. But what there's a way around it. What we do is instead of changing the width of the bar, we increase the space between the two bars to give some spacing. The way you do that is you go on to columns, go to the layout because we're talking about column layouts, right? And then you have something called space between categories. If you play around this value, you will see that you will be able to increase or decrease the size of your bars. So that's a quick tip right here. Next time, when you're creating bar charts, it has more than 5 to 6 values. Oh my God. When you have more than 5 to 6 values, make sure you go ahead and play with space between categories. You see how this looks much cleaner. Let me quickly switch it to a bar chart from a column chart to show you now how it is very easy for me to, okay, let's switch on my data labels as well. Yeah. Now you see how instead of using this chart, just by adding colors, adding a baseline, you see how it became more insightful, right? One more quick tip right here. If you're trying to look for a particular feature, like you have in your brain that I'm looking for spacing between my bars, you don't have to go and look into each of the settings here. Use the search bar in the format option, say how I wrote spacing, I have bars, and then it shows up perfectly. So this is one quick tip right here. How you can improve the visual aspect of a bar chart. And as I told you, it was a very, very simple because I wanted to start slow. Any questions so far in the bar chart? Okay, no questions. Perfect. Next, we're going to move to a lollipop chart. First question, why do we need a lollipop chart? Now, say I have a visual like this. I have my total price by item type. So all these are my item types. All of them are my price. Now, see this. Don't you think this looks a little cluttered? I mean, it's like all the bars are like sticking together. There are a lot of values on the side. Now, imagine if there are going to be more item types to be added. This bar chart is going to look huge. In order to increase the white space between the item type, to make it more beautiful, there is something called a lollipop chart. Now, I'm sure all of us know what a lollipop chart is, what a lollipop is, right? So, what a lollipop is, all of us have had it. You have a candy on the top, and then you're going to have a stick in the bottom. So, this is how a lollipop looks like, right? That is what we're going to replicate here. Let me just copy paste this right here. First, like I said, I need a stick as a base for my candy. How do I increase or play around with the width? Like I said, there is no inbuilt feature, but what we're going to do is increase the space between the columns. So go ahead and I'm just putting into maximum. Now I have a base ready. Now I want to add the candy on the top, right? How do you do that? Always remember that if you want to play around with the bars or columns in your chart, you can use something called error bars. Click on error bars and enable it first. Then you have upper bound and lower bound. In the upper bound is obviously going to be on the top, lower bound is obviously going to be in the bottom. We are going to focus only on the upper bound for the sake of the lollipop chart. What is the value that you need to choose for the upper bar is the value that you chose for the y-axis, right? Because the candy has to be on the top, it has to be matching to my x-axis, sorry. So now here it is my total price. So I'm going to drag and drop my total price in the upper bar. Do you see once I do that, do you see that there is this black marker that popped up? Now we're going to play around with that marker. Now remember I said I want candy, a circle on the top. Go to the marker shape, throw this particular circle on the top, maybe increase the size to look more like a candy. You have something like a lollipop. Now we're going to play around with the colors. Like I don't want this black candy on the top, so I'm just going to go ahead and change it to a dark shade of purple and probably reduce the bit size. That's it. You see how now, and obviously you can play around with the size of the markers. You see how it has become more clean compared to the previous version, right? And now say if I have more item types being added to, I can play around with the sizing and it was still going to look neat. Now, quick, I would say like bonus tips right here is you can change the marker style to get different type of charts, right? Like for example, instead of a circle, if I go ahead and choose a diamond, let me change my color to match the series value. You see how now I am able to get these let's also play. Let me increase the space. Do you see how now I can also get like a arrow shaped visual. You see how it's like there's an arrow pointing to my data label, right? How did I get this? Just by changing the marker size. If you want, like, you can add triangles like this, you could add like crosses. There are a lot of things that you could do. For now, I'm going to drop it as diamond. So this is the lollipop chart. Any questions so far? Hope you guys are having fun and enjoying. Okay, 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 okay. Perfect. Next, we're going to talk about dumbbell chart. Uh, Let me create a new page so that I don't lose it. Okay. First, what is a dumbbell chart? This is what a dumbbell chart looks like. So all the folks going to gyms or took a gym membership and never went to a gym like me, we know what dumbbells are, right? Like it has two weights and then there's a bar. There's a stick in between. So here I have my two weights and then I have my stick in between. When to use dumbbell charts? Very simple. When you have two categories that you're trying to compare, what are the different scenarios you could use? Like the scenario here, gender, I'm trying to compare male and female, or say you are trying to compare current sales with previous sales, or you're trying to compare apples and mangoes, like two completely different things in the same category. That's when a dumbbell chart is used. Now, why should I use a dumbbell chart? I can just use a bar chart. It's telling me the same thing. The bar chart, say it tells you is male more or is male more or female more for each of this category, right? But dumbbell chart, apart from knowing just which is more, you will also be able to see the distance between the points. The distance in between the points tells you the difference. Now, here in D and E, do you clearly see that males are dominating for D and in E, females are dominating? But do you see the difference in the height of the lines? In the E category, you see the line is bigger. That means the difference is more. So that is one additional information you get from a dumbbell chart. Now, simple. How do we do it? Like usual, create a bar chart. Let's copy paste it. First step to create a dumbbell chart is to convert it into a line chart. Once you do it, you have something like this. Obviously, not at all useful, right? Next, what I'm going to do is add error bars. Now, remember, I told you in the previous lollipop chart that we are going to use error bars to create a candy on the top. In dumbbell, I'm going to use error bars to create my weight of my dumbbell, right? Going to my error bars, first enabling it. In the lollipop chart, we only use the upper bound because we just wanted the candy. But in the dumbbell chart, we need the weight on both the sides, right? So I am going to use upper bound and lower bound. You can actually use anything, like you can interchange female and male, male or female doesn't matter. But the use of this is you see how once I added my value of the male sales and the female sales, you see how now I have like these let me zoom it a little bit. We have these lines, these black lines between the 2 points. That's what we want because the weights have to be connected by a bar. Next, what I'm going to do is I do not want these line chart. It's really annoying. Go to lines and just make it transparent. That's it. Just by increasing the transparency, I got rid of it. Another way you could do is just switch off show for all series. That works too. So what I did right now is converted to a line chart, added my error bars, switched off my line chart. Now I have a basic structure. I want to add weights on the top. I already have these weights that look like lines, but I don't want lines. I need circles. Go to your Barker shape, add circles. What do I have right now? I have my weight right here. But I do not really know what is male or female. So I need to color code it. Remember how I told you that these are the markers, right? How do you color code it? Is you go to markers, switch show for all series. That's it. What happens is the light chart colors will be taken over by these markers. Remember how when I had a line chart, I had blues and pinks. Now you will get blues and pink. As simple as that. Do you see how now from being too colorful, too cluttered, we get a very simple, basic looking dumbbell chart. Lot of spacing, lot of white space, easy on the eyes. quick understanding. If I ask you what are the categories where females dominated, very easy. You just look at the top of the dumbbell charts and see the pinks. So it's I, G, E, C, and A. As simple as that. If I ask you in on which category the distribution of the male and female, the difference between the male and female was more, what do you have to do? You don't even need data labels for it, right? You can just look at the distance between these two dumbbells, distance between the two weights, and find out. Like it's obviously I over here. Any questions so far? No, I more. Yes, Aishwarya, you're right. Perfect. So, any questions so far? Did you like? Do you like what you see? What has been your favorite chart? The lollipop chart, the dumbbell chart? Let me know in the comments as well. Perfect. Now let's take it a little bit higher. We're going to talk about butterfly charts. Let me just show you what we're going to do. Now, what are butterfly charts? These are also called tornado charts. I like using butterfly because I like butterflies. I will come to your question at the end, Rashmita. Perfect. And then, okay. So, why butterfly or tornado charts? Now, in this particular stack bar chart, you see stack column chart. I keep getting confused between columns and bar charts. Anyway, so bar chart, the problem here is I am able to see female and male categories perfectly. I see the data labels, I can find out the difference. But do you see how it is a little cluttered? In the sense, one, the white spacing is a little less. But if I have to answer questions like in which category the females was more, I'm not comparing male or female. I just want to compare between all the females. It's going to take a little time for me to look at all the data labels, right? So what I'm going to do, I will go to pink, I will look at the data label, data label, data label, and then I'll be like, okay, I has the maximum females. But in these two particular visuals, you see how it's very easy to compare male and female, as well as compare between the males and between the females. That is one reason why I like using butterfly or tornado charts. But just to reiterate it, tornado charts and butterfly charts are really good when you want to compare between the categories and you want to compare within the category. Quick example, this particular visual. I can compare in B, male is more than female. In E, female is more like again, like the variations can be seen. Let me just switch off the data labels for clarity. Increase the value. Perfect. And then now if someone asks me in which category male females, like females are more, just compare on this particular side and you will see that this particular I is more, right? So this is why we are going to use a tornado chart. Now let's begin creating it. What I'm going to do is create a very simple bar chart. What I did right here is I have my products A, B, C, D, E, F, G, H, I, and then I have the the sales made by the males. So here you have my total males, the sales, sum of the sales. That's it, right? So now I have my male value. What do I need now is female. So I'm going to copy paste this just like this. Instead of male, I am going to replace it with female. Clearly see the values. Let me just change the colors so that we don't get confused. The color has to be pink. Perfect. So what do I have now is my male values and then I have my female values. One quick thing, you need to have two different measures. Like you see here, I have my total female sales and total male sales. Two visuals right here. Now what I have to do is wrap it so that it looks like a butterfly. Simple thing is one, you go to your x axis and then you have something called invert range. Like I said, I need to invert it. So go ahead and convert invert. When I select invert, what do you see? From the x axis has been inverted. So now I have something like this. Let's just throw it right here. I have this and I have this. Now, do you see A, B, C, D, E, F, G, H, I being repeated on both the sides, right? What I'm going to do is switch off my y-axis from one side and then adjust my size accordingly. That was as simple as that. Perfect. I have my males and I have my females. Let's talk about the drawbacks. One, I cannot add legends on the top. Like here, I have male and female. I cannot do that because these are two different charts. That's one drawback. Second drawback, the sorting order of one visual changes. For example, instead of A to I do it like I to A. The other sorting order will not change because I have not, this is two separate visuals, right? So you should be very careful when you use this particular trick. If you use this trick, sorting order should not change because they are two different visuals. Second, you cannot have inbuilt legends. Now, obviously, if I have to do something like this, what I do is I just add an image. Like I create something like this, go ahead and take a screenshot of the legend that I already have. Like, for example, like here, I just do this. I save this particular legend, import it as an image. If I really have to use this technique, looks very clean and clear. But let's do something else. I want legends. I want it to change to according to the sorting order. For example, here you see how I could like even if I change the orders, everything changes, right? How do I create this? Let's start from this itself just to save time. Let me use this. What did I do? One second. Product. Let me sort it accordingly. So what do I have here? Again, starting with the base thing, let me switch off the reference line. Okay, this is what we started with in the previous. I'm going to do the same thing here. I have my products, I have my mail sales. What I want to do is first, I do not like floating bars, adding a reference line to it. How do I add a reference line? Just go to reference line, choose your constant y, add it to 0, just changing my colors quickly to look like a reference line. Let's make it black for now so that it's clear in the demo. Perfect. Now I have a reference line. Okay. Now I want to add females on the other side of my reference line. You see how my reference line is at 0. If I have to go to the other side, I want negative values. What I do is simply create a tax measure, take my sales from the total female sales, multiply it by -1. So what I'm doing in this step is negating my female values. If I do that, what happens? Let me quickly show you. And I'm going to obviously drag and drop those. What happens is fix my value from this sales, female sales, and immediately negates it so that it comes across my baseline. Perfect. Let's rename this as female. Now, quick thing. I need to change the colors. Obviously, I want things in order to be it very clear that it's female. How do you do that? Like I said, I personally do not open every particular setting to find what I want. I just use the format option right here. But for now, I know that I want to change the color of the bar. I go to the bar and then I go to my female and then change it to pink. That was as simple as that. Let's talk about the advantages. One, I have my legends on the top, so I don't need to import any image. Two, no matter what I change, my sort order to, everything changes accordingly because it's a single visual. Isn't it awesome? Let's talk about the drawback. Let's see what happens when I switch on my data label. When I switch on my data label, do you see how? Let me show you here. Yeah. Do you see how males are perfect? I have everything in positive, but females are being showing in negative. That can be misleading, right? Because the sales is positive for everything. That's what we see here. But in this chart, it is misleading. So be very careful that when you do something like this, like whenever you want to negate something to show on the other side, either switch off your data labels or what another suggestion for you is swap the values of the data labels. How you could do that, a new Power BI feature. When you open data labels, you have something like this, right? You will have all selected by default. But what I want to change the female value, go to female. What am I changing? The value, click on value. And then simply replace it by total female. Instead of the negative value, you will automatically get everything in positive. Although I'm using the negative values to create the chart, I can display positive values out there. So, any questions so far? I hope you are enjoying this session. Butterfly chart, if I had to choose between this particular version and this particular version, this is my favorite version. You can add title to it accordingly to make it look pretty. And let me also add like a visual bar. Perfect, right? You see how it's very easy for me to compare, like, okay, D has male domination, I has female domination. Among all the males, D is leading. Among all the females, I is leading. So this is the advantage of using your butterfly charts. If you can think of any other ideas, drop in the chat. I would like to learn from you too. So that's about the butterfly chart. Moving on, we're going to talk about progress bar chart. First, I'm going to show you the data set just to show you like I'm not doing anything crazy. It's a very simple data set. It's called tracker. I have students, name of students. I have 5 students. I have my dates. I have my days, and I have the marks in the subject history. What I did is threw in slicer with all my student names: Arjun, Karan, Meera, Priya, and Rohan. And then I have a simple bar chart already formatted it for you. I have a title. I have all my Monday, Tuesday, Wednesday, Thursday, Fridays, and I have all my values, all the marks of history subject. Quick tip right here. You see how I have this particular icon in the title. I want to show you a quick trick how you could do that. Let me first get rid of this. For example, my title is ABC. Okay. If you want to add emojis or emoticons inside your titles, inside your subtitles, or anywhere in a Microsoft product, how could you do it? Earlier, how I used to do it, I'll go to Google, I'll find an emoji, copy, come and paste it right here. You don't have to do it. Every Windows person has inbuilt emoji pane in all the Microsoft products. In order to enable it, you need to click the Windows icon on your keyboard and then you need to press a full stop. Windows icon plus full stop. If you want to try it, you can try it in the chat. I would be more than happy to see if it works for you. So, Windows icon and full stop will open this particular emoji pane where you can find emojis. For example, like here, I'm going to talk about targets, right? So, I just type in target, I get a target. Or say you're looking for hearts, you have lots of colorful hearts right here. And you can add as many emojis as you want, but I suggest not to add too many. One is perfect, right? Oh, yeah, I see people using emojis in the chat. It's so cool, right? You know, it works pretty much everywhere. So it works in Teams, it works in Excel, PowerPoint. So now when I create my presentations, I keep using it all the time. So Windows and period is the icon for it, right? So that's a quick tip for you all there. Now, what happens when I change the name of my students? So when I click Arjun, so this is his mark. Let me add data labels so that it looks cleaner. Never mind. Karan, Meera, Priya, Rohan. So these are the values. And if I don't select anything, I get the sum. Now this is pretty good. I am able to see that Arjun did very good in the month in the days of Monday and Friday. Now Priya needs to improve in on Thursdays and so on. Very easy to find and track what's happening. But when I have marks, it's always like 9 out of 10 or 10 out of 10, right? You always have like a end point or say the maximum value, the total marks. Here, don't you think it will be great if I have something that I can compare the current values with, right? Like if I want to say I scored 8 out of 10 and Rashmita scored 5 out of 10 or 10 out of 10. So it's always out of something. When you want to show something like that, we use something called progress bar. How do we create progress bars? Is very simple. First, let me just, okay, let's play around with this particular visual itself. Very simple bar chart. What I have on the bar chart, my weekdays, and I have my scores of the history month. Now, I am going to add another bar, which will give me my total value. So say the total marks was 1,000 or whatever it is. So from now, instead of 100, I just 1,000 because all my values here are above 100, right? So I have a measure which is defaulted to 100,000. And then I'm just going to add it. You are not able to see it because of the color. So once I add it, let me go and change the color for you. How do you change the color of a particular bar? Is you go to bars, select the bar that you added, and then change the color to whatever you want. Right? As simple as that. I could also create a Monday, Tuesday, Wednesday, and then I'm going to add my history mark. This is how it is going to look. I'm going to add the new mark. This is what it's going to look. Let's probably do everything from scratch to make it easier for you. What I'm going to do, simple, take a bar chart, add all the weekdays on the y-axis, adding the marks of my history on x-axis, and adding the 1,000 out of 1,000. Now, quick things to note. Saturdays and Sundays, I do not want to see because first of all, students do not have any marks, right? So I'm going to just go ahead and hide those so that it's much cleaner. Now, when you use this particular clustered bar chart, you get something like this. Now, I want to merge those or basically overlap those. How do I do? Is you go to bars and open all, open layout. You have something called overlap. Click on overlap. Now, once you click on overlap, nothing is going to happen because the space between the series is 0. What happens when you increase the space between the series? So I am increasing the space by 1,000. You see how now it has overlapped? So something to keep in mind, if you want to see the overlap, you need to play around with this particular feature. Now what happened is oh my God, my sum of history got hidden behind the maximum value. So I'm going to flip the overlap to bring it in the front. Pretty easy. Now, remember in the first slide, I told you I don't like big bars. I want small bars. How do I do it? Is increase the space between the bars. Very simple. Increasing the space between the categories to see something like this. Now, I don't like these colors. I want neutral colors. So what I'm going to do is the maximum value, I'm going to give it like gray so that I know like out of this much, I'm scoring this much. And then my score, you can change to whatever you want. Purple is my favorite color, so I'm going with purple. We do not need legends for it, switching it off. We do not need any titles for it. So switching off all my titles as well, you get something like this. Now, one extra thing that I've done is, like I said, I don't like my bars floating. So what I do is I add a reference line. Go to reference line, add a line, then you have to choose X constant, make sure it is at 0, change the color according to your needs. I probably go with gray and then I use a solid. So you see how now, let's ignore the title for now. You see now how I have something that I can compare to, like if you want to switch on the data labels, you see how I can say like I have 620 out of 1,000, 660 out of 1,000, 580 out of 1,000. And this is very beautiful. It beautifully works with these as well. For now, I'm not using it because I want to show the total scores of all the students. Quick things here. If you do not want to see one data label, like I want to see only the data label of my current marks, you could switch that off. How do you do that? Is you go to data labels, in apply settings to go to maximum value, whatever you created, and switch it on. As simple as that. And then let's change the color of the 620s to probably black to make it look clearer. So you see how now it's very easy for me to say that, okay, when I'm tracking the progress, Friday has the maximum progress, Wednesday has my lowest progress, and I need to work on Wednesday. So this is how you could create progress bars. Now I'm going to show you a couple of variations in these progress bars that I've been using recently. It looks a little beautiful too. The reason I'm showing you these variations is imagine you have a dashboard. You have lots of bar charts in it. It's not looking to good look because everywhere no one wants to see bar charts. Like people like to see new things and different things that makes things easier for them. What you can do right here is add your error bars. So remember, in the dumbbell chart we added a candy. On the in the lollipop chart we added a candy. In the dumbbell chart we added the weights. Here also you can add those icons. How you could do that is again go to error bars. The first thing is you need to enable it. Once you enable it, you can change the marker shape. So now, like I've chosen circle. You see how my circles have come up, but it's not really clear. I want to get rid of this particular blue. So go back to bars and probably just make it transparent to get something like this. You see how now, let's probably play around with the students. You see how now I can track progress like this? Isn't it like clearer and cleaner? In order to make it more visually appealing, let's change the score to 200, the maximum value to 200. You see how now I have something like this? Looks easy on the eyes, looks pretty too. If you want to make this more insightful, what you could do is something like this. Increase the space between the categories to maximum, and then increase the size of the bars to look something like this. Play around with the marker shape. I like actually doing this. I like dime bar. So this is about the progress bars. Let me know which one did you like. Did you like the initial version where I showed like a proper bars, or did you like the ones with the markers? Now, like I said, it depends on your end users as well, right? I mean, if they do not want to see something like this, do not show them. But it's really good. Instead of having bar charts in I mean, if you have four bar charts in a particular visual or in a particular dashboard, it's always better to show one week of it. So this is about the progress bars. I'm going to get into the questions after. Nisha says the marker is more clearer. That's true. That's true. Like it's pretty clear to see, right? Which is towards the end is we can say that that progress has been good. If it's away from the end, we say that it needs more progress. So that's how this works. Great. Next, we're going to talk about my favorite, which is widgets. What are widgets? Is small groups of visuals that make work easier. You do not need to have 5 to 6 visuals to show a simple thing. Now, let me create a duplicate page for this so that I don't lose it. Let's look into what we're going to create, right? We have something like this. It's a combination of slicers, the student slicers that I had, and then this is just one particular visual. But let's see what are the specialities of this visual. One, top, I have a title, beautiful with an emoji. So captures my attention. Number two, I have a subtitle in here which directly gives me the insight before even going into my visual. This is something that I really like to do. I do not want to go into the visual and try to figure things out. More easy if I could get the insight before I go into the visual, right? And this is dynamic as well. So you see, when I change the employee to current, I see that 3 out of 5 goals have been achieved. When I do Priya, it's again 3, Rohan is 2, Meera is 4. So I'm getting the insight before even going into the visual. The next thing that I really like is I have my visual. I have my days on the side. I have my performance here. And do you see how I have a target value? So I know that this is my target 115. These are the days where it is above target. This is the day which is below target. Easy context, easy reference to find out whether it's a good thing or a bad thing. Now, I could have easily found out that Wednesday is not doing good, it's below target. But do you see how I have icons on the other side that also tell that to me? Like I have emojis here, like I have the tick and cross signs, which easily tell me that, oh, I need to focus here, right? And if you see that those are dynamic too, it keeps changing accordingly. Now, if you go to Priya, you see how the targets have not been met on Mondays and Thursdays, right? So it's very easy for me to understand where I need to focus on. Two, you see how I have data labels also? Instead of making the user guess or instead of making the user go ahead and hover over the bars, it's very easy for you to find out what the values are. So these are the reasons why I think this particular combination or this particular widget works for me. The reason I'm talking about this is remember I told you that it's very important to change the intent of designing a visual, not just building a random visual. It's not like you're dragging and dropping stuff and then you have some insight to show. Sometimes designing these little design tips of how you can add icons, how you have a target line, instead of writing target is 115, I have the target incorporated inside my video. Now, how do we do it? Let's focus on that. Let's go to the duplicate page. Okay. First thing now, I'm not going to talk about how to make a slicer. I'm sure everyone knows how to make a slicer. We'll talk about that at the end. Let's focus on this particular visual. Right. First thing, quick tip right here. Say you created a visual, you do not like it, or there is some error, you want to go back to the default value. How you could do it? You don't have to delete everything and start from scratch. You have a visual, you have these three dots, click on three dots and select reset all settings to default. What it does is it'll reset to default. This is how I started it, right? Now, this is how you could get started. Just showing it to you. First thing, like I told you, subtitle is enabled. I have my title right there. Let's talk about 4 out of 5 goals. That is my subtitle. So you see how if I, that's a subtitle. Subtitle is a dynamic value. A very simple DAX has been used. Explaining the DAX. Always use variables in DAX, makes things really easy. I have my total days, which is 5. What is my achieved days? Is calculating achieved target is just finding out if it is more than my target or not. And then I'm using a format value to format out the, as simple as that. Very, very easy DAX. I'm not going to talk about the DAX more because I'm running out of time. Now, once I have that, I'm going to subtitle, I'm going to throw it in there. Now, one thing people do not do is people keep visuals like this. What I tend to do is use the divider option as well. Once you add the divider option, you see how it gives you a cleaner look. And then you see how my background of my title is also in a different color. Usually it would be that it stands out, right? So what I did here, added a title, added a subtitle, added a divider. Perfect. Now in this particular visual, everyone knows how to do this. How do we do this is create a simple visual. This is my reference line. If you remember from the previous concepts, I use reference as 0, but here I'm going to use reference line as my target. This is very simple, right? Any questions about this particular visual, let me know. Now, this is great. Remember what I want to do right now is add those icons before this baseline. If you remember, I told you we need to create a particular negative value if I want to go again on the other side. So what I did is I created a negative bar, which is -20. And I'm going to throw it right there. So now I have my negative bar -20. So what I'm doing right now is creating space for my icons to be added. Simple. Once I have this, remember I told you, you do not want to see negative values. I'm going to replace the negative values by the icons. So I will show you my icons. Very simple icon. If my history is more than my target daily, give me a tick, else give me a cross. Maybe let's do something else. Let's do like a green heart and then just for the fun, red heart. Okay. I have my icon DAX ready. So what I'm going to do right now is instead of this -20, I'm going to replace it by my icon. How do you do it? If you remember, go to value and just drag and drop this stuff. You see how I have my icons right there? You can increase the size of the icons if you want, just by increasing the font size. Now, I do not want that blue background. Go to the bars, go to the negative bar and just increase the transparency. You will get something like this. Isn't it great? So what was the trick right here is first, you need to get on the other side of the bar. How do you do it? Just have a negative value. Like here I have -20. You can have whatever you want according to the spacing. After you do that, you need to replace the values by the icons. Just have a simple DAX which chooses your icon. And then get rid of the transparency of the bar. You can get something like this. Now, the fun part about this is you can, instead of just like having the icons, you can even have text. Like say, I'm just writing good or bad for now. And then You see that you can even have text. Now the text not showing up because of the font size. Let me decrease it. You see how now I can have good or bad. I can change the colors of this, like I'm putting it in blue to get more attention. That's one quick tweak that you could do. Another thing that you could do is probably if you want all this on the other side, instead of minus 20, right? Let's see what is the maximum value is 160. Let's do 170. You see how now all my data labels came to the other side? I have good, good, bad, good here. So quick thing that I want to tell you is just by playing around with the measures and with all the settings in your format pane, you can achieve lots of interesting things like this. And all of this is very dynamic because obviously it's Power BI. With that being said, I think I am on time. Thank you to everyone who attended my session. Make sure you connect with me on LinkedIn. I keep sharing all these little tricks here and there. If you want the PBIX for this and you want to practice it, reach out to me on LinkedIn. I'm more than happy to share. Let's quickly look into the questions. If anyone wants to add in some comments, please go ahead. Rashmita had a
Yes,
question
let
in.
me.
Yes, let me know. Okay, just quick two questions, and then I'm going to just answer the questions in the chat. Let's start from the bottom. Thank you for the comments, guys. Varun asked the question: how does Power BI internally optimize rendering of native visuals when handling high cardinality? What best practices would you avoid? Okay, the first thing is, so whatever I showed you right now is just for small reports, like 2 to 3 pages of reports. And then if you have more values, all these things are going to take more time to load up. But these look really good. Now, the best practice is what I would say is, you remember like how I created all these measures, different measures. Try to have measures that work for many visuals together instead of creating every measure separately for visuals. So reusable measures is how you can make sure that performance is not hit. That's really important. And the demo file, like I said, reach out to me on LinkedIn. More than happy to share it with you. And thank you to the moderator for sharing the profile link. Rashmita had a question. Great question, actually. Oh, where is it? Just scrolling up. In a large scale dashboard with thousands of categories, how would you decide between bar charts, lollipop charts, or other two performance in the user cognitive? First thing, it always depends on the end user. If the end user is not a fan of pie charts, do not use it. If the end user likes seeing tables, go for it. So it's basically the user's decision. When it comes to readability, small things like, and again, it depends on the end user. The clients that I work for, they do not want tooltips. They don't want to go ahead and keep checking everything. They want everything on the dashboard because their work is to take screenshot of this and send to the higher executives. So everything depends on the end users. You as a developer need to know how to do things. Like remember I told you, like if I want to add icons on the other side, how can I do? Immediately it should come to your mind, add a negative value, throw in my values there. As simple as that. With that being said, I just want to say thank you. And hope all of you have a good day. Bye bye.
Yes, Lakshmi. So I was about to ask questions. Okay.
Yes, go ahead. Go ahead.
Yes. I was about to ask questions, but you have covered most of the questions that are in the chat box. And you are right, actually, it is not the limitation of the tool. It's just that we just need to redefine our thinking and approach the problem differently to solve it. That was great, actually.
Absolutely. Yes,
Yes.
absolutely. You're right.
So, and the demo that you have shown, different types of charts and everything is really exciting. Thanks for your wonderful session. Yes.
Thank you. Thank you, guys.
Thank you.
Thank you,
And-
Lakshmi. Thank you, everyone, for long 2 days of this conference. You have been there. Some of you have almost attended one particular room completely and made this event successful. And Lakshmi, thank for giving couple of sessions to us. I know I reached out a little late to you, but still you made a couple of sessions. And I think I was looking forward to this Power BI visualization session because I know you are one of the expert in making the visual work they we cannot imagine about that in a day to day. And I'm hopeful everybody got benefited from this session as well as all the sessions what we have done. Thanks a lot everyone for doing it. Thank you to all the speakers and moderators who have supported us for this conference and making it a great success. We hope to see you soon. We have a next in-person planned in Indore, and followed by we will have few more in-person events in Hyderabad and Bengaluru. So stay in touch on social media forums and WhatsApp for the information. Thank you everyone. Thank you, Lakshmi.
Thank you.
Thank you.
I'm going to post the links and then we'll wrap it up.